is nothing but the IDE integrated development environment that I use, which is IntelliJ. All the IDEs are pretty much similar. So IntelliJ is similar to Eclipse. So it's coming up. So basically what you do is you have to select a workspace first. Workspace is nothing but all your program, all the class files, all the class and everything that you write would be put into this particular workspace. And you can create a new class and start off. So when we get to the Hello World program, which is the first program that we are going to talk about, it would give you a clear idea on what we are talking about. So let's talk about Java internals, how it looks like, and all the features that we spoke about. So basically, so far what we have covered is more about Java is an object-oriented program, or it uses object-oriented programming paradigm, which is nothing but everything is thought of as a class with a particular state and behavior, right? It's platform independent. That's why it's been widely used. It's secured as well. That's why it's been used in banking applications and stuff. It's good for distributed computing since it's platform independent. You just have to write it once and you can run it everywhere. So basically, this platform independent aspect is what helps it to be widely used in big data applications. So let's talk about the internals. So what is JVM? JVM is nothing but, again, it's a specification, right? You could have your own JVM. Sun by itself gives specification for a JVM. This is what the JVM should be all about. So I could create my own JVM, but we use the reference implementation of Sun Microsystems or Oracle now, right? So JVM is a virtual machine that runs the bytecode. So basically, there has to be some level of compilation done before JVM can understand it. So that's where you have Java compiler. And so what this does is nothing but it takes your source code, it takes the class files as, or it takes the class that you write as is. So Java compiler would consume it and kind of compile it into a dot class file. So dot class file is nothing but compressed version of it and compiled version of it as well. And this dot class file is nothing but it's also known as bytecode, and this is what a JVM could understand. So once you have this class file, it could be sent to the JVM and JVM could understand it and run the applications. So what makes Java platform independent is this Java compiler is platform independent. You don't have to take care about it. You just have to run the compiler. And whenever you want to run this particular bytecode on any of the machines, you just have to have JVM for that particular machine, right? So basically, if you want to have on Linux, right, if you want to run it on Windows, you would have JVM installed on Windows, or you would download the JVM for Windows. And if you want to run it on Ubuntu or the Linux or Mac, you would just have to have the JVM downloaded for that particular platform, and it should be able to sense this particular bytecode. So basically, this is what makes it platform independent, right? As I said, once you have this bytecode, once you compile it, this bytecode could be transported or ported into any of the machines, any operating systems, and you should be able to run it. That is what it is all about. It's write once and run anywhere. So as I earlier mentioned, you could just get this class file into your pen drive and take it anywhere, and you could just plug your pen drive and just run through. That's how simple it is. So this is Java runtime environment wherein you have a set of JVM plus you have libraries. Libraries, it is nothing but, all the programs put together, all the program source code for Java put together. So rt.jar is one of the libraries which would have most of the classes, or you have util classes, maybe string class. String is a class itself, which is exposed by Java. So this particular jar file, or it's a Java archive. Jar is nothing but Java archive, which is set of Java classes, or the class files rather, which would have a lot of class files within. So in rt.jar, you would have something like string class and stuff like that. A lot of other classes which is being used by the system, or which is being used by Java itself. So basically in JRE, this is what you have: JVM plus set of libraries plus other additional files. So as spoke, JVM is nothing but specific to environment, but all these things like rt.jar and stuff like that would be independent. JRE does not contain tools and utilities such as compilers or debuggers for developing applets and application. So JRE by itself is a runtime environment, so it doesn't have compilers and stuff like that. So JDK is nothing but it's specifically for development. You could see here it's JRE plus development tools. You have compilers and stuff like that as well. So to run a class file, you just need the JRE, but if you're a developer, you would need JDK. So what we downloaded earlier, if you remember, that was JDK, right? JDK for Windows or JDK for Linux. So basically, if you see this one, you could see here as JDK. So essentially, you need JDK only if you are a programmer. If you just want to run the class file, JRE would suffice. So what is JDK, JRE, and JVM? As we spoke about, you could see JDK is a superset. It has everything, right? JDK would have your JVM plus it would have, as we spoke here, it's JRE plus your development tools as well. As you could see here, details, it has everything here. It would be really confusing right now if you directly get into what all this is all about. But basically, you could imagine JDK is a superset and JRE is nothing but it's your runtime environment, which has JVM and some additional files, or rt.jar as we said, which is nothing but set of files, set of class files that is exposed by Java, which could be used, like string, for example, right? Let's see how it works. So basically you have your source file. So this is what a developer would typically write, would create a .java file. So whatever you write, you create a class, you just create a new class and write something to it. What you get is .java. You get the extension .java. So basically this is your source code, whatever you write, you as a developer would write. This class files would be sent for compilation, or whenever you are good enough done with your coding, you would compile it. And once the compilation is done, once everything looks good enough, once the compiler doesn't mark anything and doesn't flag anything rather, which means everything is syntactically right, you would get Java bytecode, which is nothing but .class file. Now this .class file could be moved across network, or you could, as I said, you could just put it in your pen drive and can take it anywhere. And you could run it on any of the environments. You just have to have JVM. So basically you could run this class file, which is compiled on Windows. You could run it on any of the environment, any of the platforms. So this is something that we spoke about during runtime. There's a verification as well. So when class loader would load this particular class file, it would ensure that it is up to the mark or it's not manipulated sort of. So if at all it sees something wrong, then it would flag it off as, corrupted file or something. So this is nothing but Java class file libraries, rt.jar that we spoke about, Java archive. So this is what is happening when you run a particular class file, right? So you have this class loaded and then you have this compilers, just-in-time compiler actually running it for you. So basically it's a part of JVM. So JVM is, remember JVM is nothing but it's a platform. It is specific to platform. So basically for Windows, you would have a different JVM, and for Linux, you would have a different JVM. So yeah, you get this class, you load this class using class loader, and you run through the application or run through the class files. So typically this is how Java operates. So just to give a gist on this one, so you have a source code, you have .java file written, you compile it, you get a .class file, and you can port this class file anywhere. You can run this class file anywhere on your network or wherever you want to. You just have to take this class file, and on the machine on which you run, what would happen is you load this class file first using class loader, and with JVM would have just-in-time compiler which would run a particular class for you, right? So what we are trying to do here is you're running the source code that's written on any environment. You're running it on any other environment. So basically you could write this on Windows. You could write source code on Windows, but you could run it on, say, for example, Linux. So that is what makes it platform independent. So yeah, let's create one class. And as we create it, I'll talk more about it. So you could open up your Eclipse and could create something like new project. So it could be a bit different for you. The look and feel might not be exactly the same as mine, but you just have to create a new project. Select Java. So basically I put a project name, so whatever you want to. So basic nomenclature is like it has to start with uppercase letter, which is camel casing, right? So you should follow camel casing when you, that's one of the best practices. It won't flag you as some error or something, but that's a normal industrial practice that whenever you create a Java project, it has to use camel casing. Create Edureka Java. So it's creating a project for me. And as you can see here, I have this particular project being created, right? Now what I do is I create Java class. So basically, as we said, everything could be seen as a class, right? That's what object oriented is all about. So basically what I would do is I would create a class here. So this is my source folder wherein all my source class would be there. So as you can see here, new Java class. So say I create com.edureka. So this is nothing but your namespace of the package, right? So you could give whatever you want to. Basically, this is to avoid collisions, right? If we don't have a namespace, there would be a lot of collisions within the class. So there are a lot of people working on the same project, right? So I could create a class with name class A, and the other person might create class A as well. So when this is clubbed together into one particular application, there would be a collision. So to avoid this, basically what you have is you have a namespace. So I would write as com.edureka.class A, and the other person would write something else, and that would avoid class name collisions or class collisions. So this is com.edureka is my package or namespace, and hello world is my Java class name. So as you could see here, there's a package com.edureka, which is again a namespace. And there's a class by name hello world that's been created, right? And if you want to see, you could actually go and so you can see a folder structure created here in the source. So this is your source folder, right? Within your project, there was a source folder wherein we created the class. So if you go to the source folder, you could see a package structure or you could see a directory structure being created, which starts with com, and within com you would have edureka, and here you can see hello world.java. So remember we said that your source code would have all the Java files. So basically this is what I was referring to. This is a method that's a default method that's been called. So when you run this particular class file, JVM would actually look out for this particular method. So you need to have the same signature as is. So you would have a main method wherein your program execution would start, right? So as in when you compile it and run the class file, so basically when you compile it, you would get a class file, right? And when you run this class file, JVM would check out for this main or a method that has the same signature as this one. That's a main method. And your program execution would start running from here. So basically it's an entry point for your execution, right? So this would be a simple program wherein we would just print hello world. So basically you have like system is a class, and this is how you print in Java. So I don't want to confuse right away by saying what is system, what is out, and println. But basically what you have is system is a class. As I said, everything could be imagined as a class. So in Java, everything is a class. So basically you could just click here and you could see the source code of it, right? This is the source code, and this is coming from rt.jar. Remember in JVM we spoke about in JRE we had rt.jar, we had JRE, we had JVM plus class files. So all this has been written by Java, by the Java community. So basically you can see here this system itself is a class. So out is an instance variable and println is nothing but a method within out. So what this statement, particular thing is doing is nothing but writing it onto your console. So let's print hello world. So basically when you build a project, it's compiling it. As you could see here, it's saying it's building it. So once it has built it, you could see a class file here, right? So you could see here hello world.class. This is because we built it. When you build it, your Java file would be compiled by your compiler and it would create a .class file. And remember, as I said, this .class file could be run on any machine. So this is Windows machine that have written this file, Java file, and compiled on. Now this .class file could run on Linux or any platform that you want to run it on. So let me talk about this class, right? So you have a public keyword, which is nothing but access modifier, which gives visibility. So basically what we are trying to say here is hello world is could be publicly seen. So it could be seen anywhere within the application. So basically for class level, you have public, which as the name suggests or as the name gives out, it could be seen anywhere within your application. That's a visibility key access modifier. All right, so you have the keyword class here, which is for the class. You need to have it mentioned as class. If you write something else, then it would give you compilation error. So it has to be exactly the same. All right, that's the syntax of it. Hello is nothing but the name of your class. Then you have this public static void main, which is nothing but, as I said, this is the entry point for your application or your class file. So when you run this particular class, it would start off from here. You have a static keyword. Static keyword is nothing but it's at the class level. So basically you need not create instance. We haven't reached to that point yet. So basically hello is a class and you could create instance of hello, which is nothing but object, right? So when you have a static keyword here, you need not create object of hello to run it. If it's not static, then you need to have object of hello created. So basically what I'm trying to say is, say you have one more method here, which is test. Now this doesn't have a static keyword here. So basically what we can do is we can print. So yeah, this is a non-static method, right? Now we cannot call it directly. If it's a non-static, you need to have an instance of hello world created. So basically how you create instance is nothing but hello world. That's your hello world object. So when I say instance, I'm talking about creating object, right? And you could create new hello world. So object of hello world is created using new keyword, right? When you do this, you would get an object of it. Or now what I do is, so basically what I was trying to say is you cannot call test as is. If you do it, you would get a compilation error saying that non-static method test cannot be referenced from a static context, right? You cannot call it without having your object. So basically I can call it on hello world object dot test. Now I can call it. Now it doesn't give me compilation error. I'll create one more static method which would give you some idea. So I'll rename this as non-static test and this would be static test, right? And we are printing a static method and here we are printing non-static method. So hello world dot non-static test. Now whereas the static test did not be called using object, so we could directly call static test. Sorry, I haven't written static here. So this is a static method. Okay. So now you could see here it compiles fine, right? So what I was trying to say is when you have a static method, you did not have an object to call it, whereas non-static method, you need to have object. That's what the static is all about. Then you have void is nothing but the return type. It's not returning anything from here, so that's why it's void. You have main method, that's the keyword, that's the entry point for your application. You have this arguments. You can see string array of strings, which are arguments provided to a particular program. So you could pass on as many arguments as you want. Or if your program is, say for example, you want to pass your name as an argument, you can do that. So this is arguments. Then we have main, which represents startup of the program, which I already mentioned. Then we have system.out.println is nothing but the print statement. So as I mentioned, system is nothing, everything could be thought of as a class. System is a class, out is an instance variable, and println is a method within out. So basically you don't have to think much about it. Just to understand the structure of it, just to understand how a particular class is being written, this is what we have. This is how we write a class, right? Again, just to brief on this, you have access modifier, which denotes the visibility of a particular class. You have the class name, you have the main method, which is nothing but the entry point for your class. You have a static method, which says whether you need an object to call a particular method or could be called directly from a class. You have a return type here. So this is how typically any method would be written, and you can write whatever statements you want to within this particular method. This case, we have printed out hello world. So basically you could follow this when you do it on Eclipse. So it might be a bit different based on the Eclipse version that you would have, but it should be pretty much similar. All right, so you create a new Java project. So I showed this already on IntelliJ, which is also widely used IDE, but yeah, you could use Eclipse as well. So basically you could see the project name being written as hello world, right? And here it mentions the JRE to be used. So here you can see class being created. And let's see how we can run this. So we compiled it and we saw that dot class file was created. Now we can run this. So as I said, main is the entry point. So it would start running from here. So your program control would come here. And the first thing that it would see is you have printed hello world. So it should print this one. Then I would keep it simple. I don't want to, let's see what's been printed here, right? So you could see here hello world being printed first, right? This is where the program execution started from. So it came to main, saw hello world, it printed out hello world. Then you gave a call to this non-static method. So it printed non-static method, which has been printed in this particular method. And then it gave a call to static method, and you could see static method being printed here. So one thing to remember is the program execution starts from main, and it just executes this main method. So whatever content you want to write, you would basically write it in the main method. So you could see here hello world being printed out. Now let's see how easy it is to code the same in the J shell. So J shell is nothing but shell prompt that was created in Java version 9. Since 9 you would have J shell. So since I have Java version 12, I should have J shell as well. So yeah, J shell is nothing but a prompt. So it's nothing but instead of writing into integrated workspace, you could have J shell and you could try out something here. It's not something for production use as such. It's basically to test something, right? You as a developer could, if you want to see what it does, instead of writing everything into the main. So if you write a class, you would have to write things into the main and then run it and stuff like that. With J shell, it's just a kind of interpreter wherein you could write something, some command and see what the output is. So basically you could say, for example, we printed hello world, right? So system.out.println hello world, right? If you remember, this is what we typed into our main method, right? So if you want to run this, you have to have all these artifacts created as is, right? To have a class, you need to have main method and then build the class and then run it. Basically in JShell, you could run it just to see what's output, right? As I said, this is not an application as such. This is just for the developer to test what the output for a particular command would be. And what are modifiers in Java? So one thing that we saw in the program was access modifier. We already saw about actually this one, right? Public, and we saw public here as well. So these are nothing but modifiers, right? Public, as I said, this public means it's an access modifier which shows that hello world could be accessed anywhere throughout your application. So here we can see it's a word or a phrase, changes meaning of other phrase in some. So basically it's just trying to say that one of the aspects or one thing that access modifier could be used is to control the visibility of a particular class or a method as well. We have an access modifier for your methods as well. So this is just one of the things, right? We would see other modifiers as well. Modifiers in general has some other things as well, but when it comes to access modifiers, it basically controls the visibility of a class, visibility of a class or a method. Or so yeah, modifiers here, as you could see, there's access and non-access modifiers. Let's see access modifiers. So we used public already. So this one is nothing but a access modifier, which is public, which says that it could be used throughout the application. So visible to the world, as it says. Public is nothing but visible to the world. If we talk about chronological order, if we talk about the visibility, so default is visible to the package. So default is nothing but within the package, it would be visible. So basically you could default is without any keyword, without any access modifier. That's a default scope. So within the package, it would be accessible only within the package. So you have like com.edureka, that's your package, right? So this hello world would be accessible if it has a default scope, it would be accessible only within com.edureka. If you try to access it from some other package, you would get an error. So that's the default visibility, visible to the package. Private is nothing but it is visible to the class. It is only visible to the class. So this is the lowest visibility, only visible to the class. If you try to access it from outside class, even within the same package, you would get an error because you won't be able to access it. It is accessible only within the class. Public is accessible to the world. It could be accessed from anywhere within your application or anywhere within your wherever your class file. So basically if you have a jar file, but what I'm trying to say is public is accessible anywhere, right? Protected is again visible to the package and all the subclasses. So we'll talk about subclasses. So subclasses is nothing but in C we have inheritance, right? Say for example, integer. Integer is a class. So as I said, in object oriented paradigm or in Java, everything could be visualized as a class. So integer itself is a class, right? So there's a number, there's a superclass, which is number, which has all the common state and behavior that a particular number would have, right? So number is a superclass and you have subclasses like integer. A float would be a subclass of number. Long would be a subclass of number. Basically, this is inheritance, right? You are inheriting integer, float, long, double, and everything from number class. So number is a superclass and all this integer, float, and everything is a subclass of number. So when it comes to protected, it says that it is visible to the package and all the subclasses. So just to keep in mind, as of now, you can think of access modifier as visibility of a particular component, or could be visibility of a class or visibility of a method or an instance variable as well. This is what drives the encapsulation factor of object-oriented paradigm. So basically, we control the access for all these components, or we control the access of class, variables, methods, and everything, which makes it encapsulated. Cannot be breached, sort of. as we could see, this is like I could make this one as default as well. All right, so this is default scope. It would still run because it's within the class. Right now, suppose I make this one as private, right? Just to show you what this encapsulation is all about, or what this access modifier is all about. Suppose I make this one private, right? Still this one runs because it's within the class. You are trying to access it within the class. Now I create a new class. Say for example, we say access modifier test. So I create a main class here again, main method. Now suppose if I try to run this, right? So basically I create the same stuff here. Say I create a hello world object. Okay. Now this one is private, right? Now if I try to access it from here, what I was trying to say is if I so as you could see here, it says that non-static test has a private access to hello world. So you cannot use it from outside. That's what I was trying to say. So basically, since it has got a private scope, you cannot access it from other class. And if I remove this private now, which gives it default scope, and as we said, default is nothing but it has got access within package. You could see this error going off here. Now it is accessible, right? So that's what it is all about. When you have a private scope, it's within a class, whereas default is within a package. Public is accessible anywhere and protected is visible to the package and just the subclasses. So let's talk about non-access modifiers. This is not controlling the access of class, method, or variable. When it's static, you need not create object of a class. So basically for static test, you could see that we didn't create object of a class. We didn't call static test on a particular object of a class. It could be called directly. That's what static is all about. The static modifier for calling methods and variables without an object to which it belongs. As we saw, we didn't create an object of hello world. We directly call the static method. Final is nothing but you can't change it. Final, as the name suggests, you can't change it once it is created. So finalizing the implementations of classes, methods, and so this is nothing but instance variable, which we would be talking about the slides to come. Just to tell you, this is an instance variable which we have assigned the value 10. Now suppose within this particular method, I try to change the value to 11. You would get an error saying that cannot assign a value to a final variable. So final is like it's final, can't change it. Once you have created it, you can't change it. But if I remove this final, you could see this error would go off. You don't see this error anymore. Whereas by putting final, you would see this error. So that's what final is all about. So basically, this is good enough for constants, right? So if you have constants within your class, you would make it final so that no one can change it. Abstract is nothing but you could mention it as abstract when it doesn't have implementation of all the methods. So what I'm trying to say is abstract modifier is again a non-access modifier, and what it tries to say is, say for example, you have a shape class. Shape class is an abstract class because shape doesn't say you want to calculate area of shapes. So basically shape class by itself wouldn't know what the area of the shape would be. Shape is a class wherein it's a generic class. It doesn't know what the implementation of area would be. For square, it would be side square. For rectangle, it's length into breadth. Or circle, it's pi r square. So basically shape by itself wouldn't know what its area would be. But now shape is a superclass, and say you have subclasses of it, like square, you would have circle, and so on. So now basically you want to ensure that when you create a subclass of the shape class, you want to ensure that that particular class implements the area. That's when you create it as abstract. So the shape method would have, or the shape class would have area method as abstract, which would be implemented by the subclasses, which has to be ensured. It's kind of ensuring, or if the subclasses don't actually implement it, you would get a error. So basically circle would have its own implementation of area saying pi r square. Square would have its own implementation saying side square. So basically what I'm trying to say is area is a abstract method for shape class. And when you have an abstract method, the class itself is abstract. So you have like shape com.edureka.shape. I'm creating a class. Now I'm creating an abstract method. So when you say abstract, you don't have to provide implementation. It's just generic this thing. You don't have implementation of it. You just have the signature of it. So basically, as I said, when you have an abstract method, the class itself should be abstract. So we'll have to make this abstract as well. So you created a shape class which would have an area and which would give you this thing. So basically, if you want to have subclass, I don't want to show how the subclasses are created at this point, but basically this is what abstract is all about. You don't have the implementation of it, but you're ensuring that subclass is implemented. So here you can see it's just a signature. You don't have implementation unlike this. Implementation is nothing but if you write something within these braces, this is an implementation for this particular method. Whereas in shape class, you just provided the method signature, but we don't have implementation of it. So that's what abstract is all about. Synchronized and volatile is much about used in threads. Synchronized is we are saying that only one thread could get a control at one point. So as we said, threads are nothing but parallel execution. You could have thread, say for example, you could have thread one calling a method. So we have a non-static method test, right? Say this is a method. So what we are trying to say here is if it's synchronized, we can make this as synchronized, private synchronized. So this is what ID is all about. So when you have this integrated development environment, you don't have to type everything. When you type SY, you could see synchronized coming up here and you could select it. So when you put a synchronized here, what we are trying to say is only one thread could access it at a given point. Only one thread at one point. So if multiple threads are trying to access it, one thread has to wait for it. So only one thread would get an entry to this and the other thread should wait for it. So that's what synchronized is all about. And volatile, it's basically for memory visibility, or what we are trying to say is, so basically every processor has got its own cache. So what we are trying to say is when you use a volatile access specifier, don't store it in cache, store it directly into the main memory so that all the threads would get the most recent value being assigned to a variable. And also volatile is not needed when you have using synchronized as such. So it's mutually exclusive. So let's talk about variable. So variables are nothing but it's a holder, right? It holds value, and variables are nothing but it's reference to that particular or it's a address or something that is pointing to a memory location where the values are being stored, and you could access it using this particular variable name, or you could access the memory location where the value is stored using a variable name. What I'm trying to say here is, so this is a variable and you could access, so this 10 is stored somewhere in the memory and you could access this part of memory location where this 10 is stored using this variable, or you can manipulate it as well. You can change the value. So basically there are three types of variables in Java. There's local, instance, class, or static. Local is nothing but local to your method. Whenever you have a method or you kind of create a variable within a method, that is nothing but local scope, which is like it has the access, its visibility only within that particular method. Once control goes out of this method, you can no longer access this particular variable. That is local. So if I define something here, say for example, I define something here. So this is a local variable since it's defined within a method. So once the control, you would have this only within this particular method. Once the control goes out of this method, this is no longer accessible. Basically, this is where garbage collection for Java is useful. Once your control goes out of this particular method, garbage collector would kick in and would clean off this variable or clean off this particular memory location, or would make it available for use. So that's the local scope. The next one is instance. Instance is nothing but something that is defined at the instance level. So this is instance variable. So since it's at the class level, right? This is, you could see it at the method level. This is at the class level. So this is nothing but an instance variable. Now there is static variable as well. So this is how you define a static variable. So instance variable is nothing but it's per instance. So you could go and change this instance variable to something else. Suppose I assign a value 40 here. Now I could have one more object created. Suppose I call this object 1 and I have hello world object. So I create one more object here. So what we are trying to do is we are trying to change the instance variable through objects. So basically this is what it is. When you have an instance variable, normal instance variable, which is non-static, you could access it through objects, right? So through object one, you assign for object one, you assign instance variable value to 40. For object two, then you change the instance variable value to 50. I won't say changed it, but you assigned it. This is how you deal with instance variable. It's at the instance level. It's at the object level. Whereas for static, it's at the class level. It's one per class. It's not one per instance. It's one per class. So basically what you can do is you could do something of this sort, wherein it's at the class level. It's not at the object level. You are assigning value 100 to a static variable. So as you could see here, it's not a particular instance that you're operating on, it's the class directly. Just to give you a gist, we have local variable, which is within a particular method, and scope remains within a method. Once the program control moves out of this particular method, Java would or JVM would come in and kick in garbage collector to clean this off. It's only accessible within this method. You have an instance variable which is at the class level, but it's non-static, and which means that it has copy per object. When you have multiple objects, you could change the values the way you want per object. Static is nothing but one per class, and as you could see here, we changed the value of the static variable to 100 through class. So that's about variables. We have an instance. So instance variables are declared in a class when the space is allocated. I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a teacher instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is created with the use of keyword new, and destroyed when the object is destroyed. So unlike local variables, which is within the method scope, instance variable is within the class scope. So basically, whenever you create an instance of a particular class, your memory would be allocated for that particular instance variable. And whenever it's done, whenever it's destroyed by the garbage collector, it would go off. Access modifiers can be given to instance variables. You could have like private, public, protected, default. All the access modifiers be assigned to an instance variable. So basically you could have it as private. Private is just within this class. You cannot access it outside this class. You could have public as well, which is like could be accessed anywhere within this application. You could have protected, which is like within the package or the subclass, and you can have the default one, which is nothing but package access, which would be accessible just within this package, that is com.edureka. So instance variable have default values. For numbers, the default value is 0. For boolean, it is false. And for object references, it is null. So values can be assigned during the declaration or within the constructor. You could assign values directly while declaring it, something like this. Instead of 0 is the default one for integer, as they have mentioned. But yeah, you could assign, if you put it as 10 here, it would be taken as a default value instead of 0. Constructor is nothing but a method which constructs an object of a class. Values can be assigned during the declaration or within the constructor. Instance variables can be accessed directly by calling the variable name inside the class. However, with static methods, when instance variables are given accessibility, they should be using fully qualified name. So what we are trying to say here is this is a static method from which we are trying to access instance variable. In this particular static method, you need to have object reference. This is the object that we created. So object reference dot instance variable, you need to have, as we have mentioned here. So here, as we can see, object reference dot variable name, you need to have fully qualified name. When you try to access it within the static method, you need to have fully qualified name. Whereas here within a method which is non-static, this is non-static. Here I can access instance variable without object reference. So here, as we can see, it could be accessed without. But if I do it here, it would throw me an error. It's not accessible here at all. Non-static field instance variable cannot be referenced from static context. Instance variables are not accessible directly here. It has to have fully qualified this thing, which is object reference dot instance variable. Whereas when it's called within non-static method, you could use it direct. So static, as we spoke about, it's one per class. So it's declared using static keyword. So static variables are stored in static memory. It is rare to use static variables other than declared final and used as either public or private constants. As we said, it's mostly used for constants, and static variables are created when program starts and destroyed when the program stops. So one thing to remember is it's one per class. It's not one per object. Instance is one per object. You have a copy of that particular instance variable, one per object case of instance, whereas case of static, it is one per class. So the scope remains, or the life cycle remains, right when the class is loaded till the program is stopped, till the class is unloaded. Static variables are declared public since they must be available for users of the class. It's not mandatory though, but usually if it's a constant, it is declared as public. Static variables can be accessed by calling with the class name. So we saw here class name dot static variable. So how do we decide what amount of memory is to be allocated? So these are the data types that we have. So each variable in Java has a specific type which determines the size of memory, the range of values that can be stored, and the set of operations that can be applied to the variable. Data types can be categorized into two major types, primitive and non-primitive. So basically primitive is not object. Primitive is supported by language itself, which is kind of, it has got 8 primitive, or it's predefined by the language and named as keywords, and it has 8 primitive data types, that is byte, short, integer, then you have long, float, double, character, and boolean. This is pretty much similar to other programming languages that you have. Byte, it consumes one byte. These are 8 primitive data types that are predefined. Non-primitive is nothing but string. String is an object itself, so that's something that is non-primitive. Or if you define your own class, say student for that matter here, right? We have defined student class, that's non-primitive. So this student class is non-primitive. We have strings for storing string, which is again kind of non-primitive. We have arrays, or basically it's all called as reference variables, since we're referencing a particular memory location through variable name. This is where we have table showing byte consumes 1 byte and its range is from -1 to 8 to 1 to 7. Short is like 2 bytes, and you could imagine that it would be from -32768 to 32767. So it's pretty much similar to other programming languages that you have, like in C as well, we have similar to this thing. One thing is character takes 2 byte, and C it takes 1 byte, I believe, though it doesn't use all the 2 bytes every time. It depends on encoding type. So Boolean is 1, which is true or false since it has to store 1 or 0. So yeah, it's pretty much similar. So just to talk on the bytes required, byte is 1 byte, short is 2 bytes, integer is 4 bytes, long is 8 bytes, float is nothing but it has decimal values stored, signed decimal values. So it again consumes 4 bytes. Double is signed, again float values or signed decimal values, which consumes 8 bytes. Character is 2 bytes, and Boolean is 1 bit. So basically, to decide whether to use float or double depends on the nature of the application. So if you want to have more precision, or if you want to have more range, you could go with double. So non-primitive or reference data type is a variable that holds a particular object or holds bit that represents a way to access an object. It's a pointer to a memory location basically. So as we spoke, Java doesn't expose the pointer directly. It doesn't give you directly pointer to the memory location, but it gives you the reference variable. So you cannot manipulate memory location directly. You cannot add some values to the memory location through pointers or something, but through reference variable, you can access it and assign some value. So yeah, it does not hold the object itself, but it holds a reference address to the object. The reference type does not have size or bit range. So here we can see string str is equal to edureka. So the one shown in red is actually the memory where edureka is stored. You have a reference and str is the reference to it. So here we can see variables and data types. So we have a main method again, and we have byte. We declare a byte here. Byte b is equal to 10. Short s is equal to 20. So I think it's pretty straightforward. You kind of have this data types created. You just have to assign values to it. These are all primitives, as you could see. Till here it's primitive. So you could see that values are being assigned and it's been printed out here. So I think it's pretty straightforward. You can assign a value to a variable and just print it. So again, we use system.out.println for printing it. You could try it out on your own. You could try it out this data type program. You could just assign something and just try to print it out. We are talking about data type conversions. So we have implicit and explicit conversions. In some case, programmers don't have to actually write explicit conversions from one data type to other, but in many cases, programmers need to. So the arrow in the diagram shows the possible implicit type casting that are permissible with primitive data types. It's just with primitive data types, right? As the diagram shows, int can be converted implicitly to long, float, double. Since int takes less space, it could be applied to any of the numbers. For vice versa, they have to be converted explicitly. Whereas if you want to convert long to integer, you have to mention it explicitly. So basically, we are talking about when you're trying to store integer into long, integer takes less space and long takes more space. So it can be easily accommodated. Since long takes more space, if it is more than the range of the integer, it wouldn't know how to assign it to integer. So that's why it has to be explicitly converted. Implicit conversions, we can on the J shell, you could type this. So here what we are trying is we have a character C is equal to A, and you could see C is assigned A. Now integer K is equal to C, which could be done. You could assign character to an integer. So basically it's a ASCII code for it. So 97 is the ASCII code for C, which would be assigned to K. So now when you assign C to float, which works as well, so you get 97.0. You could assign character to long as well, which is 8 bytes integer. You could assign double as well, which is 8 byte float, and you could see. But it cannot be done the other way around as we spoke. So you cannot have integer or you cannot have double assigned to character. So it would give you incompatible or possible lossy conversion from double to character. It has to be explicitly done if you want to do that. Need of type conversions. So here we have integer a equal to 100, initiated a variable with type integer. Then you have a string b, which is assigned value hello. So basically here you can see string being used, which is a reference variable. And you have string s is equal to a plus b. S equal to a plus b, then it adds up like 100 plus. Since hello is a string, it would concatenate it. So you could see 100 and hello being concatenated, and you could see 100 hello. The data type of both the variables are different, but to perform any operation, we need both the variables to be of same type. Here, integer value is converted into string and gets concatenated with other string. So basically, had b been an integer, you would have got addition of it. Say for example, integer b is equal to 200, and if you 100 plus 200, you would get 300. But since it's a string in this case, 100 is converted into string and it's concatenated with hello. Explicit type conversions. We saw the previous case wherein double was being assigned to character, which prompted us with lossy conversion. So this is similar to that. So basically here what we are trying to do is we are trying to assign double to integer. So you have double, d is equal to 45d, which is 45, right? Again, double is 8-byte decimal signed decimal number. So you assign 45 to it. And now we are trying to assign this double value to integer. So it's possible lossy conversion. But you have a provision to typecast it. So basically what we are trying to do here is you're trying to assign again double to integer, which is possible if you typecast it. So when I say typecasting, it's nothing but opening parenthesis, then the destination data type, then your data, actual variable. So basically to the right side, you could see that through explicit typecasting, we can assign double to integer. So casting may lose information. For example, floating point values are truncated when they are cast to integers. Example, the value of d, that is 45.5, when converted to integer gives 45. So we could see here in the bottom, like the double, we assign the value of 45.5 to double, but when we converted into integer, we got 45. 0.5 was truncated since integer, since the destination data type that's integer doesn't store decimal values. Now this is like type conversion methods, which is there in your wrapper classes. What we are trying to do here is we are trying to convert 23, which is string, into integer. So you have a string s is equal to 23. You assign the value 23. So mind you, this is string right now. We have integer dot parse int, and we pass the string, which would be converted into integer. So this integer class that you see here, right here, is nothing but a wrapper class. You have string into integer, which is nothing but integer dot value of string, which converts it into integer data type itself. So as you could see, the destination is integer. Now integer to string, you have an integer. We have a toString method which converts integer into string. So basically you have integer I, which has been assigned 23. Now you have integer dot toString I, which would convert this integer into string. We have one more method, which is string dot value of, which would also convert integer into string. Let's talk about operators. Operators are nothing but it operate on these data types. So you have unary, which is kind of pretty much similar to what you have C, C++. You have postfix and you have prefix. Postfix is I++ or expression++, and the operator is after the variable, which means that it would be assigned value and then it would be added. Prefix is before the operator, which would be added first and then assigned, or the operation would be done first and then assigned. That's prefix. Arithmetic is pretty much similar, like multiplicative. You have like multiplication, division, and mod. You have additive, which is plus and minus. You have shifting operation, which is bits shifting to the left and bits shifting to the right. You have relational operators, less than, greater than, less than, equal to, greater than, equal to, instance of quality of two data types or two variables. We check whether they are equal and not equal. We have a bitwise and, bitwise XOR, bitwise inclusive OR, which is happening at the bit level. We have logical and, logical OR. So basically this is for conditions, right? If you want to have like two conditions, like if int I is greater than 0 and int j is greater than 0, sort of, you add or you have logical ANDing between two conditions, logical conditions. Or logical OR, pretty much similar to other programming languages, like it's OR between two conditions. We say that either this or that. We have a ternary operator which says that if the condition matches, we would have a condition followed by question mark, followed by colon, and we would have some value followed by colon, followed by some other value. So what we are trying to say here is if the condition is true, assign value 1. If the condition is false, then assign value 2. So instead of having it written in if else, you try to put it within ternary operator. So basically this is when you have simple assignment operator. If you have a logic, if you have some particular logic being written, it would be a better practice to have if else so that it's readable, right? Because ternary operator, it would be very difficult to actually read through. We have assignment operator, which is equal to, which is plus equal to, is nothing but adds the value on the right hand side to the left hand side and assigns it to the left hand side variable. Minus equal to does the same thing. It kind of subtracts value to the left hand side from the value to the right hand side and assigns it to the left hand side. So I believe this is pretty much similar to other programming languages. There's nothing different in this. We might have used it somewhere or the else. Should be pretty much simpler for you guys. So let's see unary operator example wherein x is equal to 10. So you could see x being assigned value 10. You have x plus plus. As we said, it assigns first and then increments it. So you could see value 10 here again. So now if you, after this, if you print the value of x, you should see the incremented value, that's 11. So that's post increment. So let's see pre-decrement. So you have a been assigned the value of 10. All right, now you do minus minus a, which is pre-decrement. You would see the value 9 directly. And now if you print the value of a, it would be 9 again. So basically this is like decrement and then assign. This is like assign and then operate. This is like operate and then assign. Let's see the negation operation. Like a has a value of true. Now we negate it and assign it to the variable d, and you could see that it's changed to false. Now let's see the arithmetic operator. You have b, which has value of 20. We have d, which has value of 30. So when you add it, it gives you value of 50. When you multiply it, it gives you the value of 600, 30 into 20, which is 600. When you divide it, 30 by 20, you get value 1. And when you have mod, which is like remainder, which gives you value 30 by 20, which is equal to 10. Shift operators, so it shifts to the left. So shift left, shift right. So basically you have integer value of 20, and if you convert this into binary, if you convert the 20 to binary, which comes out 5 digits, right? So when you convert this binary and when you shift it to the left, you would get the value of 80. So you have value 20, which is nothing but, if you convert this 20 into binary, which would give you 10100, right? Now what we are doing here is kind of shifting it to the left by 2. This is what you do, and this is what it shows up as value of 80. So this is nothing but 64 plus 16. So that's what this left shift does. Basically it's shifting to the left by 2. Again, you could have shifting to the right by 3, which would give the value of 2. Just shifting to the right by 3 would be something like this, right? So yeah, basically it shifts it, and you could see that, yeah, basically it would end up to 2. So now we have like relational operators, which is pretty much simple, like a less than b, it gives false. A greater than b, a equals b. Since you have a is equal to b, in this case we have a equal to b, that's why we have a less than b as false and a greater than b as false, but whereas a equal to b is equal to true. We have arithmetic operators pretty much similar. Basically you have add, you have multiplication, you have division, you have mod. So here we have a is equal to 20. So what we are trying to do is assignment. So a is equal to 20. Now b is equal to 40. A plus equal to b, which is nothing but, as I said, your left hand side would be added up to the right hand side and would be assigned to the left hand side, which is nothing but 20 plus 40 would be assigned to a. So when you print a, it would print 60. Ternary operator, which is nothing but if a is less than b, Here we can see that if A is less than B, then the value of 100 should be assigned to TR or the value 200. In this case, the value 200 is being assigned. A is greater than B. Logical operators is nothing but ANDing and ORing of conditions. Yeah, here we are saying that A is less than B and D is less than B, then return false. And it's like kind of ANDing logical conditions. Now let's talk about the control statement in Java. Now again, this one is pretty much similar to other programming languages, nothing different in Java. So you have control statements, you have iterative statements, you have jump statements. So one is selection or decision making statements, which is like if else ladder. You have if this particular condition satisfies, do something, do some execute group of statements. And if it doesn't, then execute other group of statements. That is about if else. Switch is nothing but based on the value of a variable, like you execute different step of statements. Like say for example, you have you write a switch on integer variable x. Now when x is 1, you do something, or if x is 0, you do something. Or you can have a default statement as well. When x is neither 0 or 1, do something else. That's about switch. Iteration is you repeat the same set of statements again and again till a particular condition is met. That's iteration. So you have for loop, which is like after every iteration, the value of variable or the iterating variable would be changed and would be checked against a condition. And if it meets, it would come out. Or if it meet, it would execute it again. And if it doesn't meet, then it would come out. So yeah, this is pretty much similar to other programming languages. So for int I is equal to 0, I is less than 10, I plus plus, and you write something within it. So this loop would go on for 10 times from 0 to 9. It would break, it would come out when I is greater than 9, which is 10. When it goes to 10, it would come out. While is again pretty much similar to that. You have do while construct, which is guaranteed to be executed once because the condition is checked after the execution is done once. So basically, no matter what the condition is, it has to be executed once for sure. That's when, if that's the behavior you want to put into your program, you would use do while. Execute once for sure. Jump statements, you have like break, which come out of for loop, or any iterative statements. You have continue, which would again continue, and return is again coming out of a method, or yeah, mostly from the methods you return something. So the control leaves the method. Now, just to give you what if else is, if the condition is true, then execute the conditional code. If the condition is false, come out of the execution or come out of the conditional code. Skip the conditional code. That's what if else is. So here you have int I is equal to 10, int b equal to 20 if I is less than b. So it's pretty much similar to the ternary operator that we had. So you could see here tr is equal to a plus b. So basically the value, if a is less than b, which is in this case, a is equal to 10 and b is equal to 20. In that case, you would have ter as 30 since it is true. So basically it checks the condition, and if the condition is true, it executes the code with it. Now let's talk about if else. If else construct is nothing but you have a else set of statements to be executed when the condition doesn't succeed. So in this case, if a is less than b, tr is equal to a plus b, else tr is equal to b minus a. So in this case, it was less than a is less than b, so you got the value of 30. Whereas if a is greater than b, we have again changed it. So if a is greater than b, then tr is equal to a plus b, else tr is equal to b minus a. So in this case, a is less than b, so which means tr should be b minus a, which goes into the else condition statement. And here you have 20, b as 20 and a as 10, which is 20 minus 10. So you should have tr as 10. So here it's pretty much same. It does the same thing, nested if else. Now we are talking about the switch statement. So you have switch expression and you would have case written against it, whatever case you want to execute. So basically you would have for value one. So yeah, what we are trying to say here is we have a switch expression and we have a value. For value one as its value, then execute this piece of code and then break out. And if it has value 2, then execute this piece of code and then break. If it doesn't match with value 1 and value 2, then execute the default cases. So one thing to note here is it's mutually exclusive. Only one of it would be executed out of the cases. Make sure you break out of all the conditions. So to the right hand side, you could see integer ch has a value of 40. Now we have a switch for 40. Now case, when the value of ch is 20, it would print case 20 executed. When its value is 30, then we would have case 30 executed. When its value is 40, then we would have case 40 executed and then break out. And if it's neither 20, 30 or 40, we would have a default case executed, which says that 20, 30, 40 not executed. So in this case, since it has a value of 40, you would see that case 40 executed as output. Iteration is nothing but it is basically iterating code. If a condition is met, the code would be executed. Until the condition is true, the code would be executed, and once it is false, it would come out of the loop. So basically it's a looping statement. So after every loop, the condition would be checked, and if the condition is true, it would loop again, and if not, then it would come out. There are three types of for loop in Java. Simple for loop, similar to C, like for int I is equal to 0, I is less than 10, I plus plus would be a simple for loop. For each or an enhanced for loop and labeled for loop. For each is basically iterating on array list. Suppose you have some collection, or suppose you have array, right? You don't have to manipulate the indexes, since the typical scenario with array list is iterating through all the elements within the list. So we have an enhanced for loop wherein we don't have to actually deal with indexes. Java has come up with a enhanced for loop wherein for each iteration it would assign the value of each element within the array to a variable which could be used within the loop. So we don't have to deal with indexes, like we don't have to loop through till the size is met, till the loop through till the size of an array is met. Basically, it's all done by Java itself. We have an example which would clarify it. So simple for loop is, as I mentioned, you have for int I equal to 10, I is greater than 1, I minus minus. So it would print from 10 to 2. That's a simple for loop. Now, what's the syntax for it is for, then open up round brackets, then you have initialization, then you have a condition, and you have increment or decrement, whatever you want to do. Or you could even add up like I plus equal to 2, even that is good enough. It's like for each even number. Not even, I would say, it's like incrementing by 2. Now, this is what I was talking about. So this is for each loop or enhanced for loop, wherein a typical scenario with array is you kind of iterate through each element within the array and then do something within the loop, right? So this is what Java has made it easier for us. So basically, you don't have to deal with indexes here. If you wouldn't have had for each loop, what you would do is you would, till the size of the array is met, you would iterate through and read from each indexes, right? But in this case, as you could see, there's an array, and for each loop, the value within the array would be assigned to this variable, and you could use this variable within. Makes it pretty much simpler for us. And as I said, this is a typical thing that we do with arrays. Now, labeled for loop, it's not recommended to use this often, but still we have these constructs here. So basically, it's like go to. We can have a label of each for loop. It is useful we have nested for loop so that we can break or continue a specific for loop. Normally break and continue keyword continues the innermost for the loop only. To give rationale behind why I mentioned that this shouldn't be used often is because it becomes very difficult to debug, right? If you dry run it, if you use these labels, it becomes very difficult to actually understand what's happening within. So we should avoid it, and all this could be done by writing a proper constructs or using simple for loop as well. So we should avoid it somehow. So basically, as per my experience, this is not a good practice to use it. So type of while loop, we have simple while loop, we have do while loop. All right, so simple while loop is first the condition is checked. If it meets, then the looping statements are executed. Whereas do while loop is kind of the statement is executed once for sure, and then the condition is checked. If it is met, then it is looped again. If not, then comes out. So this is a simple while loop. So you have condition. As you could see here, while a is greater than 1, you print the value of a and you decrement it within. Here it's a do while loop. So no matter what, you would have this 2 printed and it would be incremented. So it's 2 to 9. So no matter what, some value would be printed for sure when you use do while. Now we have jump statements, which is break is like coming out of a loop. So as we mentioned, it's the innermost loop that it comes out of. So that's what break does. If a particular thing is met, or you could write a condition for a particular loop to be broken rather than continuing it. So basically you could have like this would be more or less like you could have an infinite loop, say for example, running through. And if a particular condition is met, you could break out of it. A typical scenario where it would be used. So here you could see that you have a loop from 10 which iterates from where I is equal to 10 and where I is greater than 5, I minus minus, which we are decrementing each loop. Whereas you are saying that if I is equal to 7, we should break out. So here you can see though I is greater than 5, you can see the loop has broken out after 8. Since the value has reached 7, it's not printing the other indexes because it broke out of the loop. So basically, this is like if a particular condition is met and you don't want the loop to go ahead, you can break out of the loop. Continue is similar. When you write continue, it goes to the start of the loop again. It starts the loop again and it skips the messages or it skips the code that you have after continue. So in this case, you could see that we have I equal to, in case when I is equal to 5, we are continuing the loop, which means the print statement for I when I is equal to 5 wouldn't get executed since you're continuing it. So basically, as you could see, the values being printed here, you can see 0, 1, 2, 3, 4, and there's no 5 here. Then we have 6, 7, 8, 9. So basically what we are saying here is when I is equal to 5, don't execute the statement within the loop. Just continue, just skip it. Okay, so what are methods in Java? So method is if you would have written function or if you would have used any programming languages, if you want to perform some operation, if you want to do something, or if you want to do something on some particular data, you would write a method. So basically in Java, methods are defines the behavior of a class. So remember I told you a class is all about state and behavior. So methods are nothing but it defines the behavior of a class. So what are methods? A method has a group of statements. Of course, as I said, since it defines the behavior of a class, you need to have some operations done, right? So you define the operations through group of statements. It is much more used to have reusability of a block of code that minimize redundancy. So imagine if you didn't have methods, then you would have written the same piece of code again and again. Say, for example, you have a method which adds to number, right? And if you write the piece of code to add to numbers directly into the main method, if you want to write it again, or if you want to again add two numbers, you will have to write the same piece of code again in the main method. Whereas if you have a method, what you would do is you would refactor and take this add method or a functionality which adds to numbers into a method. And this method could be invoked from anywhere within the application which is nothing but reusability, right? Rather than writing the same piece of code, now what you're doing is you are defining this add method into some other method, which could be called anywhere within the code. So that's about redundancy. That minimizes redundancy and increases the reusability of a code. A class can have multiple methods, as you could imagine. You could have multiple behaviors introduced into a class, which means that you would potentially have multiple methods within a class. A method returns a null or a value using the return statement. So basically, the intent of the method is to perform some operation, right? So what the method would take is it would take parameters and do some operations on these parameters, and it may or may not return something back to the calling program. So if you don't want to return anything, you have to return null. Or if you want to return some value, you could have, say, for example, you want to return string, you would return a string of a method. You could have void as well, which means that the method is not returning anything back to the calling program. It is doing something within itself, and just the control would be back to the calling program, but it won't return anything out of the method. That's about method. So let's talk about, so what's the syntax of method? So the first one that you see, so this is a method which is public int edureka integer a integer b, and it is just concatenating the two strings or two numbers that we have sent across. So basically, let's anatomize it. So what is public? So public is nothing but, again, a access modifier. So public means this particular method could be accessed from anywhere within the application. So that's what public means. Similarly, you could have private, you could have default scope, or you could have protected scope. So public is accessible anywhere within the program, private is within the class, default is within the package, and the protected is within the subclass and the package. Okay. What is this int? It is nothing but the return type. So this particular method is going to take two arguments and do something and return integer, right? Name of the method is, you can see edureka, that's the name of the method. Okay, so what you see within the parenthesis after the method name is nothing but the arguments that this method takes. So what this particular method is doing is it is taking two arguments which it is acting upon, right? So it takes integer a and integer b. That's the parameter list. So whenever you want to invoke this particular method, you have to pass arguments in this order. Now, what you see within this curly braces is nothing but the behavior, or this is how you introduce a behavior to the class, or this is how you add functionality to a method. So what you are doing here is kind of adding these two numbers. So what is a return statement? What does it do? So return statement is nothing but you do something, you take the arguments whenever control comes into a particular method, it does something and you return it back to the calling program. So the return statement is a control flow statement that terminates the execution of method and return control to its caller. So when return type of any method is void, then the method does not return anything. If it is void, you won't return anything out. But if it is returning string or something, you would return string, or null if you plan not to return anything. It could be null as well. So here we can see a method by the name work, which is returning void. So you can see that it is not taking any arguments as such or parameters, but it is just printing out saying that edureka welcomes you. In the second case, you can see it is returning integer. So it's taking int a and b, okay, and then it is printing out and it's returning integer as well. So let's write a program, sample program to add two numbers, and we would be writing all this logic within a method. So let's start off by defining a class. All right, so we define a class, say com.edureka. And a typical name for all arithmetic operation, class with all arithmetic operation would be calculator, right? So I would write it as calculator, for example. All right, so here you can see the naming convention again. There's a package. which is com.edureka, and you have a class as calculator, and it follows camel casing. So it starts with uppercase followed by lowercase. So you can see the class is being created here. Okay. Now what we are trying to do is you are going to have a method which takes to number. Okay. So say I define, let's keep it public. All right. So this is an access modifier. We want to keep it public. So we want to access this particular method from anywhere within the application. So I'm keeping this public. So typically addition would return results, right? You would add two numbers and return results of two numbers. So that's your return type, which is integer. So you could either write the return type as primitive, or you could write it as a wrapper class. So basically wrapper class is nothing but integer has its own, everything in Java has to be realized in terms of classes. So integer has its own class. Int is a primitive data type, and integer that you see here is a class corresponding to int. So let's put the return type as integer, and add is the method name. Okay. Now this takes two arguments, integer arguments, which is arg1, and let's put the second one as arg2. All right, so we start and end it by curly brace. Okay, now we have to write logic within here. So what you see here, it's throwing an error saying that you are not returning integer out. There's a missing return statement, because in the signature, this is known as method signature. This particular thing that you have defined here is method signature. So in the method signature, you have mentioned that this particular add method is intended to return integer out of the body, but still you haven't returned integer. So basically, to get rid of this, I could put return null, which means it's doing nothing. Now you can see that we got rid of the error, right? So let's do one thing just to make it more verbose. I'll write integer result is equal to arg1 plus arg2. So this is a method body that you are defining here. So you are adding a behavior, right? You are giving behavior to the calculator class. So by defining add method, this certain behavior that you are introducing. Now you could have a multiply method as well, which would take two numbers and would multiply it, which is again giving some sort of behavior to calculator. So that's the reason we say that methods add behavior to the class. Okay. So here it is taking two arguments, arg1, arg2, adding it, and we will return the result from here. All right, so this is a method that you have defined. But so far, we are not invoking this method, right? We are not calling this method. We want to call and check whether it's running as expected. So that's where we would have main method. All right, when you type main, it should give you suggestion saying that, are you trying to write main method? So once you click on it, it would, this is done by IDE, by the IntelliJ. Similarly, in Eclipse, you would get an option. It would give you a suggestion saying that, do you want to introduce main method? All right. So we have a main method here. So again, it's public static void main, and it's taking arguments here. All right. So remember I said static and non-static method. You can see here add is non-static method. When it's a non-static method, you have to create instance of this class to invoke it. So basically, first thing that I do is I create instance of calculator. So how do you create instance of calculator? It's with new keyword. All right, you create new, and it would create instance of calculator. Now I give a call to add method, and suppose I want to add like 10 and 30. Okay, so these are the arguments, and it has to be in order. In this case, since both are integer, it doesn't matter. But had it been some other data type, you have to ensure that, say for example, I write string here. What this would return is typically a result, right? Addition of two numbers. Now let's print it out. System.out.println. This is for printing result of addition is. Let's print out the result that we got here. All right, and let's end it by semicolon. So basically you have a package defined here. Within the package, you have calculator, and actually it's my bad. I should have defined it right here. So it gives the right package name here. So earlier I had defined calculator within com.edureka. Again, I defined the package com.edureka, which is not required. So yeah, you can see here package as com.edureka, which is nothing but the namespace. We have public class calculator. So public is nothing but the access specifier for this class. Class is the keyword used for defining class, and calculator is the name of your class. Also, one thing to note is the name of the Java file should be same as the name of the class. So that is something that IDE or IntelliJ would do it for you. You just have to create class and it would create class. So basically, if you go to the source folder, you would have something like calculator.java, right? Then you have public method, which is again, here's the method that we have defined. Public is the access modifier for this method. Integer is the return type. Add is the name of the method. It's taking two arguments, arg1, arg2. Within the body, you are adding two numbers and you are returning result, which is integer, which aligns to the signature that you have put here. All right, in the main method, just to check whether this add method is functioning properly, what you do is you create the instance of calculator, you add two numbers, you pass two numbers to it, 10 and 30, and we are going to print the result and see if it returns as expected. So here basically it should print the result as 40 since adding 10 and 30. So remember, while it builds it, it would compile into a class file. Okay, the .java file would be compiled if it's properly written. If it's syntactically correct, it would create .class file. All right, let's wait for it to run. Okay, so it's prompting me errors that we have in other methods. So let me do one thing. Let me delete the other classes that we defined yesterday. So I go to the source folder, com.edureka. So I'm just deleting these classes that we defined yesterday so that we don't spend time in actually correcting it. All right, so put it into a backup folder. All right, so okay, so we have only this calculator class now. I run this. So yeah, you can see here it has printed result of addition is 40. So basically what it has done is adding these two numbers, 10 and 30. All right, so that's what we have here. So we're adding two numbers. So let's talk about the sequence of how all this is being carried out by Java, right? When you run a particular program, how things work out. When you run a class, the first thing that's been called is the main method. Okay. JVM is nothing but Java Virtual Machine, which runs the program for you, which is part of JRE, Java Runtime Environment. When you run a particular class, it would search for a main method. And if it doesn't have a main method, then it would give you an error saying that a class can't be run. So it's pretty much similar to an executable file, right? So if you're trying to run a class, it has to have a main method, or you won't be able to run the class directly. So that's where the execution starts from. That's the entry point for your program. Okay. So once it encounters main and everything is good, your JVM would start executing the statements that are there within your main method. Okay. So in the addition case that we saw within the main method, we created the instance of calculator and we invoked add method, right? So when we ran that particular class, you could see that the addition was done. So basically what's happening behind the scenes is, JVM would execute the sequence of statements that you have with the main. So again, coming back to the example, add example. So within the main, you invoke the add method, right? When you invoke add method, the control would go to the add numbers method and it would again execute whatever functionality you have put within that particular method. This case, it was addition of two numbers, so it would execute it. Once the execution is done, it would return whatever is being written out. So in this case, ours was addition of two numbers. So it would return addition of two numbers back to the calling program. So your calling method was the main method wherein you called this add numbers from. Okay. So it would come back to the main method, and that's how it prints it out. So following the invocation of add numbers, you could see that we have printed out the result that comes out of this add numbers, and that's how it gets printed onto your console. So that's the sequence of execution that happens behind the scenes. Now, what are the ways in which you could call a method? There's call by value. Call by value is nothing but instead of passing the memory location, it passes the value of a particular variable. Okay. So this is similar to call by value and call by reference that we have in C. Okay. Instead of passing the memory reference or instead of passing the reference, it's just a value that's been passed. So if you change something within the method, or if you change the value that's been passed within the method, only the local copy would change, whereas the main copy would remain as is. But basically, call by value is just passing the value, but not the actual reference. All right, so to understand call by value, you could, so this would give you some idea. So say for example, I have integer arg1, which is equal to 10, integer arg2, which is equal to 30. Okay, now I pass arg1 comma arg2. So what's happening here is it's passed by value. So suppose you change, so what I'm trying to say is here, if you change arg1 to something else, say 100. Okay, so what we are trying to do here is we are trying to pass this to arguments arg1, arg2 to add method. And within the add method, we are changing this arg1 to 100. Basically, we would check whether this 100 is being reflected in arg1 here. Okay, arg1 here would change to 100 as well. Let's see what happens here. Okay, so I print it, okay, before passing it by value. So I print arg1 here. Okay, and after I give a call, I would again print it. Printing arg1 after passing it by value to a method, add method. All right, so let's run this. So basically, since it's passed by value, arg1 would remain as 10. Okay, so that's what pass by value is all about. So here you can see arg1 before passing was 10 and arg1 after passing was again 10. All right. So the change that you made here doesn't reflect here. So that's passed by value. All right. So there's one more concept of method overloading. So within Java, you could have same methods with different number of parameters. Same method, when I say same method, it has got a same method name, which would take variable number of parameters. Okay. The overloading happens at the compile time itself. So during compile time, JVM understands to which method you are actually giving a call based on the actual parameters you pass on. So just to give you a fair idea about this, I define one more method, say add, which takes say integer arg1. Let's keep this add as. So I define three parameters here. So instead of two, I define three parameters here. This is nothing but method overloading. All right. So here I define arg1 plus arg2 plus arg3. All right. So we sum it up here and we return it back to the calling program. So one thing to note here is it's not giving you compile time error, right? So you can see that it has accepted this add method as well. So you can see here the signature is pretty much same. Only thing is we have one more extra parameter, which is arg3. So it is treating these two methods as a different method. That's what method overloading is all about. Suppose I define one more arg3, I say 40. All right. So we have three parameters here. I'm giving a call to add arg1, arg2. If I put arg1, arg2, the first add method would be called. If I have one more arg3, now the second add parameter or the second add method would be called. So let's define result from new add method, right? So here we say, okay. So as I said, we have overloaded the add method. Overloading is nothing but same method name, but different arguments or different number of arguments. Or it could be different types as well. You could have only two arguments, but one is integer and one is something else. Say for example, string, that also works. So basically different data types, same number of arguments, but different data types or different number of arguments. All right, so here we are adding three numbers and let's run this. So it's going to add 10, 30 and 40, which is nothing but 80. So this is done at the compile time. As I said, this linking is done by JVM at the compile time. So here you can see result from new add method is 80. During runtime, you can see that it invoked this particular method and not this one. All right. Now let's start off with arrays, right? What is the concept of arrays? So again, this is similar to other programming languages. Arrays are nothing but grouping data or grouping values of same data type. Okay. So arrays are used to solve the problem of storing multiple elements of the same data type. Okay. An array is group of like typed variables that are referred to by a common name. So you define a name for the array and in the future you can use this name to access it. Okay. Specific element in an array is accessed by its index. As you could imagine, since we are grouping, you would have multiple elements, right? You could add something to it, or you could delete something, or you could add it to the end, insert it in the between of the array, or just search something, or just search by index, right? You would give some specific index and get element from that particular index. So we would be looking at the program which would give you a clear idea about this. But basically array is nothing but group of or its multiple elements of the same data type. Array type is fixed and cannot be changed. So in Java, when you define an array, you either give the number of elements that you can store in the array, which is nothing but the array size, or you have to give the values that a particular array would contain right when you define it. Okay. But all in all, you have to make sure that when you define an array, you give the size as well, which cannot be changed in the future. The size of the array has to be mentioned during the declaration itself. So here's an example of array. This array has around which has four subjects, which stores marks of four subjects for a student. Okay. So here you could see indexes in the white box, which says 0, 1, 2, 3. It's always in sequence. It starts with 0 and it ends with n minus 1. So basically this array is of size 4, which starts from index ranges from 0 to 3. All right. The value that is stored is nothing but that's the marks in a particular subject, which is like 87, 60, 70 and 80. That's a value that's been stored into this array. Okay. We can access any of these indexes. Suppose you want to access at index 1, you could do it. You need to define upfront, you need to define on the size of the array upfront. This is how it's been done. Okay, so this is how you declare a array. So we saw how we usually declare integer and stuff like that in Java, but here we are declaring array. All right, so this is an integer array and you can see square brackets here. All right, this tells JVM that we are trying to define array of type integer. All right, so again, we use the same keyword, which is nothing but new. New keyword is used to create a particular array. All right, and here we are defining array of size 5. So this is one way of declaring array. The other one would be through initializer itself. So when you declare it, you give what are the values that particular array is holding up. In the first case, you're not giving the values, you are just defining an array which reserves some amount of memory, right? JVM would reserve some amount of memory, or in this case, it's 4 bytes, right? Array. So for integer, it takes 4 bytes. So it would reserve 20 bytes for array of size 5. All right. So in the second case, as I said, it's directly initializing the array. It's putting these values directly into the memory location. Still, it would be consuming 20 bytes, but the second variant would have the values directly initialized. So when you declare an array of size 5, the range of indexes would be from 0 to 4. If you try to access index 5, you would get this exception. Exception is nothing but a anomaly situation, right? Which or something which is not expected has occurred in your program. And Java expresses such event by throwing out an exception. You can't access index 5. So different ways of declaring array. We saw that it's with new keyword. All right. So you have new int10, which would declare array of size 10. Again, you could either have the square bracket at the end of the variable, or you could have it in between the type and the variable name. So behind the scenes, everything is the same. It doesn't do anything different for both, but these are different ways in which arrays could be declared. All right, the third one is similar to the last one, wherein we are initializing it directly. All right, we are putting this value 1, 2, 3, 4, 5 into this array. This one is again the same. So within the square brackets, you can see that you're not defining the size of the array, but you have an initializer at the end by which you express that you want to put in 1, 2, 3, 4, 5 into this array. So basically 1 and 2 that you see here does the same thing. It declares the array of size. The first case is 10, the second case is 5 though, but behind the scenes, it's doing the same thing. It's nothing different when it comes to actual reserving memory and stuff like that. It's doing the same stuff. And 3 and 4 does the same stuff. Only thing is syntactically it's varying, but what I'm trying to say is JVM doesn't do anything different to actually execute it. So the length of the array is set when it is declared, and when an array is declared, array index gets initialized. All right. So if you define an array and if you try to print the length of it, you could see that it prints out. In this case, we have declared array of size 20, and when you do x.length, when you print it out, you could see that it prints 20. All right. So what are different types of arrays that we have? Again, similar to what we have in other programming languages, we have single dimensional array and multi-dimensional array. Single dimensional array is what we saw earlier, like you define array of integer of size 5, that is a single dimensional array. So in this case, you could see a array being initialized with value 2, 4, 6, 8, and 10. That's a single dimensional array. Since we have just one dimension, one row, right? Say, for example, you want to store marks scored by a student or marks stored by a particular student, just one student, that would be a single dimensional array. All right. So, say, for example, the first one is the marks code in math, the second one is the science, and so on and so forth. All right. So, that's single dimensional array. So now what's multidimensional array? So taking the same example of storing marks scored by a student. So by a particular student, it would be a single dimensional array. But suppose you want to store marks scored by all the students in all the subjects. If you want to store it, it would be a multidimensional array. So one particular row that you see here would be a marks secured by a student, by just one student in all the subjects. The first row would be by student 1, the second row would be by student 2, the third row would be by student 3, and so on, right? So that's where you have this application of multidimensional array. So how you access it is nothing but if you want to access the first element or the first index, it would be a of 0, 0, and this would be a of 0, 1, and so on. So as I said, if the first column is for math, if it's a marks secured in math, this entire stuff, the first column that you see would be marks secured by all the students in math. That would be the first column. Whereas the first row is the marks secured by student A in all the subjects. So basically, this could be imagined as a table in a database, right? You have a table wherein you have rows and columns. So columns are nothing but you have fields within a table, and the rows that you have are different entries that you have within a table. So this could be imagined in the same way. So you could see how the indexes are aligned. So X increases when you go down and Y increases as you go to the right. The memory allocation of array. So for single dimensional array of type integer, one integer value takes 4 bytes, right? So now when you declare an array of size 5, you would have 20 bytes reserved. That's how memory is being allocated, right? If you have a character array of size 5, it would be 10 bytes. Since each character takes 2 bytes in Java, so you would have 10 bytes reserved upfront. All right, so that's about memory location allocation in single dimensional array. And when it goes to multi-dimensional array, in this case, you have like 5 elements, right? You have array of 5, which means that you have 25 elements stored within the array, right? 25 integer elements stored within the array. And each integer value takes 4 bytes for storage. So it would be 100 bytes. All right. So if you define a multi-dimensional array of 5 into 5, you would have basically 100 bytes allocated for it. Let's write some programs and understand more about how these arrays operate. So we have an array of 5 elements. All right. As you could see here, 2, 4, 6, 8, and 10. Write a program to access element at a specific index. Okay. So you have an array of 5 elements, 2, 4, 6, 8, and 10, and we want to access it. We want to access particular element. All right. So let's write. So I create a class. All right. I define this as array demo. So I don't give a package name here because I'm defining a class within a package. So you could see here the package came directly because I right clicked here, right? And then created a new class. So yeah, you get this particular class here. I define a main method as a type main. It would give me a suggestion, right? So this is the entry point again for this particular class. And suppose I define integer array, and suppose I define 2, 4, 6, 8, and 10, right? So you could see here we have an array defined of size 5, okay, and you have initialized it as well. So what I was trying to say is you need to have length of the array given upfront, right? If you don't do that, it would show you an error. So you can't do something like array of integers is equal to new. So you could see here array initializer expected. All right. So either you will have to initialize it or give some value to it. So if you put here 10, you could see that it compiled, right? So either you will have to mention some indexes here or the length size of the array, or the other way is to initialize this. Okay, now you could see the compilation error has gone. So what I'm trying to say is JVM has to know about the size of the array upfront. If it doesn't know, then it would flag you with an error. All right. So we have defined this array of, let me keep it as is. Okay. So now we have defined an array of size here 5, and we have initialized values as well. Now let's try to print out values, right? So just to keep it simple, suppose the index would range from 0 to 5 in this case. So this value 2 is stored at index 0, value 4 is stored at index 1, value 6 is stored at index 2, value 8 is stored at index 3, and 10 is stored at index 4. All right, so let's try to print 0. By the way, I want to copy it. Yeah, so I'm just printing 0, 1, and 4, and let's see what it gives out, right? So it should print 2, 4, and 10, right? So you could see here 2, 4, and 10. Now the other thing that I wanted to show is if you try to access, so let me show you what happens there, all right? So if you try to access at index 5, which doesn't exist at all, now it should give you a exception. So in Java, exceptions could be nothing but caught and you could do something with it. So here you could see that it gave you array index out of bound exception since 5 doesn't exist at all. The index 5 doesn't exist at all for this array. Okay, now let's define multidimensional array, write a code to find the length of row 0, right? So let's define a multidimensional array. All right, so we have a multidimensional array here. So how you define multidimensional array is something like 1, 2, 3, 4. All right, so this is a multidimensional array that you have. Okay, so we have defined a multidimensional array. The size of this array would be 2 by 2, right? 2 by 2 is the size of this array since you have two elements here, or let me put it to remove the confusion. Let me put it this way. So right now we have like 2 by 3, right? So you have like 2 columns and 3 rows. All right, so now let's print. Actually, it has to be 3 by 2 rather. Okay, now let's print the size of this array 0, right? So how we do it is again println. Now you have multidimensional array and you have 0. So 0th one refers to this 0, 1, and 2. Okay, dot length. So as you could see here, that individual row that you have within multidimensional array itself is an array. It's a single dimensional array. So multidimensional array is nothing but it's a array of a single dimensional array. Okay. So let me print here size of first array. I missed plus. So as you could see here, there was an exception. And since there was an exception, you won't have this particular statement executed since there was an exception here. So basically, to execute this particular statement, you should handle this particular exception. But we are not talking about handling the exception yet. So I'll have to comment this to pass through. So now you could see that it has printed out 2, which is your size of first array. So this is a program that we actually did right now. Create an array having many characters, write a program to copy elements from created array to another array, and also write a program to delete an element from an array. Okay, so I'll just talk about this right here. So we have an array here of characters, right? So basically, when you want to delete something from an array, what you will have to do is you will have to shift the indexes, right? You can't delete something directly from an array. So what you will have to do is if you want to remove something, then you will have to shift the indexes. What happens is suppose you have an array of 5 integers and suppose you are deleting the second element, right? Now what you would do is you would shift, if you are deleting the second element within the array, you would shift all the elements that follows the second element to the left, right? So the third element would become the second element, the fourth would become third, and the fifth one would become the fourth. So basically you shift it. That's how you delete something from an array. All right. So other thing is about copying elements from the array. We have a utility class, which is nothing but system. System is a class itself. So as you could have seen that when I'm printing out something, I do system.out.println, right? So this system, it's a utility class in Java, wherein it exposes a lot of functions within or a lot of methods, utility methods within. So one of them being array copy. So here you have to give source and the starting index and the destination. And what we are trying to do here is copy 5. So this is how we copy from one array into another. starting from index 0. So this is copying, and the other one that you see here is about delete. So as I said, deleting is nothing but we have a logic written here to shift the indexes to the left. So here we are trying to delete one at index 3, and we are just shifting elements after this index 3 to the left. That's how we delete something from an array. Now let's see what are strings. So string is nothing but, again, it's a data type within Java. So why do we have strings at all, right? We have array of characters. Then why do we have string at all? So here's an example wherein you have a lot of loads of data. So you could imagine a role of a data analyst who has to analyze through a lot of data coming in, right? So nowadays it's like petabytes of information being processed throughout a day, right? Which would be very difficult to handle if you had to deal with character array. So that's where Java has come up with strings, which is nothing but a group of characters, but you don't have to deal with it. Java by itself has a class which would take care of this strings. And since strings are widely used within a program, you could imagine that name or anything, that any identifier that we have is mostly we have to store it as the string. So one of the data types that's widely used within industry, or which is widely used in programming, is string, right? So Java has some kind of string management as well to make sure that programs run or make effective use of strings. Okay. So here what's been mentioned is James is a data analyst and he's finding it really difficult to actually deal with character array to store patients' names every time. So that's where we have string. So string is solving the problem of actually dealing with character array. So Java is actually having character array, is storing characters or the characters in the string in a form of character array, but it doesn't expose it to the outside world. You can just use this class to deal with it, but you don't have to deal with character arrays. So Java string is nothing but sequence of characters. They are objects of type string class. Once a string object is created, it cannot be changed. This is the immutability functionality of Java, wherein once you write to it, you can't change the value. So this is specifically important when it comes to multi-threading, when you have multiple threads accessing a particular string, a same string. So that's when immutability helps us to make sure that multi-threading is, it's thread safe. We call it as thread safe because multiple threads can access the same string just because it is immutable. All right, so what are different ways in which you declare a string? So you have string str is equal to new string, which you're not initializing the value of the string here, which could be any value. And you have string str1 is equal to edureka, wherein you are initializing the value of the string right away. The other one is the character array. Similar to the integer array that we discussed, we have character array as well. So immutability of the string. So why do we have immutability? One is for security. So string stores a lot of useful information, like even the credentials and stuff like that, which shouldn't be accessed by external users. So this immutability factor of string helps us to keep it secure so that no one else can see it. Synchronization. So this is what I spoke about. When you have multiple threads accessing the same string, you don't have to synchronize it. Java by itself, through its immutability feature, would ensure that multiple threads can access the same string without hampering it, or it would run as it's expected. Caching. So caching is nothing but you have a string pool. So basically, if you have two strings with the same value, it won't store it. It won't store redundant copy of it. There would be just one copy in the string pool, and both these references would be pointing to that value. If you happen to change one of these references, it would point, or it would create a new value in the string pool and point the other reference to it, sort of. So basically what we do is, why caching is required is, as you could imagine in an application, as I said, string is widely used data type, and you could have multiple references pointing to the same value of a string. So we don't want to have duplicate values stored. That's where this caching comes into picture to utilize memory efficiently. So what is string pool? As I said, string pool is all the constants that you define within the string within the application would be stored in the string pool. String pool used in Java is a pool of strings stored in Java heap memory. So we have heap memory wherein the objects are created, and that's where string pool resides as well. String pool is possible only because strings are immutable. You can't change once it is defined, you can't change it. If you change it, then you can't change that particular memory location. It creates one more entry in your string pool, and the reference would point to the new entry. So the actual memory location is not getting changed. That's what immutability is all about. String pool helps in saving a lot of space for Java runtime. We are breaking on the redundancy factor here. So if you have multiple strings, or if you have multiple strings holding up the same value, it won't create multiple copies of it. There would be just one value in the string pool, which would be accessed by all the references. So basically, string pool, as we discussed, is or resides in heap memory. So string is not a primitive data type. Unlike character, char is a primitive data type. String is not a primitive data type. It's a wrapper class to array of characters, right? And this is specifically done so that Java has a mechanism to manage strings well, which is widely used data type within any application or any programming language for that matter. Java strings are stored in string pool of heap area, which we already discussed. So we can see a string pool. So we have stack memory and heap memory. So when you have a local variable, when you define something locally, the reference is created in the stack, all right, and it points to the actual object is created in the heap, but the reference is created in the stack. So you could see S pointing to hello in string pool. Okay. So S is nothing but a reference to the string. Okay, so here we can see that we are concatenating, right? So this would give you a fair amount of idea what immutability is all about, right? So here we have string S1 is equal to happy, all right? And what we are printing out is the original string that is happy, right? So you could see here S1 is a reference that's been created in the stack. You have a string pool within your heap memory, which would store all the strings, all the constants or literals that you have defined here. So you could see happy been stored in the string pool and S1 pointing to it. Now you are trying to concatenate S1 with learning, right? So it's happy learning. So you could see that the memory location that S1 is pointing to is not changed, right? It's still pointing to happy. But there's one more constant that's been created in the string pool. That's a concatenation of happy and learning. So you could see happy learning also created. But what's important to note here is S1 is still pointing to happy. It's not pointing to happy learning. All right. So if you want S1 to actually point to happy learning, this is how you do. So you have S1, which has the value happy. All right. So you do S1.concat learning and you assign it to S1. All right. So you are assigning to the same reference as S1 and you are printing out S1. In this case, what would happen is, unlike the previous example that we saw, wherein S1 is still pointing to happy, you would see that S1 is pointing to happy learning. So here you could see that S1 is pointing to happy learning. So basically you move the reference from happy to happy learning. All right. So let's see what are strings. How do we operate on strings, right? So let me create a new class here, just string demo. I create a main method again. All right. Now what we do is string s is equal to Eureka. All right. So let's first print the length of the string. All right. So this is how this utility class, or this is how this wrapper class helps us. So it has all these utility methods, right? You just have to do s dot length. It would give you length of the string. So had we not had strings, and if you want to deal with the character arrays, you would have to print the size of the array here. All right, so when we run it, it should print 8. 8 is the size of the string edureka. Let's have substring. So it's a beginning index. So suppose if you give 2, so it would give you substring from index 2. So basically we are getting substring. We are getting part of the string. Substring is nothing but part of a string, right? From a particular index. So since we have given 2 here, it starts from index 2. So you have 0, E is at 0, index 0, D is at index 1, and U is at index 2. So it starts from U till the end of the string. You have compared to, you could define 2 strings and you could actually compare them and see the value. So basically, so you could have one more string defined here, something of this sort. All right, so here we compare it. So we are doing s1 dot compare to give s2. So we are comparing s1 with s2. So it compares the given string with current string. So here you can see it has shown -1, right? Since B is 1 ahead of A. So if you have same string, it would show you 0. So if it's exactly the same, it would give you 0. You have is empty. Suppose you don't have anything within your string, you could check it whether it's empty. Is empty returns a Boolean variable, which means if it's true, it is empty, and if it is false, it has some value within. We have 2 lowercase, we have 2 uppercase. In this case, suppose you want to, there could be scenario in which you want to change or you want to change the casing. So I'll just take one of it. I make it 2 uppercase. Okay, so S1 is nothing but we have edureka stored within, and we are, so when I run this, you should have edureka printed in uppercase. So here we have written camel casing, and let's see the output. So here you can see the string was converted or translated into uppercase. So similarly, you could do lowercase, which would print string in lowercase. Now we have value of is nothing but the value of a string, value of some of the data types. So you could pass integer and you could do value of, and it would give you a convert integer into string, right? So value of is a method within string which takes different data type and converts it into string. So just to give you an example, you could have like integer I is equal to 100, string dot value of, and you give I, it's converting this I into string. So it would print the same value 100, but it's converting it into string. You could replace something within the string if you want to replace particular character within the string, which could be done with replace method. So replace method takes 2 parameters. Replace is a method within string which takes 2 parameters. First one is the character that you want to change, and the second one is the new character that you want to change replace to. Okay, so here to show s1 dot replace, I could replace E with E maybe. All right, so we are making it lowercase, and as you can see here, it's printed in uppercase E was changed to lowercase e. So that's about replace. We have contains, which again gives you Boolean type result, which says whether a particular value or particular character is present in a string. All right, so in this case, we check whether we have S2 with HELDO, and you replace D with L, which becomes hello. And now we are checking with the replaced string contains D, which it doesn't contain it, right? So it would give you false. So that's about contains. Equals is basically checks for the equality of string. It takes one argument and it compares it against the string object against which you invoke the equals against. All right, so to give you an example, So you have S1, which is edureka. Now to print it, so here we do S1 dot printing equality of string. So since it's the same, it would give you true. If had it been different, it would give you false. So you can see here it's printing both the strings are the same. You have different methods like compare, ignore case, wherein in this case we compared with case, right? If you would have had Eureka in lowercase, right? If it would have started with lowercase e, you wouldn't have got 0 here, all right? Whereas there's one more method which is s1 dot compare to ignore case, wherein it doesn't consider the case, right? So even if there's a case change, if there's a one in uppercase and one in lowercase, still it would match, or still it would give the value as 0, which means both the strings are the same. We could get some character out from a string. Okay, there's a method character at. There's ends with, which again returns a boolean value saying that whether a string ends with a particular character. All right, so here what we are doing is we are checking whether the string p, which holds the value happy learning, is ending with u, which doesn't, right? That's the reason it gave you false. Had it been g here, it would have given you true. Now that's about strings. Now let's talk about different variant of strings and why do we need it. So there are like three variants of string. One is the string class itself. The other one is string buffer, and you have a string builder. So we'll talk about why do we need these variants at the first place. So string buffer is nothing but it's good for multi-threading. When you have multiple threads, usually it's good to have string buffer because all the reads and writes that you do on the string, it is synchronized. So when I say synchronized, there's only one thread that could access a particular method within a class at any given point. So you can't have multiple threads going in and changing the value or doing something. So basically, if you have a string within your application which is being accessed by multiple threads, it's better to go with string buffer. Or if there's a lot of not accessed as such, access is one factor, but of course, if there are a lot of modifications done and stuff like that, like with string buffer, you could append to a particular string, which cannot be done in string, right? In string buffer, you could actually do a lot of things which cannot be done in string. And just to make it thread safe, they have made all the methods that modify the string contents as synchronized so that only one thread can access it at any given point. So see, you can see insert here, right? In string, you don't have all these methods. You don't have methods to manipulate the strings in string, right? Whereas in string buffer, you have methods to manipulate the strings. So when I say strings, those are literal strings, right? Not the string class. All right, so here we have string buffer and we are trying to append something to the string buffer. So we define a class, we define string buffer. So you could have like s1 dot append, and when you see append, you could see that it appends any data type. This is the important factor in string buffer. You have a lot of utility methods within, or you have a lot of methods to manipulate the string, which you don't have it in string class. All right. So this is mutable, right? You're changing the values. Suppose I append 3 exclamation marks to it, right? So what we are doing here is we are just printing out the new string. All right. So basically you should see edureka and the 3 exclamation marks. Yeah, as you could see here, it got appended. Right? So basically it's a mutable string. Change the value within. Insert is nothing but inserts a new character at the given position. So here we are saying that insert W at position 0. You could replace particular or replace substring with a new string. So here what we are saying is replace index starting from 0 till 2 with this new character sequence. You could delete something from it, delete sequence of it. So here we are saying from index 0, delete one character. So if you have 2, then it would delete 2 characters. So basically, when you say 2 characters, even this E would have been gone. Okay. In this case, we are just deleting one character. So basically, this delete method takes the starting index and the number of characters following the starting index. Reverse, you have like you could reverse the entire string. Okay. So just to show you, I can new string dot, if I reverse it. So basically, these are kind of utility methods which we often use, right? So you can see it's been reversed here. All right, you can see the capacity of the string. Capacity of the string buffer is nothing but I think it reserves 16 characters initially when you declare it, and it keeps on incrementing it. So it has a growth factor defined within, which you need not take care of at this point, which you need not think about it at this point, because those are internals to Java. But initially, when you declare a string buffer stores space for 16 characters, which is 32 bytes. If you have string buffer, why do we have string builder, right? So string buffer, as I said, has some drawbacks. What are the drawbacks is more about string buffer is synchronized. When I say synchronized, which means that only one thread can enter it, only one thread can process it. So basically, if you have a multi-thread application, you should go with synchronization, because synchronization has some overhead, right? It has its own trade-offs. So when you use synchronized, what happens is when you move out of the synchronized methods, JVM internally has to do some operations which takes some time. So basically, it's good to avoid synchronization, and which would make the application much more faster. And that's where string builder comes into picture. If it's a single threaded application wherein you know that you don't have multiple threads which are going to access a particular string, in that case, you should go with string builder as against string buffer, because string buffer would give you a slightly lower in performance compared to string builder. Most of the things that string buffer does is done by string builder as well, as far as the functionality is concerned, but it's not thread safe. String builder is faster, but it's not thread safe, which means that you cannot have multiple threads accessing it. All right. So to keep it simple, if you have multiple threads accessing a string buffer, then you should go with string buffer. But if you have a single threaded application, you should go with string builder, which would make the application much more faster than string buffer. Again, with string builder, the default capacity is 16. When you initialize it, it stores, as you could see, it allocated 16 space for 16 characters initially. So as far as the demo is concerned, it's pretty much similar to string buffer. As far as the outcome is concerned, it's pretty much similar to string buffer. There's no difference as such. But as far as the performance is concerned, string builder is faster than string buffer, because it's not synchronized. Okay. So you define a string builder with happy and you append learning to it. Okay. And if you try to print SB1, which is appended with learning, you will see happy learning, would see it being appended. Okay. Similar to string buffer, when you delete character from index position 0 and one character from that position, you would see that the H, which is the first character, has been deleted out. So you could see that at index 1, you could insert welcome. You can see the entire string, that is welcome, being inserted between. Okay. Then you have reverse. You could reverse the entire string, pretty much similar to string buffer. So again, this one is very similar. You are appending, you are deleting, then you are inserting here, you are reversing here. This is pretty much similar to what we did for string buffer as far as the syntax and semantics is concerned. And the outcome is the same as well, just a performance change in terms of speed, right? So when to use string buffer and string builder? As I said, if you have multiple threads, you should go with string buffer to make it thread safe, but it would be slower as compared to string builder. Okay. String builder is specifically good enough when you have single threaded application, and it would be faster since it's not synchronized. So to make it thread safe, you have synchronization, which adds overhead to the performance, which takes toll on the performance. That's why string buffer is slower. Why to use object oriented concepts? So let's talk about classes and objects. So classes are nothing but it has got a state and behavior, right? As you could see, you have a class and you have different objects, right? There's a phone which is a class and which has got different types of phones, right? A rotary phone, then you have a touch tone phone, and you have a cellular phone. These are objects basically, right? So you define phone, which is pretty much generic and which has got state and behavior. Class is something that is generic, that has got state and behavior. But objects is something that is an instance of a class which would have specific state and behavior. So phone by itself, phone is a class by itself, which may or may not have specific behavior. But you could see that the specific phones will have its own behavior. You could define its own behavior. So all these three things that you see here, three types of phones are nothing but objects of phone class. State is something that is defined by instance variables, right? It's a class level variable, right? At the class level, you define something that gives state, and behavior is nothing but something that is defined by methods. Like calculator was a class wherein we had an add method, and add method basically gave some behavior to the calculator class, right? So what are attributes? So you have a class and you have attributes. Attributes are nothing but a property of an object, and in Java this is defined by your instance variables. Basically, class will have properties, which is nothing but the state, which would be defined by instance variables. And you could imagine every instance will have its own set of properties. It won't be the same, right? In terms of the phone that we saw earlier, there were three different types of phones. You could imagine that it would have different properties, right? It's not the same. So what are the naming conventions in generally used at the industry level for Java? So this is not something that is actually taken care by compiler. So even if you don't follow these naming conventions, still the compiler would pass through. But these are best practices, or this is good to have thing in the industry. Conventions is more about to keep everyone on the same page and make it easier for other developers to understand more, right? Or keep things simpler. So that's why we have conventions. If we wouldn't have conventions, then people would prefer to write in their own way, which would make us difficult to understand. All right, so for class name, it should start with uppercase. As we saw in all the examples, you would see that I have always used started with the uppercase, or it's rather camel casing. So in this case, you could see string buffer demo, right? So it starts with uppercase. You have B, which is again uppercase. You have D, which is again uppercase. This is nothing but camel casing. It starts with uppercase. Basically, it follows camel casing. Interface name is again similar to class. It starts with uppercase. You have method name, which should be lowercase always, which should start with lowercase, but you could have it follows camel casing, but it has to start with lowercase. So main is a predefined method within Java, right? So you could see main starting with lowercase. Or I created add, right? Add is again, you could see uppercase. If you would have, say, for example, add numbers, you would have something of this sort, add numbers. So if you want to append numbers to it, it should start with uppercase. So basically it's camel casing, but starting with lowercase. Whereas class name, it's a camel casing which starts with uppercase. Variable name is again camel casing, which should start with lowercase. And constant is always like it has to be everything in uppercase. So basically, if I define a constant final string, I would write something like this. Okay, so and if you want to add more words to it, it should be like this underscore. So it should be separated out by underscore. All right, so these are the conventions that's followed in the industry. by Java community. So mostly, even if you go to the source code, if you want to see something, dig into the source code of Java, you would see same naming convention being followed. Types of variables, we spoke about the types of variables. Again, to brief you through, we have local variables. Local variables are nothing but the variables that are defined in a method. So if you define something within a method, that's local variable. So arg100, or suppose I define int local var is equal to 100. So this is a local variable, right? If you remember, this is within the scope of a method. Once the control goes out of a method, your variable is no longer accessible. And also it gives space for the JVM, for garbage collector, to kick in and clean up this particular memory space. Instance variables are nothing but it's defined at the instance level. So here, for that matter, this constant is also instance variable. All right, so I can define integer. Variable starts with lowercase and it follows camel casing. So this integer is nothing but an instance variable. It's at the class level, right? When your class is loaded, when you refer to this particular class, you would have your instance variable initialized by Java. So instance variables are declared in a class, but outside a method, constructor, or any block. Okay. Class variables are nothing but static variables, and it is one copy per class. So as against instance variable, which is one per object, whereas static variable or class level variable are it's just one per class. So if you define static, this is just one per class, and this could be accessed directly using calculator dot constant example. You would be able to access it. But for instance variable, you need to have an object created. This is non-static, basically non-static instance variable. So one of the reasons why you need to access instance variable is because different instances might have different values for a particular instance variable, right? I could define calculator 1, right? Or let me put it as calculator, and we have like normal calculator. You could have one more class which is like scientific calculator. It's one more object. Now normal calculator can have its instance value as 10, and scientific calculator can have its instance value as 100. You have different values, but whereas in static, since it's one per class, it's not at the object level. So you have demo d is equal to new demo, which is an instance of a class demo, and you print message, right? D.print message, and it should print this message. So basically there's a class demo which has got a method print message, and we are trying to invoke that message from the main method. Okay, let's talk about the constructor. Constructor is nothing but when you invoke new keyword, new calculator, there's a constructor, implicit constructor for each class, which is without any parameters. So we'll talk about that. But when you do new calculator, basically there's a method which could be used by the programmers to initialize variables. If they want to initialize something, so for each instance, if you want the same value for an instance variable, you could initialize it within constructor. So basically constructors are for initialization, or if you want to do some kind of pre-processing, right? On invocation, if you want to initialize something or do some kind of pre-processing, that could be done through constructor. Constructor is used in creation of an object. It is a block of the code used to initialize an object. So when I say initialize an object, it's nothing but initialize some property or variable within your class. Constructor must have the same name as the class it is in, and it does not have any return type. So unlike method, which has got a return type, constructor won't have a return type at all, because what we are trying to do through constructor is just to initialize objects within, but you can't return something out of it. So basically constructor is a special method which you don't have control over. You're not doing anything within it. You're not trying to actually return something out of it, right? You don't have control over its invocation. It's done by JVM itself. JVM calls a special method when you invoke new or when you create instance of it by using this new keyword. Constructors are of two types, default constructor and parameterized constructor. So when I say default constructor and parameterized constructor, this is nothing but, so I'm defining a constructor now, calculator. As I said, it has to have the same name as the class. Okay, so this is a constructor. And as I said, this could be used for initialization of variables. Say I initialize this to 200. So for all the objects, you would see this being initialized to 200. That's the initialization. Okay, so I have created two instances of it, two instances of calculator class, that is normal calculator and scientific calculator. Let me do normal calculator dot instance variable. Okay, so here we are printing the value of the instance variable. Let me copy the same thing again, but in this case, the second case, I would be, as you could see here, we have a constructor. I defined a constructor here, constructor for a class, which is initializing the instance variable to value 200. So as and when you call this new calculator, a new instance of calculator would be created. The first thing that would be called is this constructor, and which would initialize it. So basically what we are trying to do here is, we are right after the construction of this particular object, we are going to print the values of instance variable to see if it assigned 200 to it. So here you could see the value 200 being printed out. So basically, if I wouldn't have constructor, then the value wouldn't have been 200. So let me comment out this one. This is how we comment in Java, by the way. This is a block comment which starts with slash and asterisk and which ends with asterisk and slash. So I commented out that one. I commented out the constructor, and you would see the value being initialized to 0. So you could see value being initialized to 0. All right, so that's what constructor is all about. Now this is a default constructor. You could have parameterized constructor, which is like integer, you provide some value, right? And you assign this value to variable. So instead of hard coding this value of 200 for the instance variable, you could pass on some value during the construction of the object. So basically what we are doing here is, I pass 30 here and I pass 40 here. All right, so I'm passing 30 and I'm passing 40 to the constructor. And as you could see here, we are initializing the instance variable to that value. So basically for normal calculator, it should be 30, and for scientific, it should be 40. Yeah, as you could see here, you have 30 and 40 being printed out, and this is the parameterized constructor. That's what this default and parameterized constructor, and that's what it is all about. So default constructor is, you don't even have to specify any constructor. So I commented this calculator constructor. Still implicitly there's a constructor put in by JVM, which is the default constructor. So it's not mandatory to have constructor each time unless you want to initialize something. So what's the difference between constructor and a method? Constructor must not have a return type, whereas method may or may not have a return type. Here you could see that unlike the methods add integer which return something, this doesn't say anything. This doesn't return anything because we are not doing anything within it. We are just initializing it, initializing some instance variables, right? Constructor name must be same as the class. So this is a contract. This has to be followed. Constructor has to have same name as the class. Since you are not invoking the constructor by yourself, it's done by the JVM. You don't have control over invocation of constructor, and you have to follow the naming pattern that Java recommends to, or Java forces us to. You have to make sure that constructor is given the same name as the class name, whereas method can have any name. As we saw the add method, you're free to use whatever method name that you want to. Constructor is used to initialize the state of an object. We saw the instance variable being initialized within the constructor. Method is basically it gives some behavior to a class, right? We saw add method, which is giving some behavior to the calculator method, which is nothing but adding up to numbers. Similarly, you could have multiply, you could have divide and stuff like that, which adds more behavior to it. Constructor is invoked implicitly, so you don't have control over invocation of constructor, which is done by Java itself. When you try to instantiate a class or when you use the new keyword, it's implicitly invoked by Java, by JVM. Whereas method, you have to invoke it manually. So basically, when you do this, constructor is called by itself. Whereas when you want to call add numbers, you have to invoke it explicitly. How does constructor work? The moment object of a class is created, the constructor of the class is called, which initializes the class attributes, right? So we saw about this. So when you use the new keyword, JVM by itself would give a call to the constructor, which could be used for initializing instance variables within your class. So type of constructors, there's default constructor and there's parameterized constructor, which we already spoke about. The constructor which is created by the compiler without any parameters is the default constructor, and the constructor with specific number of parameters is called parameterized constructor. So here we spoke about this already. So we have integer value, right? This is a parameterized constructor since you are passing parameter to the constructor. Whereas if you don't define anything, Java by itself. So in this case, you could see that we didn't have a constructor for this class, right? Array demo, we don't have constructor for this class. So Java by itself puts a default constructor for array demo, which is known as default constructor. So it's not mandatory that you need to have constructor every time since Java takes care of it. That's the differentiation between default constructor and parameterized constructor. We use parameterized constructor for passing values to the constructor and initializing something based on the value that's been passed in rather. So the default constructor is used to provide the default values to the object like zero, null, depending on the type, right? When I didn't have any constructor at all, for a moment, I'm going to comment this. So this is a line comment. When you put two slashes, it's a line comment. Okay, it's commenting just this particular line. There's a block comment and there's a line comment. Block comment is slash asterisk and ends with asterisk slash, whereas line comment is two slashes, forward slashes. Okay. So basically, I'll comment out these constructors as well. All right, now we have this calculator class. Now let me print the value of the instance variable. Value of instance variable initialized by default constructor. All right, so we don't have a constructor at all. So that's what I'm trying to say here. I commented out these constructors, right? So we don't have a constructor at all. And when you create a new calculator, JVM by itself would have a default constructor, which is used by JVM to initialize variables within. So you would see this instance variable as value as zero, because that's what the default constructor does. It assigns some value to it. It has like specific values. For integer, it's zero. If it's a class, it would be null. So you could see the value being printed as zero. If it's a class, it would assign value null. So in this case, you have string, right? And you could see zero, null, depending on the type of instance variable that we are dealing. We saw how we passed parameters and initialized it. Constructor overloading is just like method overloading without return type. Constructor overloading in Java is a method of having more than one constructor with different parameter list. Like we defined add, we had two add methods, and now I have renamed this to add numbers, but basically this was add method, right? So you could have multiple methods with the same name but different parameter list, which is known as overloading. Similarly, for constructor, you could have the same paradigm. So basically what we are trying to do here is we have a constructor with one parameter that's integer. I'll define one more constructor here with two parameters. So we define one more parameter here, and I say, for example, I put something like this. So we are adding up these two parameters and putting it into instance variable. Okay. This is constructor overloading. So here you have single parameter being passed. Here you have multiple parameters being passed. So based on whatever you pass here, suppose I say 10 and 20, or I say, so on construction, you should see 130 as the value of the instance variable. Okay, as you could see here, you have the instance variable initialized to 130, which is nothing but addition of 110 and 20. And you could have something like this, just 110, which is also okay because you have a single this thing defined as well. Constructor taking a single value as well. And in this case, it would be just 110. So constructors are nothing but methods which helps in construction of object. All right, so you get 110 here. So constructor overloading is in Java is a technique of having more than one constructor with different parameter list. So we had a demo about it. As I showed, there were multiple constructors, one with one parameter and the other one with integer parameters. And during runtime, based on whatever you pass, a particular constructor would be called. In this case, you could see that in the first case, which is shop S1, you could see the first constructor being called, which has two integers as being passed. Whereas when you create object S2, which has two integer parameters and one string, you could see that second constructor is being called. Now what's constructor chaining? So constructor chaining is the process of calling one constructor from another constructor with respect to the current object. The real purpose of constructor chaining is to pass parameters to a bunch of different constructors, but the initialization should be done at a single place. Constructor chaining can be done in two ways within the same class from the base class, and constructor chaining occurs through inheritance. So basically for constructor chaining, there are two keywords that we have. So one is this. This itself is a keyword in Java, this, THIS. This is a keyword, and this super keyword. Let's see how we do it for this particular constructor. I have this constructor which has this value, right? So instead of doing this directly, what I could do is, so here I was initializing this value directly to the instance variable. What I could do through constructor chaining is I could do this, and I could pass the value comma 0. So basically you're chaining here, right? You could see that what I'm trying to do here is I'm trying to invoke this constructor from this constructor. That's what the chain is all about. So when you say this, it tries to find constructor within your class which takes two parameters, two integer parameters, and this is the one it finds out, right? It has two parameters. And basically what we are doing is we are keeping the second parameter as 0, which means it would initialize the instance variable to whatever value you have here, right? This is what constructor chaining is all about. It's more about calling constructor of the same class within the constructor of the same class. So basically from this constructor, you are giving a call to this constructor. That is constructor chaining. Super should be the first, I think. It gives a call to the super constructor. So you have a subclass and superclass, right? What you do here is you give a call to superclass. For constructor chaining, I think this should be good enough, wherein you use this keyword to call constructors within the same class. You basically chain them together, right? We have demonstration on constructor chaining here. When you create student, you could see there's a constructor without any parameter, and we could see this Megan being called. So basically what we are trying to do here is the default name would be Megan, right? So, And again, we have one more constructor, which is overloaded constructor, which takes name. And in that case, it would give a call with the specified name and mark as 70. So basically 70 is a default marks that we are assigning, and Megan is the default name here. If you don't provide name, it would be Megan. All right, so this is what constructor chaining is all about. Static keyword. Static keyword, again, we have spoken about in a couple of instances, but I'll just walk you through this slide again. The static keyword is used for memory management. Static is non-access modifier used in Java, accessible, applicable for blocks, methods, class variables. Static keyword is used to refer the common properties of an object. So as we spoke, it's at the class level, it's not at the object level. We have it common across all the objects, right? When the static keyword is used to declare any parameter, then memory is allocated only once for that parameter. So in this example, we could see that since it is one per class, so you would have this constant example defined just once, right? It would be allocated just once. Whereas in the non-static ones, like this instance variable, you would have memory allocated for each and every instance. So basically, for this instance, you would have memory allocated for this instance variable. For again, this normal calculator that we had earlier, you would again have a memory allocated for instance variable. All right, so it's one per object, whereas the static ones are one per class. So yeah, memory is allocated only once for that parameter. All right, so here we can see that we have a static string company which has some company name put in there, and we are just displaying it, right? We can see that we are displaying ID, salary, and company. And you could see that for both the instances, for E1 and E2, you have two employees here with ID 25 and salary 25,000, and we have employee E2 with salary 30 and with ID 30 and salary 3,000, right? So we are defining two instances of employees, and you can see here we are not passing the company name as a parameter to the constructor, right? Still, when you display it, look at the output at the right side, you can see that it has displayed 25,000 and SRT traders. The company name came by itself because it's one per class. So what we are assuming is this class is basically designed just for one company, right? That is SRT traders. So all the instances of the class or all the employees that you create here, all the instances of employees that you create here will have the same company name that is defined here, since it is one per class, right? Whereas their ID and salary would be variable, which would differ as per the value that you pass to the constructor. Here we can see that company is a static variable. It allocates memory only once. So here it could be seen that you, as I mentioned earlier, you have reference variables being created out in the stack. And in the heap memory, you could see values being stored. So ID is 25, salary is 25,000. For E2, ID is 30 and salary is 3,000. And you can see the static variable. So basically static variable is stored in a different space, which is permanent generation memory. That's where the static variables are stored. So a method could have static as well. When a method is static, you need not create instance of a method to call that method, instance of a class to call that method. Pretty much similar to static variables, right? So basically I can have one more static method here. So say for example, I have private static. All right, so what I was trying to say here is you could have calculator dot, and you could directly call the display method. So you need not have instance of a class created. It's at the class level. This is at the class level rather, right? One per class. Let's talk about this keyword. This keyword is used as a reference variable to the current object. So basically, what it is trying to say here is, so if I want to print something here, let me print the instance variable, right? So within the add method, what I'm trying to do is I'm printing the value of instance variable within add numbers, right? So I'm trying to print the value of the instance variable within add numbers, which would be basically, this is where we are calling add numbers. So basically it should be 110, right? When we have such scenarios wherein we refer to an instance variable within a method, we could see here printing the value of instance variable within add numbers gives you 110, right? Implicitly what happens is it puts this dot here, this dot instance variable. All right. So what we are trying to say is the instance on which the add numbers was called, on the same instance, whatever the value of instance variable is, just print that thing out. So this is implicitly put in here. You need not use this keyword. This keyword is usually used when you have something like this, right? When you have instance variable. Suppose you have something of this sort, right? One of your parameters is same as the instance variable, right? So you want to differentiate which is the instance variable and which is this variable, right? So that's when you use this. When you say this dot instance variable, this is referring to this instance variable, and this instance variable to the right hand side is referring to this one. All right. So that's when you have to explicitly put this, or in other cases, it's done by the JVM itself. You did not take care of it. All right. So this can be passed as an argument in the constructor call. This can be used to invoke current class method. This can be passed as an argument in the method call, and this can be used to invoke current class constructor. This could be passed basically if there is one more. So say for example, you have something of this sort, which is pretty vague though, but add method taking calculator as its parameter. Okay. So I'm just trying to demo, you could actually take calculator as an argument for any of the methods within. All right. So you have an add method which takes calculator as its parameter. All right. So here, say for example, within this method, don't think about the logic. It's not logical though. I'm just trying to show you it could be done, right? So I have add and I put this. Within your method, you could pass as an argument. You could pass this as an argument. So basically you are invoking this one. So now if I print it, you can see in add numbers, you have this method being called. So yeah, here you can see printing out the add method taking calculator as its parameter. So basically it's calling this on by passing this. So yeah, we spoke about the constructor earlier. We saw how this could be used in the constructor. And one of the use cases, as I said, here you could see that similar to the example that I spoke regarding the instance variable, you could see the parameter, the name of the parameter is roll number, which is same as the name of the instance variable. This one is pretty much similar to that. You could see that the name of the parameter that is passed to the constructor is same as the instance variable name. The roll number to the left hand side is nothing but instance variable within the class info, whereas to the right hand side it's a roll number that is passed as an argument to the constructor. Similarly, for the name, you have this dot name, which is referring to the name, the instance variable in the class info, and to the right hand side it's a parameter that's passed to the constructor. That's a typical use of this. So we are creating a message here, and you can see that we are giving a call within the constructor. This is within the constructor actually. So we saw this in the previous example. Basically, this is what it does, right? This value of 0, that is what this is doing. Within the constructor, you have this, and you are giving a call. So in this case, this Annie would give a call to message string n and would print it out. So how does it work? The main function is executed. So again, this is a sequence in which the things execute behind the scenes. The main function is executed first. When an object of the class is created, a default constructor is called. Okay, in this case, the one without parameter is called, right? Then you have this dot Annie, which is nothing but you're giving a call to the constructor within the same class, but with the parameter Annie. So the JVM would check whether you have a constructor with parameter as string. So it finds it and it would give a call to that constructor, which is nothing but the constructor that you see here in a blue block, right? Then it would, similar to any method, after the method invocation is done, it comes back to the calling method, right? So after this Annie is called, it comes back here, then it prints welcome to Edureka. And once this is done, it would go back to the main method. In general, what happens is whenever a method is invoked, the local variables and everything is pushed onto the stack, similar to C, right? In C also you have a calling stack. So your local variables go into the stack, the calling method is invoked. After the method is being invoked and is completely done, it would come back to the stack and start off from where it had left earlier. So typically how the subroutines and everything work in programming language, that's how it's done in Java as well. So that's why we have calling stack. So that's a sequence of execution that happens. So let's start off with object-oriented programming concepts. This is pretty much generic. This is not something that is just for Java. So this is an object-oriented programming concept, which usually all the object-oriented programming languages use it or adhere to it. So we have inheritance, which we'll be covering up in the topics to come. Polymorphism, which is we have like static polymorphism and we have dynamic polymorphism. Cover it up in details in the coming slides. We'll talk about what is abstraction and also how Java has encapsulation or how Java is aligned towards the encapsulation feature of object-oriented programming. So let's start off with inheritance. Just to give you an analogy, you could think of inheritance anything that is derived. You have some superclass or you have something from which other subclasses are derived. When you have some feature of your parents, we say that you inherit it, right? Because you have got it from your parent. So you have a parent. So this could be analogical to something of that sort. Maybe your looks is inherited from your parents, sort of. That is exactly what inheritance is all about. You have a parent class and you could have subclasses out of it. And these subclasses would inherit the features or inherit state or the behavior, I would say, of your parent class. So to give you an example, as you could think of vehicle, right? Vehicle is generic thing, which could be a superclass. So vehicle could be thought of as a superclass. Now there are subclasses to vehicles. You have bike, which is a type of vehicle. You have car, which is a type of vehicle. You have buses, which is again a variant of vehicle, and truck, of course, is again a vehicle. So basically, this defines is a relationship. Bike, if you read it out, you could clearly say that bike is a vehicle, car is a vehicle, bus is a vehicle, and similarly, truck is a vehicle. So basically, this is something like it defines is a relationship. So let's see about how actually this classes or the subclasses inherit from the parent classes. Just to read out, inheritance is a powerful feature object-oriented programming through which one object acquires some or all properties and behavior of parent object. So as I said, it's a is a relationship. So is a relationship is represented in Java through inheritance. It could also be seen as a parent-child relationship. So subclasses are actually childs of parent classes. In the previous case, you have bike, which is a subclass of superclass vehicle. So vehicle is a superclass, and henceforth we would be talking in these terms or we would be using these terminologies. So just wanted to be sure you get it. So vehicle is nothing but a superclass, and bike would be henceforth referred as subclass. Child classes would be referred as subclass. So you have method overriding. What do you achieve by inheritance is more about method overriding to achieve runtime polymorphism. And the second thing is code reusability. As I mentioned, the subclass would inherit properties and behavior from your superclass or your parent class. So there could be some method defined in your superclass which need not be redefined in your subclass. It inherits by itself. That's the property of inheritance. If it has got a common behavior, like say you have two kinds of calculator, different types of calculator, the example that we spoke about yesterday. There could be a parent class calculator which is adding numbers as is. You provide two numbers, it adds up and it gives you. Maybe this add behavior could be added into the calculator class. Now, suppose there's a subclass of calculator wherein you have this scientific calculator or something, which is modifying this behavior of, or which is using the same behavior of add, right? Basically, though a normal calculator or a scientific calculator will have the same add behavior, adding up two numbers. Whatever you send it as a parameter, it would add it up and give you the result. So basically, you would define this add in the calculator. In the scientific calculator, that would be the subclass of your calculator. You need not redefine this add method. It would inherit from the calculator method. So that reduces code redundancy, or it helps you in code reusability. You need not redefine the add method again. We have a lot of slides to come about method overriding and method overloading. So I won't talk it right away. This is inheritance. You have a manager class and you have like employee, which is extending manager. So what we are trying to show here is e.salary. As you could see here, there's a salary property in a manager, and this employee 2 is extending manager. And we could see here that employee 2 inherits salary property. Though it doesn't have a salary property, we are able to access the salary property from employee 2. So let me give you an example. You just have to click on create new project and give some project name. I'll give Edureka module 3. So it opens up a new window. You could go to the source folder and you could right click on it and create a new class. So basically I'll do one thing. I'll create employee class. I'll follow the same example that's been mentioned here. I create com.edureka.manager class. So com.edureka is nothing but the package name and manager is your class name. So now I define a property here, say salary in that case, right? Suppose I say, maybe I'll put it as long salary. So I define a property within your manager, which is salary. Now I define one more class. So you could either define it within the same file or you could create a new class. For simplicity, I'll create a new class. It'll create employee. So it created an employee class within com.edureka package. Now let's do main, which is your entry point for the program. Now, as you could see, I haven't defined salary within employee. The first thing that I'll have to do is, we are talking about inheritance. So employee extends. This is a keyword used for inheritance. So employee extends manager. So now you could see there's a property which is salary, which is defined in the manager, and there's employee, which is the subclass of manager. And let's see if salary is accessible to employee, which is a subclass of manager. So I define employee, emp is equal to new employee. This is how we create instance of the class using new. Now let's see if, just for simplicity, I'll give this emp dot salary. You could see that, right? Just to be sure, I print out. So as we can see here, salary, though it's not defined in employee, it has been inherited from your manager. We can have one more instance created, which is like manager is equal to new manager. This is the instance of manager class now. I do manager dot salary is equal to salary of manager is, we are just printing it out. So what we have done here is, again, I repeat the same thing. So we have a manager. Within manager, we have defined a field salary, and we have employee, which is extending manager. And in the employee class, we don't have the field or we don't have the property salary defined here. But we could see here in this example wherein we created the instance of employee and we are accessing salary property from here. though it's not defined specifically in employee. It's been inherited from your parent class, that's manager. And manager, of course, has salary field, which has been accessed out here, and we could assign some value to it. I run the program, it should compile and create a class file out of it, and it runs the class file using JVM. So yeah, as you could see here, it's printing out values for salary of employee and manager as well. So that's about inheritance. It's inheriting the property salary from parent class. Now, what are different types of inheritance that we have? There's single inheritance wherein you have a parent class and you define a subclass out of it. So similar to what we spoke, we had a manager class and we had employee class, which was inheriting manager. That's about single inheritance. You can have hierarchical inheritance wherein you could have multiple classes inheriting from a same class. So you could have A and B inheriting from a single class. You could have multi-level inheritance wherein you have one class inheriting from another, and again you could have subclass of the subclass. Parent class, you inherit it or you subclass it or extend it, whatever you say. So there's one level. So you have a child class now. You could have one more subclass of this child class. That's what multi-level inheritance is all about. So as we go through the example, it should give you a clear idea about what I'm talking about. So single inheritance, so we have vehicle and we have bike, which is extending vehicle. So this is similar to what we defined here. So what we did here is single inheritance. You had a manager and you subclassed it, and this is just single inheritance, one level. So what is hierarchical inheritance? So you have a vehicle and you have two subclasses created out of vehicle. So there are two childs of a parent class. So this could be pretty much similar to a parent having two kids, right? There could be two kids and they inherit some property from your parent. So it's pretty much similar to that. So you have a vehicle class, which is your super class, and you have subclasses to it. So let's see how this works. So I create a vehicle class, which is the super class. I have a vehicle class, and say vehicle class has a property which says integer, say number of wheels. This could be one of the property of a vehicle class. You have, say for example, you have the mileage. So these are common properties that you have in vehicle. Say you have motion. Just to add a behavior to this particular class, I define method move and I just print this thing out here. I define two properties here for vehicle class, which is number of wheels and the mileage, and add a behavior to the class by introducing method, which is move, which is nothing but I'm just printing it out. So ideally you would have some functionality written within, or you would have lines of code written within. Just because we are talking about inheritance, just to show the properties and behavior is been inherited by the subclass, for simplicity's sake, we don't have any logic written within move. It's just printing it out saying that, just to indicate that there's a move method within the vehicle class is being called. We are just printing it out there, but in reality, as I said, there would be actual logic written within. So now I define car class and I define bike class. So now I say that car is extending, which is nothing but subclass of vehicle. So remember we said is a relationship, car is a vehicle. So what we are saying is we are subclassing or we are inheriting properties of vehicle into car. Suppose I change the property of any method within, or say I can have its own movement when car class. So basically we are overriding it. What we are trying to do is we are trying to, whatever method you had within your car class or the vehicle class, you are overriding it for the car class. You are trying to change something. Similarly, in your bike class, you could override the move. So first thing that we'll have to do is bike should extend your vehicle. So bike is a vehicle, we are extending it. Now we are again overriding this move method to say move in bike class. So now basically we can have, say, one more just for simplicity's sake. We have just a class wherein you would write the main method. So this is generally a practice wherein such classes are called as client classes, wherein you have a main method and you do something with it. I just call it as automobile management class. So you have a main method. So suppose you want to change number of wheels for a car. So what you would do is car is equal to new, or it won't be car. It would be like, suppose I put Mercedes is equal to new car I create Mercedes, I create BMW is equal to new car. So now what we do is I want to override the property that is number of wheels for Mercedes to 4. Similarly, I could have a bike class, say R1 is equal to new bike or something of this sort. You could have Ducati is equal to new bike. So this is just to give you an idea of how we have classes and objects, right? Now you could imagine what objects is all about. So Mercedes is a object of car, BMW is a object of car, R1 is a object of bike, and Ducati is again an object of bike. So now I could override the properties here, say number of vehicles as 2. So yeah, this is what it is all about. This should give you some idea about how we use Java. You have a class, you have subclasses, then you kind of create objects, and you could override the properties within. And you could change. When I say override, is nothing but you could modify the values within your subclasses. And similarly, you could change the behavior. Vehicle by itself would have some behavior defined, but Mercedes and BMW, which is a car, could have its own kind of behavior, which is not inherited from parent. You are overriding it. When you say this could be analogical to something like kid doesn't have the same features as their parent. It is something like it's been overridden, right? It's peculiar to that particular kid. And that's what this is all about. So you could override it. Now let me print move, or let me call the move method on BMW. So you could see a move method, and when I run it, it should show move method in car class, since it's a move method called on car. BMW is an instance of car. So this should give you some idea about how are we inheriting properties and behavior from parent class. So here we can see that move in car class. So again, you could define your own method within your subclass, which is not something that is inherited from your parent class. So BMW by itself, or car by itself, could have something like, say, turbo, which is not in vehicle maybe. This is specific to car. So this is what we spoke about, is hierarchical inheritance. Now let's talk about multi-level inheritance. So basically it's nothing but, say you have a superclass category. So let me use the same example. You have a vehicle class, you have a car, which is extending vehicle. Now I define one more class, which is nothing but superclass, supercar, which is extending car. Basically, I can put this turbo in supercar rather. That would make more sense. This is like kind of multi-level. So I'm putting this turbo here in supercars. You have a vehicle class. You have a car, which is subclass of vehicle. You have a supercar, which is subclass of car. So all the properties that you have in vehicle class could be accessed in car as well as supercar. That's what we want to see here. So you could have something like, say, change wheels, which is void, which is not returning anything here. I just want to show you that we can still access number of wheels here. Though it's not defined in car or supercar, but in vehicle class, you could actually, it is still visible here and you can modify it. That's the beauty of it. Again, to brief, you have a vehicle class, you have a car class, which is extending vehicle class, you have a supercar class, which is extending car class. So basically, there's a multi-level of inheritance, and all the properties and behavior that you have in vehicle class would be visible to car class as well as supercar class. And supercar class can access properties and behavior that is there specific to car class. So what I'm trying to say is, if you define a new method here, so I just mentioned here behavior specific to class to car. So there's some behavior that is specific to car that we have defined within the car class. Now supercar class can access this one as well. So you could see here, you could access behavior specific to car as well. If you look it as a tree, this is a leaf node. This is supercar class can access everything from vehicle and car class, whereas car class can access everything from vehicle class. But it's not the other way around. Car cannot access something that is specific to supercar. There's a turbo method that we have put into the supercar class. Now, if you try to access turbo from here, you won't be able to access it. All right. So it's not the other way around. So you cannot access something that is specific to your subclass in your superclass. whereas you can access anything that is there in your superclass into your subclass. So it's a one directional flow from superclass to subclass. Now let's talk about has a relationship. Has a relationship is nothing but you have properties within your class which is has a relationship. All right. So say for example, employee, right? We define the employee class, and employee would have an ID specific to a employee, and it can have salary and stuff like that, which is has a relationship, which is nothing but employee as a ID sort of, right? So a department in a class, let's talk about this example. A department in a college has several professors. Without existence of departments, there is good chance for the professors to exist. Hence, professors and department are loosely associated, and this loose association is known as aggregation. So one can exist without other, which is loose association, and such thing is nothing but aggregation. So here you could see employee, here you could see name class itself, which has got first and last name. So basically you have a name class which has got property as first and last, and which is nothing but the first name and the last name of any entity. It's not associated with anything. Right now it's a different entity. Name is a different entity which would have first and last name. Now there's an employee info class which has got ID and which has got name. So you can see name here. This name property is nothing but the instance of name class that is there at the left hand side. So this is has a relationship. This says that employee info has name. So basically this is what it is. When you talk about has a relationship, it's containment. It's basically you have class as a property in a class. So in this case, name is a property within your employee info. And similarly, this name could be used somewhere else as well. It's not that it has to be used just in employee info. That's a kind of detachment they have, right? It's not tightly coupled, it's loosely coupled or decoupled. So basically, you have name, which is altogether a different entity defined as a class, which would have first and the last name, and you would have an employee info, which is containing name, which has name. So this is has a relationship. And also to give you idea about has a relationship, it's not just it has to be object, right? So vehicle has number of wheels. Vehicle has mileage. This could be thought of as a relationship. So let's talk about polymorphism now. When one task is performed by different ways, then it is called as polymorphism. Poly is multiple, morphism is forms. Basically, that's the meaning behind it. So multiple forms, that's what polymorphism means. And when one task is performed by different ways, then it's called as polymorphism. There's person, which is a superclass. You have a subclass. Student is again person. Millionaire is a person. These are superclasses. So you have a person class, you have a superclass student and millionaire. You have a behavior which is nothing but pay bill and which would be specific to both of them. So as we move on, you would get much more idea about the different kinds, but basically you have multiple forms. That's what polymorphism is all about. So what is method overloading? So we spoke about this yesterday. If you remember, we spoke about constructor overloading, wherein you had multiple constructors defined. One was integer, and the other one was like it was taking three parameters, integer, and three integers, right? So basically, this is what method overloading is all about. You have the same name of a method, but you have different number of parameters passed to the method, or you have different type of parameters passed to the object, to the method, and based on that it would understand which is the method that needs to be called. So suppose you have add with two integer parameters defined and you have add with three integer parameters defined. Now when you invoke add method on a particular instance of calculator and you pass two parameters to it, it would appropriately call add method with two parameters. And if you pass three parameters to it, it would call one with three parameters, or it would resolve it during the runtime, which one to be called. Rather, it's not overloading doesn't happen during runtime. It's done during the linking or the resolving operation happens during the compile time itself. That's why it's static polymorphism. Method overloading is nothing but static polymorphism. So return type is not taken into consideration when it comes to method overloading. It's just the parameters that a particular method takes. So Alex wants to write a code which can be used to find out the area of triangle as well as of circle. So generic code which would have area of triangle and circle. So such are the instances wherein you could use method overloading. So what's the thought behind this? I want to find area of both the shapes. Here area is a common method. It's there for both the shapes. It's there for rectangle, it would be there for square, it would be there for circle, and so on and so forth. So basically you would have a shape method which would have area, which is a common method. So instead of writing two methods of different names, I'll write area as a method name for both shapes, and I'll pass different arguments according to the respective shape. So instead of defining multiple area methods, you would have just a generic area method defined in your shape class, and your subclasses would overload it as per the type of shape. So here we can see that there's area class, there's the area method, which is taking integer. Since it's a triangle, it's base and height. So it's taking base and height as parameter. So Java doesn't understand base and height. This is user defined, by the way. It understands there are two integer parameters passed to the area. Whenever there are two integer parameters passed to area method, this one would be called. The other one is, again, we have one more method which is area, which is by the same name, and which is taking just one integer parameter, which is radius. So this is supposedly for circle, pi r square. So during runtime, when you call it, so I'm not repeating this exercise again because we did the same thing yesterday, if you remember. We kind of had multiple add methods in the calculator, and we saw that it was getting resolved to the proper one based on the number of actual parameters that you pass. So I'll just read through the slides to make you give more explanation on this, but it's pretty straightforward. So here you have area method, which is taking 4, 6, which is nothing but it would get resolved to, during compile time, this particular area method invocation would get resolved to this one, since it is taking two integer parameters. The second one is taking just one integer parameter, which is 5. So it understands that it has to call this area method, the second area method that's been defined in method demo, and it will call it accordingly. So here you could see that when you run this particular program, you could see that the first one resolved it to triangle, and it said that the area of triangle is nothing but 4 into 6 into 0.5, which is nothing but 12. The second one goes to pi r square, and it gives answer as 78.5. So you could see there are two different invocations done based on the number of actual parameters. Now let's talk about type of parameter. The method overloading can happen on type of parameter as well. So you could have multiple methods with the same name taking same number of arguments but different data types. One could be taking integer as a parameter, the other one could be taking string as a parameter. And during runtime or during compile time itself, it would resolve that, this one should be resolved to this invocation and the other one should be resolved to the other one. So basically it tries to resolve based on the parameter, based on the data type of the parameter that you pass. So here's the example wherein you have two different methods. I'll take this one, say for example, I define public integer, so it's a dummy value to be printed. One of the best practices when you write Java code is to express it, right? So you can have a big variable name. You shouldn't be restricting on variable name, which makes it difficult for other programmers to understand. So it's good to have big variable name versus small one, which is not that expressive. So here I said dummy string value to be printed. I'm printing integer value, which is nothing but dummy integer value. And here I'm printing. So we have two methods with the same name, but it's taking different data types as argument, and we are just printing it out. So I define a main method here, and I define manager. So we have instance of manager, say senior manager grade 2 dot display. I pass integer to it. I pass 100 to it, and I pass. So I have two method invocations here. One is first one we are passing 100. The second one we are passing string to it, and it gets resolved. You could see that the first one would go to this display method, which says printing integer value. The next one would go to this display method, which prints string value. So you could see here, right? So first one is printing integer value. The second one is printing string value. So based on the type of the parameter that you pass through or pass to the method, particular method would be called. This is static polymorphism. Now what's runtime polymorphism? So since it is resolved during the compile time, it is static polymorphism. There are a few things that gets resolved during the runtime, or the compiler cannot judge it upfront what the instance would be, and that's when it does it during the runtime. And that is nothing but dynamic polymorphism or method overriding. So method overriding is mostly used in a either relationship. So in one of the methods, or we saw in vehicle and car example, we have a move method here, and here we overrode it. You can see a override annotation here for the move, because you are overriding the behavior of vehicle in car class. So that's where it says that there's a easy relationship. Method overriding must be used in case of inheritance, that is easy relationship. Method must have the same name as in the parent class. We saw in the move, in the example move, we have the same name as in the superclass. So vehicle has a method move and car has a method move as well. Method must have the same parameters as in the parent class. As against method overloading, which has different parameters, method overriding, you have to be sure that it takes the same parameter. If I change this to integer, if I add an integer parameter to it, so it's not taking it as overriding. You could see it's not been taken as overriding because you have integer parameter to it. So basically it has to have same number of, or it has to have the same signature as your parent class. So that's about method overriding. Let's have a demo on this. So which we already saw, but I'll again reiterate on that. So basically in this example, you could see there's a man class which has got a pay method, which is adding behavior to the man method. And you could see it's a dummy print there. And you have a millionaire is a man, and you could see it overrides the pay behavior. When you run this program, one thing to note here is you can assign millionaire to man. You can assign, unlike all the examples that we saw, we are creating instance of the same class or assigning the instance of a class to the same class. But in this case, you could see the instance of millionaire is being assigned to reference of man. This is something that happens only in either relationship or inheritance. So what I'm trying to say here is I go to automobile management. I have car. I have a new car, which is Mercedes. I could assign this Mercedes to vehicle. Since Mercedes is a vehicle, it should be assigned. You should be able to assign it, right? This is something that you need to keep in mind. Your subclass object could be assigned to superclass. So here we have Mercedes being assigned to vehicle. But one thing to note here again is the tricky part is vehicle itself has its own move method, which prints move in vehicle class. And Mercedes, which is car, itself has its move method, which is move in car class. So the tricky part here is when you would do something like vehicle.move, just give a thought about it, which one should be called. So you have two variants of move method here. You have one in car and one in vehicle. So the one in vehicle is printing out move in vehicle class, and the one in car is the overridden version of vehicle, which says move in car class. Now what we are doing here is we are creating an instance of a car class, and we are assigning that instance to vehicle, and we are calling the move method. So just give a thought whether the move method on the vehicle class would be called or a move method on the car class would be called. So this is where method overriding comes into picture. So method overriding is nothing but it's a runtime polymorphism, which is done at the runtime. So during the runtime, JVM would see that Mercedes is nothing but the instance of car. Though it's assigned to vehicle, which is superclass, still an instance of class. So during compile time, JVM wouldn't have upfront knowledge that which move are you calling? Is it on vehicle class or is it on something else or some subclass of vehicle? So it doesn't decide it during the compile time. It delays it, or there's a lazy binding that happens, delays it till the time you run it. So when you run it, it understands that this vehicle is actually pointing to car, that's Mercedes. So when you run this, you could see that I'll comment out this piece of code. So this is how we comment out. That's a block comment. So when I move this, you could see that move class on car is being called and not vehicle. That is what is. If you get this concept, you're pretty good in terms of object oriented, by the way. This is an important concept in object oriented paradigm. So you could see here move in car class is being called. Similarly, vehicle could have, I call it as vehicle one, right? I define one more vehicle here, which is like new vehicle, and I invoke the method on vehicle two. So the second variant would call the move method in a vehicle class. The first one calls on the car class, the second one calls on the vehicle class, since it's an object of vehicle itself. So basically, you have to see on the right side which is the object that's been assigned. Since it's object of vehicle, it's vehicle. But since this one is object of car, that's the reason you have car class being called. So we had some discussion on this keyword yesterday. So super keyword is similar to that. Super keyword is just that it is called on super class. This is called on the same class. Super is called on the immediate subclass, immediate parent class. You could have multi levels, right? But this one is calling the immediate parent. Used to refer immediate parent class instance variable, used to invoke parent class method. And there's one more super keyword, one more form in which you could use is to have class constructor. So basically, whenever you create a class, whenever you call a class, whenever you call constructor of a class, by default, JVM by itself would give a call to the superclass constructor, which we would be looking at in the further slides. So here we have vehicle 11, which is a superclass which defines string wheels. Vehicle moves because of wheels. So that's a string, that's a property of a vehicle. You have a truck which extends vehicle, and then within truck you have your overriding the wheels property saying that truck has 4 wheels. This is kind of your overriding the property. It's not called overriding though when it comes to properties, but basically you're changing the values within your truck class. Print wheel is nothing but a method that's defined in a truck which would print the number of wheels in your truck class, and it has got super dot wheels which would print the number of wheels in your, or print the value of the wheels, not number of wheels, value of the wheels property within your vehicle class. So we will look at this one. So we have a vehicle class and we have a string wheels, which is a property within a vehicle class, which has some value put in, right? We have a truck class again, which has got wheels and it is overriding the value. It is just changing the value as truck has 4 wheels. Within truck class, you have print wheel method, which is printing the wheel or the value that this particular wheels property holds. It would print it. First one would be the value that this particular truck class would hold. And the other one that you see here, the second print statement, which is doing super dot wheels, is actually printing the value of wheels in vehicle class. So let me show you a quick demo on this thing. So we have a vehicle class, which wherein we are defining the default number of wheels as 4, say for example. And now we have a bike class, which is overriding vehicle class. And what we are going to do here is we are going to change the value of number of wheels. I have a method to print number of wheels, which would give, so suppose I change here number of wheels to say 2. So here we print number of wheels first, and I would have one more print statement which would be printing super dot number of wheels. Within a by class, we have a print number of wheels method. First, we are changing the number of wheels to 2, and then we are printing the number of wheels for bike and number of wheels on the super class. All right, and by default, we have set the number of wheels in the vehicle class to be 4. So we have a bike class. Now I remove this too. So now I print the number of wheels. So I create the instance of bike and I invoke print number of wheels. Now you would see that first it would print 2, and on super dot, basically this is what it's going to call. So first it will print 2. So basically here we need to have one more integer number of wheels. When it comes to instance variables, it's not overridden as such. So I have like number of wheels defined here again, and here I change number of wheels to 2. So let me run it again. So when it comes to instance variable, when you define one more field here of the same name, it's not overriding it, it's rather creating a new instance variable. So now you could see that when you print number of wheels, it's printing out 2, which is nothing but the value here, value of this instance variable. Whereas when you do super dot number of wheels, you have a default value of 4 here, which is being printed out. So on super, it gives a call to super class. So here you're creating, it's at the constructor level, and we can see that. So it's more about, as I mentioned, within your constructor, the first thing that is called when you create a instance is the super constructor is called first, and then your subclass constructor. What I mean to say is when you create instance of car, so your first thing that would be called is the constructor of vehicle, and it would do all the initialization that's required in vehicle, and then it would call the cars constructor. So what I mean to say is, for example, I create a constructor here and I print saying that we are within constructor of vehicle of superclass vehicle. Now we have this car class, and say we have constructor for car class as well. Remember we said that there's a default constructor, implicit constructor that's already been put by JVM itself. You don't have to take care about it. So I don't do anything here. So basically you did not write constructor. JVM by default writes constructor unless you want to write something or you want to initialize something. That's when you would write explicitly, you would write constructor. But in this case, since we are not initializing anything as such, I won't put a construct for car. What I'm trying to say is we are creating an instance of car here, and let's see, when we create the instance of car, there's a super constructor that's been called. That's what I wanted to show. So that's why we created a constructor here for vehicle. This is not a method, this is constructor, by the way, since it has got the same name as your class and it doesn't have any return value. So I've printed it out saying that we are in the constructor. When we call this now, when we create the instance of car, you could see that this constructor of superclass, that's vehicle, that's been called. So this is done implicitly by compiler. You don't have to care about it. So here you could see whenever you create the instance of car, you would see that we are in constructor of superclass vehicle. And the second print statement that you see is directly for the vehicle instantiation. So even for car, you could see, so this will get rid of confusion. So there's only one instance of car being created and we can see that it is calling vehicle constructor. And it's implicitly put, we don't have to explicitly put it. JVM by itself operates that way. And how it calls is nothing but by super. Final keyword, we again touch based on this one earlier in the session number 1. Final keyword is non-access modifier applicable only to variable, method, or a class. When it's applied to a variable, we say that the variable content cannot be changed. Usually use final when you want to define a constant within your application. So that's final. A method could be defined as final. You define a method as final when you say that your subclass cannot override it. That's when you define it as final. You define a class as final when you say that there cannot be any subclass of that class. So you cannot subclass it. Like if you try to extend on a final class, you would get an error, compile time error saying that you cannot extend it. So just to show you, maybe if I make this as final, your car would show an error saying that you cannot inherit from final class, that's com.edureka.vehicle. So that's about final class. And if you make this method final, you would again get an error in the class saying that you cannot override this. In the car class, we are trying to override the move method. Since it's final, it's showing you an error saying that move cannot override move in com.edureka.vehicle. Overridden method is final. Let's remove this final and you should see the error is gone. And also, if you want to see at the instance level, if you define this as 4, number of wheels as 4, now within this vehicle, if you're trying to modify this number of wheels to 2, it would throw you an error saying that cannot assign a value to final variable. All right, so that's what it is. It's not an access modifier, but it regulates it in a way that you can't change the value. In case of variables, you can't change the value. In terms of class, you can't subclass it, or you cannot create a child class of a final class. And in terms of methods, if you have final method, you cannot override that particular method in your subclass. So final modifier can be applied to class, method, instance variable, class variables, local variable, and method parameters. So final variable is used to create constant variables. When it comes to variable, as I said, usually you use final variable when you want to have constants, right? And it would be final static, by the way. If you have a constant, it's usually final and static final. Final methods is used to prevent method overriding. In terms of method, in the demo that I showed you previously, we saw that we cannot override it. In terms of class, when you have a final class, you won't be able to create subclass of it, which we saw, right? It gives you an error. Some examples of final class in string class. So system class in java.lang.package is final as well. String class that we have been using, string class that's been exposed by, or Java itself has, or Java by itself defines it, that class is final as well. If you try to extend string class, it would show you an error. It would give you an error. So system is kind of putting a contract, or Java by itself is putting a contract, or is saying that cannot extend the string class. You cannot extend its behavior. You can't change anything, any of the behavior within your string class by your own. That's why they have marked it as final. If a method is declared as final, then it cannot be overridden in your child class. If a variable is declared as final, then you cannot change the value of that particular class, or cannot change the reference of that particular class when it comes to objects. So we'll see that later. A constructor cannot be declared as final. So that's a rule. You cannot declare the constructor as final. And blank final variable should be initialized in constructor. So maybe in this case, if you wouldn't have any value here, you declared this as final. If you don't have any value here, it has to be assigned in constructor. Right now it's giving an error saying that it's not initialized. If you mark it as 4, it should be gone. So it's mandatory that if you put an instance variable as final in class, it's mandatory that you assign some value in the constructor. If you don't, then compiler would throw an error. So here you can't override it. So basically you have a final method void run, and you have a subclass of vehicle, and you're trying to override the run method. It shows you an error. So this is what we saw in case of move was final, and when we tried to override it in car, we got an error, and it's all compile time. If you declare any class as final, you cannot override that class, which we saw. It gives you a compile time error. So when you declared a vehicle as final, and when you try to extend, when you try to create car class, which extends vehicle class, it gave you an error because vehicle class was declared as final. Again, this is a compile time. Now, what's dynamic binding, which is also known as runtime polymorphism, is nothing but during runtime, it decides which instance of a method should be called, or which method should be called. So this is in case of, again, inheritance, and when you override the method in your subclass. So we saw this earlier. Again, to show you, we had this move method here, and in car you have this move method, and in automobile management we did this thing. We have a Mercedes that is assigned to class reference, rather, vehicle class reference of reference named by vehicle 1. And in the second thing, we have vehicle itself. So first one is pointing to a object of car, which is Mercedes, and the second one is referring to object of vehicle itself. So this is what dynamic polymorphism is all about. The first one gives a call to the move method in car. The second one gives a call to the move method in vehicle. So yeah, you could see here. So move in car class, and then it calls a move in vehicle class. And it happens at runtime. That's why it's runtime polymorphism. So abstraction is a mechanism of hiding the implementation details from the user and only providing the functionality of a user. So basically you could have abstraction wherein on the first day we spoke about the shape class and the circle class and triangle and square and stuff like that, right? So basically shape is a class which is an abstract class which doesn't know all the functionality upfront, or it doesn't have all the behavior upfront. It doesn't know what would be the behavior of a circle class, or it doesn't know what is the behavior of a square class. When I say behavior, it's nothing but calculation of area. Calculation of area is nothing but it adds behavior to the class, and calculation of area in your square class would be different. Calculation of area in your circle class would be different. So shape by itself doesn't know what's the implementation of area method, I would say. So that is what is abstraction. There are two ways in which you could provide abstraction in Java. One is by abstraction class, which is not 100% abstract. which could have like abstract methods, like area in this case is abstract, but there could be some methods which is same throughout or common throughout all the subclasses of shape. Say for example, printing area. You just have to have a print statement which is printing area for a particular shape. From the implementation per se, it's same throughout all the classes. Area method would be something that is abstract, whereas display area could be something that is non-abstract method. So in such cases wherein you have blend of abstract as well as non-abstract methods, that's where you use abstract class. So it's not 100% abstract. Whereas in interface, it has to be, interface is something which says that it has to be 100% abstract. So interface is altogether a new construct that we have in Java. When it comes to abstract class, abstract is just a modifier to a class. So you write class and you just prepend it by abstract, which makes that class an abstract class. Whereas interface is something that is a new construct that we are going to see in the coming slides. Abstract class and abstract methods. So abstract method is, as I said, area would be abstract method in this case, wherein you don't have a concrete implementation of area in your shape class. That's the scenario in such cases wherein you don't have a complete concrete implementation of a particular method, you would declare it as abstract method. And if you have an abstract method, if you have at least one abstract method in your class, you have to declare that class as abstract class, or else compiler would throw an error. So whenever you have a abstract class, it means that there is at least one method within that particular class which is declared as abstract. So when you subclass this abstract class, so shape for that matter, when you subclass shape, shape has got a area method which is abstract. Now when you subclass it, when you create circle, which is nothing but class circle, which extends shape, now you are creating subclass of it. In that case, you have to ensure that you implement area. If you don't implement area, it is still kept as abstract, and you will have to make circle class as abstract as well if you don't give the actual implementation. So an abstract method is a method that is declared without implementation. Any class that contains one or more abstract methods must be declared with abstract keyword. An abstract class is a class that is declared with abstract keyword. An abstract class may or may not have all abstract methods. So as I said, it's a mixture of abstract and non-abstract methods. An abstract class is mostly used for inheritance. So let me take the same example of shape and shapes. So we define a shape which would have abstract area. This is what I was saying. So when you have at least one abstract method, the compiler would throw an error. So in this case, it is saying that you have an abstract method, but your class is not abstract. So we have to make this one as abstract. And as I said, abstract class is nothing but a modifier. You just have a modifier that you need to prepend to the class. This is abstract method. And you say you have a method which is public void. It's not returning anything. We are just displaying area. Now, rather than defining it here, maybe I'll put something like, so we have a shape method, and now I declare circle method. Now this circle method is extending shape. Now it's throwing an error and it says you have to implement the abstract methods. Shape has got abstract method. If you don't implement it, as I mentioned earlier, if you don't implement it, if you choose not to implement the area method, then you will have to make this abstract. If you make this abstract, the error would go off. But in this case, since we know the concrete implementation of area for circle, we'll have to implement it. When I say we'll have to implement it, we say area and we override it. So for simplicity reason, I'll just put some value here for now. Since we are talking about abstraction, I'll just keep it simple. So basically what we are trying to do here is we have implemented area, which would be nothing but your pi r square actually. So here we have a shape class and we are overriding the area method here, and this is how you abstract it. When you run it, so basically you could have something like, suppose I create a shape utility class. So this is pretty much like overriding methods. So you could have a shape class, shape circle is equal to new circle, and you could call circle dot area. So basically what you would get is nothing but a float value, which is your area of, let me put it this way, area of circle. When I want to print it, what I would do is circle dot display area, and I print area of circle. What we have seen here is there was an abstract method area which was implemented in your subclass, that circle, and when you give a call to it, and here you could see that again, similar to vehicles that we spoke about, instance of circle is being assigned to shape, and when you give a call to it, you could see that method on circle is being called and not on shape, because shape by itself doesn't have any implementation of area. So one thing to note here is when you have abstract class, so here you could see this value being printed out, right? Abstract class would have one or more abstract methods for sure, and when you subclass it, you have to ensure that you give implementation of your abstract methods. If you choose not to implement it, then you will have to make the subclass as abstract as well. So execution of abstract method, this is pretty much similar to normal execution that we have. So the main method, you have instance of mobile class created in this case. Then there's a default constructor of mobile class gets executed. So pretty much similar to normal execution. When you create instance of Nokia, which is subclass of mobile, as I said, the first statement that you have in the constructor of subclass is nothing but super, or it calls the super constructor. So here we can see that the default constructor for super is being called when you try to instantiate Nokia. As we are running run method, but in mobile class run is an abstract method, so run method from Nokia class gets executed. Similar to the example that we saw, so shape area class area method on circle got executed and not on shape. What is encapsulation? Encapsulation is a methodology of binding code and data together into a single unit. So basically everything, it's an encapsulation. It's put as one. So you could imagine class being put as one, right? Class has got this for that matter. You see everything being encapsulated as one, right? You group this together. You group this integer and long, which is a property of vehicle, and it has got some behavior as well, which is move. It's all encapsulated as one, or it's all put together as one entity. That is nothing but encapsulation. So basically, you could imagine a capsule, right, which has got multiple ingredients, which has multiple medicines or chemical components, which are put together into one capsule, and you think capsule as one medicine, but it's basically combination of chemical components within. Other thing is for encapsulation, there's access modifier comes into picture. You have this access modifiers of private, and you have public, you have protected, you have default. This access modifiers restrict, or it restricts the visibility of a particular component of a class, say method or variable or anything. So that's an encapsulation feature of object oriented programming. You can't see everything. It's not that everything is open for everyone. So you can have restriction. You have different levels of restriction when it comes to visibility of these components. That is a part of encapsulation as well. So to achieve encapsulation in Java, declare the variables as private. Usually the best practice is not to expose everything, because once you expose something as public, or once you expose it for the application to access, you have to ensure that you maintain it, right? Because anyone can access it. So your class is becoming much more fragile. I won't talk about these topics right now, because fragility is something that is related to code quality or coupling, we say. So I don't want to touch on that, but basically the best practice is to have less visibility, restrict visibility or refrain visibility as much as possible. Try to make it as much less as possible. Make it private. Basically, if you could make all the variables as private, it would be a good thing. So basically, all non-private or public variables are liability for application. So it increases the maintenance of the application, and it's easy to break that way. If you make some changes to a class, it becomes very difficult in the future to maintain it. So usually the general practice is to keep the methods variables as private, not methods variables as private, and we have getters and setter method, which are public methods, or mutator methods, which would expose this variable to the outside world through public. So usually we don't have setter methods, we restrict setter methods again. Usually you have a private instance variable, and you have a getter method, which is a public method, which is nothing but returns the value of the instance variable to the outside world. So data hiding, the user will have no idea about the inner implementation of the class. What are the advantages of data hiding? User need not know the core implementation of the class. It increases flexibility. We can make variables and methods read only and write only as per the requirement. So imagine if you didn't have all these access modifiers, there's only one that is public, which is exposed to everyone. So it would create a havoc. So this is basically based on your requirements. You could have different patterns of this access modifiers used within your application. It makes testing easy. So basically, third point is reusability, easy to reuse and easy to change with the new requirement. So with reusability, even the maintainability of the particular application is improved when you have this encapsulation. And easy to reuse in the sense, if imagine the other way around, wherein you have only private methods. So a class could access only the instance variables within a class, nothing from outside world. It cannot be accessed from outside as well. Imagine such a scenario, right? In that case, you would have a lot of code redundancy, right? Everywhere you would write the same code. It might be the same thing you have already implemented in some other class, but you will have to re-implement it since it's not accessible outside the class. So that's how encapsulation increases the reusability of code, and it makes testing easier, of course. So here you could see that employee one. So this is the encapsulation mutator method that I was talking about. So basically you have employee one, which has got string name, which is private. You could see here it's defined as private. When I say private, this name property would be used only within this class. If you try to access it from outside class, you would get an error. But there might be scenarios in which you want to access this name from outside class. You want to understand what its value is. In that case, you would have something like this, right? You would have getter method, get name, which is nothing but its return type is string, which is the data type for name, and it's returning the name. Now, one thing to observe here is this is public. This one was private, name was private, but get name is public, which means it could be accessed from outside as well. Similarly, you could have setters, which is not a good practice, by the way. You shouldn't have setter methods. So again, setter is something like you pass the value that you want to set this particular name variable. So basically you are saying that whatever you send through this method is going to set to the name variable. So yeah, refer to this particular example in main. So you create an instance of employee one who have e dot set name. You are setting it to Alex, and when you access it, you do e dot get name. So basically what we are trying to say here is a demo encaps is a different class. It's not the same class. So you have employee one and you have demo encaps as a different class. Though it's a different class, still you are able to access your name, employee name from this class. This is again a private instance variable. You're able to do this just because you have these getters and setters. Let's understand interfaces. Interfaces are nothing but could imagine interface as a blueprint, or it is something that it's a specification rather, right? An interface could be thought of as a specification. This is how it should be. So basically it could be say a company manufacturing bottles or remote, right? It would say that this is how it should be. Basically there should be so and so buttons, there should be this button should be here, this button should be there, and something of that sort. So basically through interface, what we do is we specify the contract. We say that this is how it should be. Now, for example, you could have specification mentioned in a piece of paper. This is how a remote should be. And there could be different vendors for this remote who would be actually manufacturing remote and which would be aligned to this particular remote specifications. Then you could check that okay, so and so specifications are met, which means that this particular thing could be used as a remote. So basically these are nothing but these are specifications for the system. So through interface you say that this is how it should be, and you would have different vendors or you would have different implementations that align to the specifications, and if they match up to the specification it means that it's a correct one. So hence an interface contains all the specifications and can be used for creating a new remote. So all you see here, there's a joystick, there's AC remote, there's TV remote and everything. It has got different things, but there's something in common, and that's what you specify through interface. An interface contains variables and methods, but the methods declared inside interface are by default abstract methods. As we saw in the earlier slide, interface is 100% abstract. So all the methods that you have within interface is abstract. An interface is used to achieve abstraction. It is used to achieve loose coupling. When I say loose coupling, it's like you are not binding everything into a class. Basically, you say that if it's a remote, it has to have these features, right? So basically, you're kind of decoupling it, or you can say that all the implementations of remote will have so and so specifications, which has been introduced by interface. Also in Java, you cannot have multiple inheritance. You cannot have a class which extends multiple classes. You cannot have car which extends vehicle and which extends, say, for example, locomotive. Locomotive is one of the classes, say, for example. So you cannot have a class which extends two classes. That is multiple inheritance. Though you could have levels and you could have hierarchical inheritance, but you cannot have multiple inheritance. But through interfaces, you can have multiple inheritance. You could implement multiple interfaces, but not multiple classes. Again, since this is inheritance, interface is 100% abstract class, and basically you create subclasses from, or you implement an interface. It's nothing but it follows is a relationship. So what's the difference between interface and a class? An interface can never be instantiated. Just to give you an example, I'll show you what interface is. So instead of this class, I'll make this interface. So this is how we define an interface. We define interface, but as I said, an interface is 100% abstract. Everything has to be abstract. You cannot have methods, something of this sort. You cannot have a concrete implementation of method. Though you could have a default method, which we would be looking at in the slides to come. But at this point, let's imagine that you have a shape class, and whatever methods you declare within your shape class has to be abstract. By default, it is abstract. You need not even mention it. By default, JVM puts it as abstract. Even if you mention it abstract, it's not a problem. It is abstract. So now, when I, unlike extends that we do on class for interface, you implement it. So you implement shape class. So you'll have to make it public. By default, the access modifier for a method interface is public. So here you can see that we have implemented it. You could see that it's 100% abstract. So with this, you could see most of these differences being listed here. An interface should contain abstract methods, which we saw. Class can contain only concrete methods. We are talking about normal class here, not the abstract class. The members of the interface are always public, which we again saw. When I didn't implement this one as public circle, it gave me an error. So by default, it is public. The members of the class can be private, public, or protected. An interface can never have a constructor. Since we are not creating instance, the first point you can see that interfaces cannot be instantiated. Since we cannot instantiate interface, there's no need of constructor. A class can have constructor to initialize the variables, which we read yesterday. Implements keyword is used for inheritance, and whereas in terms of class, we have extends, which we saw now, right? For interfaces, we changed it to implements rather than extends. After extends keyword, any number of interfaces can be given. This is multiple inheritance that we spoke about. Whereas after extends, you can have only one and only one class. You cannot have multiple classes. Cannot contain instance fields. The only field that can appear in an interface must be declared both static and final. Can contain instance fields. So only the constants would be declared in your interfaces, whereas within class, you can have all levels of all the instance variables. Classes have implementation, whereas this is between class and abstract class. So classes have implementation, abstract classes have no implementation, or they can have implementation as well. So it's a mixture of abstract methods and non-abstract methods, as we saw. So abstract class is not 100% abstract, right? Unlike interfaces, you could have concrete implementation as well. Concrete classes are instantiated to create object. Abstract classes cannot be instantiated. Similar to interfaces, abstract classes cannot be instantiated. A concrete class can be final. An abstract class can never be final as it has no defined functions. For abstract class to be complete, it has to be extended. That's what the purpose is. Abstract class and interface is an abstract class can be extended to a class using keyword extends, and whereas interface can be implemented to a class using implements, which we saw. An abstract class can extend only one class at a time. An interface can extend number of interfaces at a time. So yeah, this is one thing wherein your interface can extend other interfaces, right? And you could have multiple interfaces extended. Abstract class can have private, default, protected, and public members. and interface members are by default public. In abstract class, keyword abstract is mandatory to declare a method as an abstract method, which we saw again. In interface, it's not mandatory because by JVM by default puts it. Abstract classes are to achieve 0 to 100% of abstraction, which means that you could have some concrete implementation as well, whereas interfaces are 100% abstract. You cannot have anything, you cannot have any implementation within. But you could have a default methods. Abstract class can have abstract and non-abstract methods. Again, yeah, abstract class can have constructors and interface cannot have constructors, which we saw earlier. Abstract class can have abstract and non-abstract methods since it's not 100% abstract, whereas interface can have only abstract methods. By the way, from Java 8, as I said, there's a default method being introduced, which is nothing but you could have a concrete implementation written within interface. Class interface relationship, you have class which extends other class, you have class which implements interface, you have interface which can extend other interface. If there's an interface already defined and you want to inherit some methods or you want to inherit the methods that you have within the other interface, you could do it using extends. A class extends another class while implements an interface, and interface extends another interface. Class cannot extend multiple classes but can implement multiple interfaces. So here you could see that there's one class which is extending the class on the top and there's one at the right side. It's trying to extend it. If you try to extend multiple classes, it would give you a compile time error. It won't allow you to inherit from multiple classes. Whereas in this case, you could see it's implementing multiple interfaces. On the top, you could see one interface being implemented by this class, and there's one more interface to the right which is being implemented by this class. Class cannot extend multiple classes, but it could implement multiple interfaces, which gives an opening for multiple inheritance. When any interface gets compiled, compiler automatically adds access modifier to the members. So this is done by default. It's an internal addition. So here you could see interface demo, which has got one variable, that is int count is equal to 10, and it has got a method which is output. Now when this demo.java, which is an interface which gets compiled, you could see that by default it has put it as public static final. So count 10 would be given access modifier public static final. So for variables, JVM by itself puts public static final. And for methods, it would put it as public abstract. So that's the reason when we had the area method, when we tried to override it, it gave an error saying that it has to be public. So John went to a bank. He wants to credit some money to his account. So let's see this one. So basically here you could see two implementation of it. You have money interface and you have operation as its method. So now you could see two implementations of it. One is debit and the other one is credit. Within debit, we are just saying that we are writing a dummy statement there saying that we are debiting money from this account. Whereas credit is nothing but, again, we are printing saying that we are crediting money to this account. So now when you create instance of money or you create instance of credit and assign it to money and money.operation, you would have operation method on credit being called. In this example, we can see that there's a shape interface which has abstract area and there's a circle which returns this value, right? And say I declare one more class which is square, which implements shape, and it's again throwing me an error saying that you will have to declare it, you will have to implement the method. So I override this and say I return some dummy value like 100. You have a square and inside circle, say I so circle area, we are just hard coding it right now. We don't have to implement it. So it gives you 200. It's returning 200 as float and this one is returning 100. So what we can do here is we have this shape utility. So here we have this thing called on circle. So I will just print it out here saying, and now I have one more, say for example, I create one more shape, which is square, nothing but new square. Now what we are doing is we are going to print out square dot area. So instead of assigning to a variable, you could do it this way as well. area of a square, what we did is we have an interface shape and we have an area method which is abstract. We have two concrete implementations of it, circle and square, and we are instantiating circle and square here, and we are calling area method on it. By the way, you could see here that this is dynamic polymorphism. Circle and square has been assigned to the shape reference. It's not directly to the circle. You would see 100 and 200 being printed out. So circle was 200 and square was 100, and you could see 200 and 100. So it's basically dynamic polymorphisms followed in interface as well. You could extend an interface with another interface. So suppose you have one more interface, which is for now just to, so I create an interface, test interface, which has like test method. So you have a test interface, which is void test, and you could have shape, which is extending test interface. Now your circle and your square would give an error because there's one more method that you need to implement. If you don't implement it, you will have to either make this abstract. If you make it abstract, it should go off. But in this case, suppose we want to implement it, then you will have to ensure that you implement test method as well. Once you implement it, the error should be gone. Similarly, in square, you will have to implement it. So that's what is extending one interface with another, right? So basically here you could see there's walkable, there's runnable, and when you do it, when you implement runnable, you will have to ensure that you implement walk and run, both the methods. It's a class extending one class and implementing more than one interface. There's two interfaces, walk and run. So you could see animal, which implements walk and run. So then it will have to implement both the methods, walk and run. Whereas there's a human class which extends animal. So this is basically there's a class which is implementing multiple interfaces and which has to ensure that it implements both the methods. So in this case, walk and run, it has to ensure that it implements walk and run. And there's one class which is extending from this particular class. And you could see here that you could assign human, which is extending, which is a subclass of animal. We could see that human could be assigned to walk and run as well, since it is implemented from there. So you could have h1.walk and h2.run sort of. You're giving a call to these methods. So basically, this is again, if you understand the idea of runtime polymorphism or dynamic polymorphism, which is nothing but assigning the instance of subclass to superclass, you should get idea behind all this thing. We are pretty much talking the same thing. All this is talking about dynamic polymorphism. If you get that thing right, you are good enough. So we are talking about default method, right? Since Java 8, you could have default implementation within your interface. You could say that you cannot have a concrete method, but you could have, if you put a concrete method, something like this, it would give you an error. Okay, it gives you an error saying that it's not allowed, but you could have it as default. Once you define as default, it's good enough. So all these methods or all these classes, circle, square, and all these classes would inherit this. They can't override it, they can't do anything with it, but they would inherit this. They can give a call though, but they can't override it. So basically, I'll just show it here. So basically you have default method, which is say, and which is printing out hello, welcome to Edureka, right? And you can see here default class interface demo, which is implementing welcome. And you could see here hello being concrete implementation of hello, which is nothing but it's printing out the message that's passed to the hello method. So though default class interface demo doesn't declare say method, it inherits from welcome. When you do out.say, you could see the default method being invoked. Here we could see that, hello, welcome to Edureka is being printed out, which is nothing but the output of default method. So basically default methods are nothing but method which cannot be overridden, but is available for all the classes that implements a particular interface or implements that interface. So rules for using private methods in interfaces. Following are the rules for using private methods in interfaces. Private interface method cannot be abstract. Private method can be used only inside interface. Private static method can be called from other static and non-static interface methods. Private non-static methods cannot be called from private static methods. This might look confusing at this point, but you could think that first of all, private interface method cannot be abstract because we want it to be implemented in some other implementation, right? We cannot keep it private since interface by itself doesn't have the implementation of it. You want to implement that method in some other class, so it cannot be private. Private method can be used only inside interface. So if you define a private method within an interface, it can be used only within the interface. So basically you could have a default method which is private, right? So basically default method itself cannot be private, but within default method, so what I'm trying to say is, so here you could have private void, which is doing nothing. But here your default method would call this private method. So private method can only be used within the interface and it's usually used within default. A private static method can be called from other static. This is pretty much similar to other classes, normal classes. Private non-static methods cannot be called from private static methods. This is a common rule that we have. Private non-static methods cannot be called from private static method. So if you have a static method, within the static method, you cannot call non-static method. Remember we mentioned it earlier, unless we create the instance of it, we can't call it. But in this case, it cannot call it at all. So it's not on a class you're invoking it, basically within an interface. So private methods is specifically, you could call private methods from within your default method in interface. And since private methods are not accessible from outside, that's the only reason you could have private method in your interface. Static methods in an interface. So you could have something like this, wherein you have interface one and you have a static method display. As you remember, static methods are more of a class level method, right? You need not have to create instance of a class to invoke a static method. If an interface has a static method, you could call it directly by interface dot the name of the interface dot the name of the method. So we can have a static method like static. So this method could be called. So you could have something like this method and you could call it directly using the interface name. So we have this. So now within shape utility, you could directly call, like, as you could see here, you could call the static method directly by the name of the interface. You cannot have normal methods within it unless it's a default one. Interface features for different JDK versions. So interface has evolved throughout the versions of JDKs. So just to brief on that, we have JDK 1 to 1.7 having normal interfaces with constant static variables. As we said, the variables that you would have in interface are typically constants, which is public, static, final, and with abstract methods, of course. In Java 8, it evolved and we have a default method. As I said, there would be one default method which would be inherited by all the interfaces extending that interface. And you have static methods as well, which was not there earlier. In Java 9 and later versions, so in industry right now, it's mostly Java 8 that's been used across. Very few have gone to Java 9. All the big data frameworks and everything we have is supporting Java 8 at this point. So with the latest version, that's Java 9 and above, we have constant static variables, abstract methods, default methods, static methods, and they have come up with these two methods which are nothing but private methods and private static methods, which was not there earlier. Now you could have these things as well. It makes very little sense to have all these scope variables, but maybe they might have thought something as a part of evolution. But at this point, I believe since these private methods cannot be called from outside, it's just that you have control over the default method. So basically, yeah, maybe if you have a big logic to be written within your default method, just to modularize it, just to break it into multiple methods, not to have one monolith big function or big method, you could have this private methods. That's what I can think. What is a package? We have been using package since day one. So package is nothing but it's a namespace. It's for avoiding collision. So basically I could write a name class with name shape and maybe someone else within my team would write the same thing, right? So basically at the end, when we archive it together, like we have a jar file, which is Java archive. When we archive these files together, there's going to be name collision, right? You wouldn't know which shape class are you referring to. So basically namespace is nothing but it adds namespace to it and it avoids collision. Classes in the same package can access each other's members. So basically you can have within a package So we'll talk about the import statements that will give you a clear understanding of what we are talking about. But basically within a package, as you could see here, we have not done anything to refer any of these classes. So it's within a package. We have com.edureka and we have all these classes within this package. So you could see that employee or maybe manager, which is a different class in the same package, we are accessing it directly. We are not doing anything different for it. But when you want to access it from a different package, you have to do something else, which is nothing but importing the package. The normal naming convention is usually domain name. Here you could see we mentioned com.edureka. So it's usually something of that sort. org.example.hyphenated name. It has to be lowercase, usually written in lowercase. Companies use their reversed alternate domain name to begin their package names. So basically, if you have mypackage.example.com, you would have it in reverse order. This is typically one of the best practices or practices that's been followed across industry to define the package, but it doesn't have any constraints from the Java side as such. You could do anything. So for example, if I make it uppercase, so basically it's saying that it's not showing error because of it's in uppercase, but basically you don't have a directory starting with uppercase. As per Java or from the Java side, you don't have any constraints. For example, I could do something like, so basically it does convert it into lowercase even if you give uppercase. I don't know whether this is a feature in IntelliJ IDE, or it is, of course, it has to do something with the IDE because IDE is converting it into lowercase. As far as the Java naming convention is concerned, this is what we do, but it doesn't have constraint. Java predefined packages. So Java itself has many packages. So you could imagine the entire language being written in Java source code. So basically all this you would find in the source code. When we refer to the string, string is a class which resides in java.lang. There's java.lang, which is nothing but java.language. So string is something that resides in java.lang. Object is a class which is a superclass for all the classes. So you know what superclasses are after we went through the inheritance thing. So you have superclass and you have subclasses. So the superclass for all the classes, no matter what class you use within Java, all the classes are inherited from a class called object. There's a class object in Java from which all the classes have inherited from, or all the class inherit from this particular class. Thread is used for multi-threading. Java.lang.thread is used for multi-threading. Multi-threading is nothing but two lightweight processes in order to leverage the potential of your processors. So if you have multi-core, then you could have multiple operations happening at the same instance of time. That's what thread is all for, to make it faster. You have exception class, you have system class, java.lang.system. This package is used to achieve the language functionality such as conversion of data from string to fundamental data, display the output on the console, and many more. The package is ported by default. So you don't have to specifically explicitly import this particular package. It is by default ported into your application. Java.util, this is like utility classes. You have collections and stuff like that into your java.util. This package is used for developing quality or reliable applications in Java or J2EE. This package contains various classes and interfaces which improves the performance of J2ME application. So basically these are utility classes. It does something in terms of performance or does some conversions or something of that sort. Java.io is a package which contains something like file input stream, file output stream, and stuff like that, which is basically for interacting with your files, with your IO. So basically, if you want to load something into your memory, if you want to read something from your file or write something to a file in your local directory, you would use something like java.io package. If you want to do some kind of socket networking or some kind of network programming, you would use java.net, which has something like socket, datagram packet, datagram socket, etc. We have applet. Applet is nothing but an application that gets loaded into your browser. It's not used as of now. Earlier it used to be used, but now there are a lot of other technologies that have come up. But this is something like an applet is a Java program which runs in the context of WW or World Wide Web or browser. You have java.awt, which is like event driven. Like you could have UI applications. If you click on your checkbox or button, there would be an event triggered and you would have an event handler handling it. If you click on a mouse or something, you would have an event triggered. So basically, all these classes are grouped into this package, which is java.awt. So you could see java.awt.event, which has like mouse listener. This is specific to event. So without these classes, it is impossible to handle events generated by GUI components. So as far as the front end is concerned, as far as all this AWT applet is concerned, it's not in use. Basically, Java is much more useful in terms of backend programming, which means you take data and do something with your data and stuff like that. But it's not well suited for UI applications, and it's not used to that extent in market or in industry. You have java.sql, which is nothing but all your database related stuff. So if you want to connect to your Postgre, or if you want to connect to Oracle, you have all the stuff written in java.sql. So mostly in java.sql you have interfaces, and this interfaces, as I said, it's nothing but specifications, and these specifications are implemented by database vendors. So it's nothing but interface is just an abstract method. It would have like 4 or 5 abstract methods within. So all this concrete implementation, someone will have to implement to use these interfaces, or someone will have a class which will implement these interfaces, and we as developers can use those classes to interact with databases. So vendors like Oracle will have its own set of implementation to the specifications that are mentioned in java.sql. As I said, most of the thing in java.sql are interfaces. So about the access modifier, we have spoken earlier. We have public, we have protected, private, and default modifier. Public is nothing but it could be accessed from anywhere within your application. So you could have your methods as public, you could have your class as public, you could have your instance variables as public, which means that particular method could be accessed from anywhere within your application. You could have protected modifier. Protected modifier is nothing but your subclasses can access it and your current package. Whatever the package in which a particular method or particular class resides, in which you have protected method, you could access it from that class, or any class from that particular package access the protected methods defined within a class in that package. So I'll give you an example since we have spoken about inheritance now. So I'll give you a demo on protected. Private modifier is basically it's private, it's within a class, you cannot access it from outside. If you try to access it, you would get a compile time error saying that it's not visible. Default modifier is package, is public within package. So within package any class can access it. So basically it's like protected, right? Protected can be accessed within the package, plus it has like if your subclasses are outside the package, even those subclasses can access it, whereas in default it's just within the package. So protected has wider scope than default modifier. This is kind of public. So public has almost like everything, it's a widened scope. Then comes protected, then comes default, and then comes private. So access modifiers, public, what are public? So when you have public access modifier within a class, in this case you have two packages, edureka.pack1 and edureka.pack2, and you have some public members within your class 1, which we can see here that all these public members could be accessed by class 2, class 3, which is there in the same package as class 1, that is edureka.pack1. So now there are two classes in edureka.pack2. One is a class which doesn't have any relationship with class 1, but still it can access it, though it's there in a different package, but still it can access the public members of class 1. You can see class 4, which is a child of class 1, since it extends class 1, but it's there in a different package, but still it can access the public members of class 1. So protected is nothing but it could be accessed within the package in which the class is defined, and it could be accessed by members that are outside the package but child of that particular class. So in this case, we can see that there are few protected members in class 1 which could be accessed by class 2 and class 3, since they are in the same package as class 1. Class 3 and class 2 are defined in edureka.pack1. We have class 5, which is not related to class 1, which means it's not a subclass or it doesn't have any relationship with class 1. In that case, class 5 cannot access any protected members within class 1. So here we have class 4, which extends class 1, which is nothing but class 4 is a subclass of class 1, which is there in a different package, edureka.pack2, but it can access the protected members of class 1 since it is there in a different package. Private member is nothing but it can be accessed just within the class in which it is defined. So in this case, you could see that this is private members. So you have class 1 which has got private members, and you can see that class 2 can't access it, class 3 can't access it, neither class 4 or class 5. No one can access it. It's just that class 1 can access private members. So we have seen this in examples that we took in session 1. Default package. So default package is nothing but only within the package in which it is defined. So in this case, you have class 1, which has got default members with default scope. And you can see that class 2 and class 3 can access it, but not class 4 and class 5 since they are out of this package. Since class 2 and class 3 are defined in the same package as class 1, that is edureka.pack1, that's the reason you could access it from there. This is same for attribute or method. There's a table here which is summarizing whatever we discussed so far. You have modify public. So yeah, it's within the class, yes. It's within the package, yes. If it's within the subclass, yes. And within the world, yes. So everywhere it could be accessed, right? That's why you have public. Protected is within the class, yes. Within package, yes. Within subclass, yes. But not within world. So it's just within package and subclass. But if you have different package, or if you have different package but it's not a subclass, then you can't access it. No modifier, which is a default scope within the class, yes. Within the package, yes. But we saw that it cannot be accessed within the subclass if the subclass is in a different package. When we say world is nothing but any package, and they are not related. In this case, the previous example that we saw, class 5 is something that could be thought of as class that are unrelated but reside in a different package. Private is just within the class. You can see that it's not with package. Within the package, it's not within the subclass, it's not within the world. So I think we have spoken about private, public, and default scope earlier. Let's start off with protected. So in the meanwhile, when it starts, let's talk about this. So here we can see package demo, which shows public. It has got a public method that is message. There are 3 ways to access the package from outside. So let me talk about how we actually code it. So there are 3 ways to access the package from outside the package. One is with import. In this case, like you had Edureka 1 and Edureka 2, right? The example that we saw earlier, edureka.pack1 and edureka.pack2. These are the 2 packages you have. If you want to access something, if you want to access class 3 from class 5, you would have to import edureka.pack1.class3 since it is outside the package of pack1. If it's within the package, so far the examples that we were taking was all within the same package. So we didn't have to import it. Now I'll just show you an example wherein you would have something that is outside the package, and I'll show you how to access it. So we have to import it. So whenever you have it in different package, then you have to import that particular package within. One thing is importing the entire package. The other one is importing a particular class. So in this case, you have a package demo, and we can see that within package demo, there's a pack demo, which is nothing but a class defined within it. So let's see how to access package from another package. You have a pack demo here. That's a class that is defined within the package demo. As you could see here, there's one method which is msg, and which is taking 2 parameters as input, integer I and integer j. So what are the ways in which you could access this particular class that is pack demo from outside the package? So the first thing that you could do is you could import the entire package itself. So demo.star or demo.asterisk, as you could see here, which says that all the classes within this particular package can be accessed from this particular class. So you have a package demo class defined here, which says import demo.star, and which would import everything, all the classes within demo. So in this case, pack demo, you could see that pack demo class could be accessed from within package demo class that's there in different package. So basically this package demo class that you see here is defined in some other package. Other thing is, if you want to import just a class and not the entire package, you could do that thing as well. So here what we are doing is import demo.packdemo. So you're importing a specific class and not the entire package. That could be done as well. And the third one is, instead of importing, you can do one thing. You can have fully qualified path name or fully qualified name like demo.packdemo. That's your class name. you can access it within your class. So basically you would use the fully qualified name. You might use it, you did not do it, but you might use it in case where you're just using it once within your class. But you would go with this options demo.packdemo or demo.star, in which you class has multiple is referring to the class in different package multiple times. So in that case, you just do it once and could be used within your class. You need not do it again and again. So I create a new class which is com.edureka new dot. So I created a new package. So there's one that is com.edureka and the other one that is com.edureka new. These are different packages you have. If you want to use something within this package com.edureka, suppose I want to use vehicles, right? So this is what I was talking about. When you try to access it, you can't do it. You can't access vehicle from here because it's there in a different package. Now you are not able to access it because you haven't imported it. So what I do here is import com.edureka.vehicle. Once I do this, I am able to access it now. Now what I was saying is, if you are accessing multiple classes from multiple classes within the package, like car also you are accessing. So instead of writing it like this, so what you would do is com.edureka.car. Now the compilation error has gone. So basically, instead of doing this, like instead of writing it multiple times, the other option that we have is like com.edureka.star. So now if I get rid of these two imports, still it would work. I don't need these two imports because we have ported all the classes within the package. So it's able to access both the classes, vehicles and edureka, from com.edureka. The other one was you could get rid of this. Now it's showing up error. What you could do is com.edureka.vehicle. You could access it directly with the fully qualified name. So you can see the error has gone. So these are the three ways in which you could access different packages or access classes from different packages. Now let's understand what is a regular expression. So regular expression pretty much similar to other languages that you have. Regular expression is nothing but an expression through which you could extract some sequence of characters from your string, or you could check whether a specific regular expression or whether a string is aligned to a particular regular expression. So you could define a regular expression saying that, say for example, email ID, right? One of the use cases of regular expressions could be like you have email IDs and you might have seen it on websites wherein you do some kind of registration or something. And if you don't give a proper syntactic one, then what it would do is it would give you an error at the rate gmail.com. If you don't give that, it would throw you an error showing that it's not proper. So it's not checking against the Gmail server to see whether your email ID is proper or not. So it is just checking syntactically. You might have seen it. So if you give a wrong syntactic email ID and if you go to the next tab, if you tap to the next column or to the next space, what it would show is you haven't entered it correctly. So basically what it's doing is it's checking it against a regular expression. It has got a regular expression saying that this is how an email ID could be. It should end with so and so characters. It should be at the rate. It should have at the rate. It should have Gmail, or it should have some characters in between, then it followed by .com or something of that sort. So basically to have this syntactic this thing done, just to ensure that you have given it properly, you have a regular expression. So yeah, one of the use cases could be to have this pattern checker, usually to see if you're giving value which aligns to what is expected. So maybe other thing could be if you're typing something or if you have been asked to put some amount and if you type characters there, it would give you an error saying that it's not allowed. Those type of checks could be done through regular expression. Or if you want some value to start with a particular character and end with a particular character, you can check it against a regular expression. Regular expression is a pattern used for searching and manipulating strings. It could be used for manipulating strings as well. So one of the use cases is searching and the other one is for manipulating. The regular expression either matches the text or fails to match. So basically it would validate and say whether it's a match or it's failing. So we call regular expression as regex, which is nothing but abbreviation for regular expression. So Java supports regular expression, and these are the classes that we have within Java, which is in java.util package. So remember we spoke about java.util package, which has got utility classes. So these are among them. So here you can see pattern class, you have matcher class, and you have pattern syntax exception. So basically if you have some exception, if it's not proper, then you would get some exception as well. So we would be taking an example to clarify what this is all about. So here are some matching patterns used in regular expression. So just about to read through it. So you have like ABC, which means it has to exactly match ABC. If the string that you are matching it against has the content ABC, it would match. When you put it into square bracket, which says any letter A, B, or C should match, any character, and again if there's a negation, if within the square bracket if you have this negation mark which says that any character except these three characters should be matched, so if you put D it will match. In the second case, if you put A or B or C, it will match. And here it would be from D to Z. If you put anything, it will match. Not just alphabets, it could be anything, any character. A to Z. So when you say A to Z, it says that we are giving a sequence of it, right? So we are saying from A, it's a range basically. So it understands range as well. So when you say A hyphen Z, which means that it is from A to Z. Here we are saying that any one letter or digit should be in sequence. So basically you could have uppercase and lowercase as well. Basically it is saying it should be in sequence. It should end with basically digit at the end. Dot is some kind of a wildcard character saying that any one character except line terminator must be in sequence. This one indicates beginning of line. So we say that line should begin with so and so. You could put some character here and we can say that if a line begins with so and so character sequence or whatever regular expression that we have put in, then the entire line matches it. The other one is end of the line to check if any character present at the end of the line. Other thing is word boundary. We have an example about this, so which would give you a clear idea about it, but it's more about it cannot be part of a word. Here, when we put slash b to the front and the end, or to the start and the end of a particular character sequence, which means that it has to be a separate word, but it cannot be part of some other word. Slash b to verify that any character is not present at the word boundary. Slash g to check that the character is present at the end of the previous match. Meta characters. So we have slash d. Instead of writing 0 to 9, you could use meta characters slash d to define digit. When you want to define non-digit, which is like you can see here, negation of 0 to 9 set, which is non-digit, which could be like alphabet, space, or anything, which could be grouped as slash d. Slash s is a white space character. So space, tabs, and stuff like that could be enter for that matter is a white space character. Slash s is a non-white space character, which means it's an actual character rather than white space. Slash w is a word character, and slash uppercase w is a non-word character. We have quantifiers, which is a quantifier defines how often an element can occur. So star, which means that 0 or more times, plus, which means that it has to occur one or more times. Question mark is it could be no or just one time. You could mention the number of times you want a particular sequence to occur, which could be put into your curly braces, occurs X number of times. X, you could put a range within your curly braces, X comma Y, which means that it should occur somewhere between X and Y. So it's a range. You have asterisk, question mark. It tries to find the smallest match. This makes the regular expression stop at the first match. So as and when it finds the first match, it would stop. So we'll have a quick demo on regular expression. So here, before we start off, we define a pattern here, basically. Then you could see it is basically saying from A to Z and followed by character, one or more character. Then we have a check here, which is nothing but a string against which we are going to check. First, we compile the pattern. This is a regular expression pattern that you are going to check against. So the first thing that we have to do is we have to compile this pattern to see if it's properly done or not. So first thing is to compile it against pattern, and if it's correct up to the mark, you would get the instance. If it's wrong, then there would be some kind of exception thrown. Then there's a matcher. So once you have the pattern, you do pattern.matcher and you provide the string against which you want to check. In this case, you have happy learning, welcome to Edureka is a string that's been passed. And when you do c.find, if this is fine, it would return the result true. And if you remember the while construct, it would get in only if this is true. So it's a loop. So it would basically iterate through, and you could see here that it's displaying all the characters. I'll quickly run this. Let's name the class as pattern checker. Now I write a main method. Now, if you remember, we had a pattern there, which was like A to Z followed by characters. Then we have string against which you want to check, or you could say simple string to check. So we just put this one. So once you have this string to check, now what we want to do is we want to compile this particular pattern. So what we do, pattern.compile. So one thing to see here is that's the beauty of using the IntelliJ or Eclipse. So you could see here this package has already been imported. When you use it, unless you have multiple classes with name patterns, it would ask you to specifically explicitly mention which one you opt for. But in this case, there was just one pattern class, so it imported it automatically. And we give the pattern here. So basically, if this pattern is correct, if it's rightly formed syntactically, you would get a pattern here, or it's not pattern, I believe. We have a compiled pattern now. Now what we do is we take this compiled pattern, and I think we have a matcher here. We get the matcher now. So matcher would check against string. So you have a string to check, which would give you matcher. So here it's asking me which matcher do I want. I'll select this one, and you see this one getting imported here. So this is what we have done. We have compiled the pattern and we have provided the argument against which we have to check as a part of matcher. We get the instance of matcher. So everything is in terms of class. This is what object-oriented programming is all about. You have a pattern, which is a class. You have a method within pattern, which is compiling your pattern. So this is what object-oriented programming is all about. Everything is realized in terms of classes and objects. This is nothing but the object of pattern class compiled. So now what I do is matcher.find. I just print this one, matcher.check. So basically what we are trying to do here is once the entire string passes through, we are trying to get the substring out of it. So when we get the substring from matcher, you would get the string indexes, begin index, and you would get matcher.end as well. So when we run it, you should get APPY, and so the first character would be trimmed off. So you could see first character being trimmed off from each line. So importing regular expression, we saw that java.util.regex gets imported. Then you have pattern, then you have string to be checked against. The pattern and the sentence which is to be matched are given. A to Z means any character from A to Z, and plus means one or more. The sentence check is checked whether it matches the pattern or not, and the strings from the sentence which match the pattern are printed. So basically here we could see that H is in uppercase and we don't have uppercase here. So that's the reason it trimmed off the first character. So basically if I add H here, now H would match as well, and it won't trim H, or it won't remove H. You should be able to see H as well. So yeah, as you could see here, you have H appearing as well. Previous case, H was getting trimmed off. So this one is for the word boundary. As I said, if you want to have something like you want to be sure it's a separate word and it's not a part of any word, you could put something like this. So basically what we can do here is, so we can mention here something like /v and then in. So what we are trying to do here is, you could see here, what we are saying is we want a separate word as in. We don't want it to be a part of any other word. So here in learning, though you have in, it didn't pass it because it's a word boundary. Whereas in, which is a separate word here, it just passed this one. So if had I removed this one, you could have seen two ins. That's what I mean to say. So now what's exception? Exception handling is nothing but typically, so here you could see two ins. When it's //b, it would be just the ones that are complete word instead of matching the word boundary. Let's talk about what are exceptions. An exception is an event which occurs during the execution of a program that disrupts the normal flow of the program instruction. So to give you an example, yesterday we spoke about arrays, right? If array size is 5 and if you try to access something more than 4, like if array size is 5, which means that the indexes range from 0 to 4. If you try to access something more than 4, like if you try to access sixth element within the array, it would give you an error saying array index out of bound. Or if a particular object is assigned null value and if you're trying to access that method within that particular object, you would get null pointer exception since it's not instantiated yet. When you instantiate it, that's when the object gets created. But if your reference is pointing to null and if you're trying to access something within that reference or a class, you would get null pointer exception. Similarly, you have like divide by 0 and stuff like that. It's basically something that is not expected or something that would disrupt the normal flow of program execution. When an exception occurs, the JVM creates an exception object to identify the type of the exception that has occurred. So basically, within itself, it would create it, or the code would create it. So I can create my own custom exception tomorrow. If I'm writing an application, usually in applications, that's how we do. We write our own custom exceptions. I can define my own exception as well. If within my application something is not working or something is not running as I would expect it to, I would throw an exception so that within my application, it properly logs or it properly prints out in my console saying that this is the exception that's been triggered due to so and so condition. So an exception is often referred to as runtime error. So here we can see divide by 0 exception as an example. Now there are different types of exceptions. First one being checked exception, the other one being unchecked exception, and the third one being error. So checked exception is something that happens at the compile time. What happens is when you have a checked exception, when you are invoking some method which is throwing a checked exception, and okay, I don't want to get into the catch block as yet because we haven't covered it. So this is also called as compile time exception. It means if a method is throwing a checked exception, then it should handle the exception using the try catch block, or it should declare the exception using throws keyword. Otherwise, the program will give a compilation error. Whenever there's a checked exception that's been thrown out in the sense not at the runtime, there could be methods which is throwing an exception. So whenever there's a checked exception, you have to ensure when you give a call to that particular method, say there's a method X which is throwing some checked exception, from your application you are trying to access this method X. When you try to access this method X, you have to ensure that you are taking care of the checked exception that is thrown from X. If you don't take care of it, it would give you a compilation error. When I say when you don't take care of it, how do you take care of an exception? That would be the first question that would have come to your mind. So when I say you have to take care is nothing but you have to catch it. You have to handle that exception. So try and catch is a mechanism through which you handle the exception. So what you would do is method call or the call to X, you would put it into a try block. And in the catch block, you would say that if this particular exception occurs, execute this block of code. That's a handler for exception X or checked exception that is thrown from method X. So basically you write a handler for in the catch block saying that this is what I want to do when this exception occurs. Once you have that, when your program runs, even if the exception occurs, it won't stop at that point. It would go and check whatever is written and whatever piece of code that you have written, and it can continue from there on. It's basically a decision made by the developer whether to carry from there on or whether you want to break it there. Whenever there's a checked exception, you have to ensure that you handle it. Either handle it or you say that I'm not going to handle this. I'm just going to throw this off from my method or throw this off from the method where I'm executing this method X, which we spoke about, which is throwing checked exception. I can choose not to handle it and just to throw it off to the calling program, wherever the execution initiated from. So if you don't do that, you would get a compilation error. Unchecked exception, unlike checked exception, it's not mandatory that you catch. It's not mandatory that you handle it. It's a runtime exception. Basically, it could occur anytime and it's not mandatory that you go and actually handle it. So even if you don't handle it, JVM would be okay with it and it won't give you compile time error. So basically, these are nothing but runtime exception. So divide by zero that we spoke about is nothing but a runtime exception. It's not mandatory that you go and actually handle it during the compile time. You can either handle it or you can leave it as is, and during the runtime you would get an exception. So compiler doesn't check for the unchecked exception. It's done at the runtime. Now error, these are exceptional conditions that are external to the application and that the application usually cannot anticipate or recover from it. For example, if stack overflow occurs, an error will arise. They are also ignored during the time of compilation. So even the error condition cannot be anticipated during the compilation time. It's done during runtime, right? So one of the classic example is the stack overflow, wherein say for example you call the same methods like 1,000 times. Not 1,000 times is too less for the stack to get overflowed, but suppose you call it like million times. You call the same method, right? In that case, remember when I said when you give a call to the method, it goes to the call stack, right? We have a call stack. So it would push something, it would push a state of class, or it would push the properties that's been passed as an argument, the class, or to the method into the stack. Iteratively, if you call it like million times, what would happen is you would get stack overflow, because basically everything would get into the stack and it would basically leave your memory overflowed, or even memory for the heap memory for that matter. If you create a lot of classes, if you create a lot of instances of classes, your heap memory would get overflowed and you would get out of memory error. Those are classic examples of error. So what's the hierarchy of exception in Java? When it comes to classes, you have a throwable interface, and then you have error and you have exception. So exception is further, it has got runtime exception. The other ones are the checked exceptions. So IO exception, SQL exception, these are the checked exception. This has to be handled if there's a method which is throwing one of these checked exceptions. You have to ensure that when you give a call to such methods, you handle it or you throw it from your method. To the right side, it's runtime exception. So it need not be handled. As I said, divide by zero and stuff like that would be runtime exception. Even array index out of bounds and class cast exception, arithmetic exception. Then you have null pointer exception that we spoke about. All these exceptions are unchecked exception, and you need not actually handle it during compilation time. So why to use exceptions? When we execute a given program, we'll get an exception. Exception handling is performed in order to get the output. So basically, why do we handle exception is nothing but to get the program going rather than breaking it at that point. Use of exception handling: process exceptions from program components, handle exceptions in a uniform manner in large projects. So basically, why do we do it? So it's done basically to get the process going rather than stopping it at that point. And you could handle it the way you want to. That's the reason you have this exception handlers. Give you a simple example. Suppose 29 by 0. What I'm trying to print here, result after dividing 29 by 0. So basically when you run this, it's not showing up any compile time error. It's compiling fine. Now when I run it, since it's a runtime exception, it's compiling fine. But when I run it, let's see if it throws an exception. So as you could see here, it throws arithmetic exception, which is divide by 0. And this is happening at the runtime. That's why it's a runtime exception or unchecked exception. When a runtime exception occurs, program gets crashed and control comes out of the program. As we saw here, when we ran it, it didn't run this part of it. You could see that it broke out just right from here. So whenever there's an exception, if you haven't handled it, program control would come out from there. Exception handling is done to execute the program without getting an exception. So handling is done basically to handle the exception. Whenever the exception occurs, do some action. It provides flexibility to the developer to handle it the way they want to and get it going. Mainly try, catch, and finally are keywords for exception handling. So we have a try catch. As I said, there's a try block wherein all the suspicious one or wherever the exception you think that there could be exception occurring could put it into a try block. And in the catch block, you would say that if a particular exception occurs, this is what I want to do. All right, that's the catch block. And the finally block is nothing but no matter the exception is thrown or not, the finally block is going to execute at the end. So basically, finally block is usually used to release resources, right? When you deal with databases and stuff, you create connections against database, or you create some socket connections and stuff like that when you do some socket programming. Finally would be a place wherein once the execution of the method is done or execution of something is done, you say that we can release these resources off rather than still establishing the connection, right? Which takes up some of your resources, CPU resources, or which takes up memory. So basically it's to release off the memory. Exception handling. So let's talk about try. Try block is nothing but code that could generate. So suspicious code, as I said, that could generate an error is written into the try block. So the catch block would be more about catching a specific exception and doing something with it. So you could opt out to just break at that point or do something with it. Say, for example, you want to profile an application or you want to have some instrumentation set for the application to see how much time, what are the exceptions that occurring during runtime, right? If you want to see that, maybe a typical way in which it is done is you write all these exceptions into a database and wherein later could apply some analytics to see what kind of errors have occurred in the application. You could see that later on. So that one of the use cases wherein you handle it whenever there's a particular exception, you put it into a database, you make an entry in the database saying that this is the exception that was caught in so and so time, and you could later on have some analytics to see how it could be improved, how the application could be improved. So finally block is nothing but whether successful or unsuccessful, the block is going to get executed. As I said, this is nothing but mostly it's used to release resources such as connections and stuff like that. Let's see a demo of how we can handle exceptions. To give you an example of try catch, say this is a suspicious code which we are running. Maybe you could put this into a try catch block and say when there's any kind of arithmetic exception that occurs, we are just printing it out. Printing any kind of arithmetic. So what we are doing here is nothing but we are catching exception and we are printing it. So everything is in terms of classes again. See, exception itself is a class. So you could click on it, control click, and you could see it as a class. This is a source code for arithmetic exception. So you could see extends runtime exception, which means arithmetic expression is a runtime exception. So it's a subclass of runtime exception. You could see super and everything being used here, whatever we discussed about. So arithmetic exception is nothing but it's a constructor, right? And you could see super being called here. So that's how you could get into exception and you could read through it to understand how the source code is being written. That would give you a good idea about how flexible Java is. It's very much when it comes to flexibility and when it comes to object oriented paradigm, it's very much cleanly followed code. So you could go and actually see at the way the programs are being written. If you remember when we did 29 by 0, the program broke. It came right from there and it didn't execute the following code. Now we have handled it. We are saying that whenever there is a arithmetic expression in this piece of code that's here, we are saying that whenever there is an arithmetic exception, we are going to just print it and we are going to continue it. Don't stop at that point. So you could see here the program didn't break, right? It gave you an opportunity for you to actually handle it and it didn't break, it continued. So you could see this statement's been executed as well. That's why you have this results. So we had printed here. So as a part of handling, exception handling, what we did is we just printed out saying that what kind of exception had occurred. So exception.get message that gave like divide by 0. This divide by 0 that you see here is nothing but is printed out by this message. So it gave you an opportunity to handle it and get the program running as is. So try catch finally block. Basically what I can do here is let me define integer denominator is equal to 0. So as I said, finally block is going to execute no matter what is going to get executed. So I just print a message here saying I'll say here I'll put denominator. When the denominator is 0, we would get an exception, and it would come to the exception block here, or the catch block here, and it would print it, and then it would come to the finally block. So let me run this and see. So as you could see here, it came to the exception handler. It got arithmetic expression, that is divide by 0, and then we printed out saying that printing the typical message or the actual exception that we got, and it came to the finally block here. Let me put a scenario which is not going to throw exception. In this case, my denominator is 1, which means 29 by 1, which shouldn't throw any exception. So what I want to show is still it would execute the finally block. So you could see here 29 being printed out, which this got executed successfully this time because the denominator is not 0, it's 1. It got successfully executed. Still the finally block is being executed. Why to use multiple catch blocks? So you could have multiple exceptions and you could write multiple catch blocks. There are different exceptions that we spoke about. There could be like null pointer exception as well, which you want to handle, right? So it depends upon your program logic or what you're trying to do here. So there could be null pointer exception, then you have finally, so you have multiple catch blocks here. So you usually don't handle null pointer exception, but this is just to give you an example. So basically you have this arithmetic exception here being handled, then you have null pointer exception being handled here, then you have finally. So if you want to have different exceptions to be handled within your application, you could have multiple catch blocks. Since all the exceptions are derived from exception, catch exception E should be placed at the end. So basically, if you put the exception, there's exception, right? If you remember the hierarchy that we spoke about, all the exceptions are derived out of exception class. So you could have something of this sort. So if it is not an arithmetic expression, not a null pointer exception, then there's of course going to be some kind of exception which is going to be handled in this exception block. So basically we are catching all the exceptions here. First is specific to arithmetic exception. The second one is null pointer exception. If it's not a null pointer exception or arithmetic exception, then this particular catch block is bound to get executed. And it has to be last. You cannot place it first, because if you place it first, these two blocks, exception handler blocks, will never get executed, because even these two exceptions are a subtype of exception class itself. So it is mandatory that you place it at the end, or else it would give you compile time exception. So you could have something like array index out of bounds and stuff. So just to give you, this is integer array. I put 1, 2, 3. I define an array. Now I say integer array of, there are 3 elements, right? And if I try to access or just choose, so when there are 3 elements, the index ranges from 0 to 2. So now I put 3 here. So this is generic exception handler. For all the exceptions, we would have this handler. When you run it, this is going to give you array index out of bound, because you're trying to access element at index 3, which doesn't exist, right? So you would see a generic exception handler. So it came here. What I was trying to say is, so you could have array index out of bound here, right? So instead of null pointer exception, now I have array index out of bound. Now it would be handled by this block, and it wouldn't come to the generic exception handler. So here you saw it came to the generic exception handler. Now what you would get is array index out of bound exception handler, because it's been handled by this particular catch block and not the last catch block. So this one is, as you go down, it becomes generic. So here you could see it's been handled by array index out of bound exception. So as you go down, it becomes generic, more generic. Why to use multiple catch block? So this is pretty much similar. We have array, we have arithmetic exception that occurred. Array has 4 elements, 0 to 3, and you're trying to access the 10th element. That's when you would get array index out of bounds exceptions, as we saw. There could be a nested try, wherein you could have try inside try. So basically, when you have try inside try, if there's an exception that occurs in the nested one or the innermost one, it would try to see if there's a catch handler for that particular exception innermost one. If it doesn't find, then it goes to the outer one. So in many cases, it may happen that a part of the block may cause an error and the entire block may cause another error. In such cases, we have got nested try block. So what I was trying to say is, you have this one, could have one more like exception E, or shouldn't be null. So you have a nested one. Within this try, you have one more one, this thing which says array index, which is handling null pointer exception. It's handling just the null pointer exception. It's not handling array index out of bound. So what I was trying to say is, if such scenario occurs, it would check the innermost one. If it finds the exception handler, it would execute it. If it doesn't find, then it would come to the outer one. So basically, though this try doesn't have handler for array index out of bound, still it would be taken care of. So you can see here, it came to the outer one. So if you would have some piece of code right after this, it won't get executed. So this piece of this code will not execute if inner try. So basically, if there's a exception which occurs in the inner block, and if it's not handled, it would come to the outer block, but this piece of code, whatever you have in between this catch and this catch, wouldn't get executed. Why to use throw keyword? The Java throw keyword is used to explicitly to throw an exception while executing the program. So if you want to throw something, as I said, you could create your own custom exception, and if you want to throw something, you could throw it out. You could throw an exception from your program. It can be used to throw checked or unchecked exception. Any kind of exception could be thrown using using throw. And the Java throw keyword is used inside a method. So you could see here, basically, if b is equal to 0, you throw new exception, divide by 0 causes an exception. So before it goes to actually dividing it by a by b, you are kind of handling it prior to that. You are checking whether denominator is 0. If the denominator is 0, you are throwing exception by yourself. You are creating a new exception. This is kind of your own exception, right? You're creating your own exception and saying that it's divided by 0. So for any condition, so basically if denominator is equal to 0, you could throw it from here, saying or denominator. So basically, if I keep this denominator as 0, and this should be prior to this, just cut this, and this should be done prior to this. Okay, when to use throws? Throws is something, as I said, when you have a checked exception, you can either handle it using try catch, or you have to throw it out of the method saying that I'm not going to handle this. Let the caller handle it. You could do that using throws keyword. The method is not taking the responsibility to handle a checked exception, and it is, asking the caller of the method to actually handle it. This is in terms of just checked exception, when you have a checked exception. So basically, since you're throwing it from there, but since you have handler here, it's coming to this. So you have this denominator, you threw an exception from here, but this exception is been handled here. So it came here saying that generic exception handler. All right. So if I remove this, that's the reason you have generic exception handler here. So I remove this handler. I'm not going to handle exceptions. Whenever you throw an exception, it has to be handled, since exception is a checked exception. So basically you could have runtime exception which need not be handled. So basically the handler that you see here, we just have two handlers, which is for arithmetic exception and array index out of bound exception, but we don't have handler for runtime exception. So that's the reason it gave you an error saying denominator is 0. So this is the exception that we threw here using throws. So it's giving you an error right here because this is a checked exception. The exception itself is a checked exception. Now you could either handle it like the way we had handled it here. You could write catch exception, and you could handle the way you want to. So you have two options now. When you get into this scenario, into this situation, you have two ways to handle it. Either write exception and handle it. This would be a handler. If you see, the compilation error has gone. Or this is one thing that you could do. Or the other thing that you could do is you could ask this method. This method can say, I'm not going to handle it. I'm going to throw it for my caller to handle it. So the main method is saying, I'm not going to handle it. I'm just throwing it off from my side, from my code, for the caller to handle it. So see, the exception has, again, the error has gone. So basically, whenever there's a checked exception, you have two options, and this is happening at the compile time, by the way. So you have to ensure that you either handle it or you throw it. Throw in the sense throws. It's through throws. Main is saying that I'm not going to handle this. Let the caller handle it. As you could see, the throws keyword was added in the method signature. We saw how we throw exception. We throw exception from here. You check for some condition, you throw exception from here. why we use throws. Throw is basically to throw an exception, and a method saying that I'm not going to handle the exception. So what's the difference between throw and throws? The throw keyword is used to explicitly throw an exception. The throws keyword is used to declare an exception. The throw keyword is followed by an instance. The throws keyword is followed by throwable class. All right, so here you could see this is throws keyword is actually by instance. You create an instance of exception, whereas throws is the class itself. Throw keyword is used within a method, and throws keyword is used with the method signature. So you could see throw is used within a method, within the method body, and you could see throws at the signature level. So you have throws and throw. So throw is nothing but whenever you want to check whether there's an exception and you want to throw it out, you want to actually trigger the exception. That's when you would write throw and you would throw this exception. So basically here we are checking for a condition if denominator is equal to 0, which is potentially which would cause error further down the line. So we are checking it upfront, saying that if the denominator is 0, then we are not passing it further, right? In such scenarios, we could throw the exception right away. That's how you trigger the exception from the program. Throws is nothing but it's at the signature level of the method that you could see. And what you mention out by throws is that main is saying here that I'm not going to handle the exception. I'm just going to throw it off. So these are unchecked exceptions, by the way. So whatever is not being handled here, if there's some exception handled here, it would get to the exception handler or the catch block. But if there's something that is not been handled here, would be thrown out of this main method. Main method won't handle it. That's the reason why we have throws. Throw keyword is used within the method, and throws keyword is used with the method signature. Throw keyword can throw only one exception, whereas throws keyword can be used to declare multiple exceptions. Basically, you could have something like there's one exception, say IO exception. So you could have multiple exceptions here. So the main is saying I'm not going to handle IO exception. I'm not going to handle exception or something of that. So you could have multiple exceptions after throws. User defined exceptions, you can create your own exception, and it is called as user defined exception or custom exceptions. A user defined exception class can be created by creating a class, child class of exception. So basically create an exception. I create a class which is say custom exception. Now this custom exception is extending exception. So you could have your own classes defined, and it would have like this. So whatever exception you get, you could pass that exception directly here. So this is basically what I'm trying to do here is overloading of constructor. So you could see if you're passing string, it would come to this. If you're passing exception, it would come to this constructor. So you could create your own exception here. So basically to give you an example of this, instead of exception, what I throw is I can have a new custom exception. So initially I was throwing exception. Now what I'm saying is new custom exception. This is the exception that I have created. It's my own exception. When I run this, now you can see that it should throw custom exception. So you can see here exception in thread main. Thread main is nothing but your main method where your program is executing, and it shows the exception type, which is custom exception, which is created by me. And I have passed the string saying that denominator is 0 and at what point or at which line this particular exception occurred. You can see it in the stack trace. This is a stack trace. Basically, whatever you get here when an exception occurs is nothing but stack trace. So hi everyone, welcome to module number 4. Before I start off, I'll just brief on what we covered in module number 3. So we covered on OOPS concepts. In general, what are the OOPS concepts? What are different concepts or terminologies that we have in OOPS? Then we saw how Java is aligned to those OOPS concepts, how Java is known as object-oriented program, right? Or how Java is aligned to object-oriented programming paradigm. Then we spoke about abstract classes, which is a different modifier altogether, right? And then we spoke about 100% abstraction, which is nothing but interface, which is a construct in Java, which helps you to specify something, and you could have different implementations as per the specifications. Then we spoke about exception, right? What are different exceptions and why do we have exceptions at all? and how do we catch exceptions, or what is the need to catch exception, and what are different types of exceptions, right? You have like checked, unchecked exceptions. Checked exception has to be caught by your application, or a particular method might opt to just throw it off rather than actually handling it through the throws keyword, right? We touch base on regular expression as well, and why do we need regular expression, and what are different classes that Java has to support regular expression. All right, so today we would be covering file handling and Java collection framework. All right, so file handling is nothing but you have external files. You might have something on your network, or it could be on your local machine itself, and you want to access it and do something on it, or you might want to have data that's been coming to your program. You might want to write it into a file so that you could kind of analyze it later. I spoke about exception, right? If you get an exception, you could write it into a file so that you could later on go through it and understand at what time a particular exception occurred and you could act upon it. So it's a kind of profiling and instrumentation done on application to understand more on the behavior of the application and to improvise on it. Such activities could be done using file handling. We'll talk about Java collection framework. Java collection framework is nothing but you have array list and everything. That is, we spoke about arrays in the previous topics, but Java collection framework itself exposes array list, which is a dynamic list. You don't have to manage it. So remember, in list we said that when you declare a list or declare an array, you have to mention the size of it, whereas array list is dynamic. You don't have to mention it. It keeps growing. So these are the topics that we are going to cover: file input output of operation in Java, wrapper classes in Java. We are going to talk about Java collection frameworks. We are going to talk about list and its classification in Java, queue in Java, and sets and their classification in Java. So as you could relate, all this collection, all these components within the collection frameworks are nothing but data structures in general that's used, right? So maybe in C, you might have used different data structure, and whereas in different languages, you have different data structures, right? This is just to handle data. Data structures are nothing but to store data efficiently, and you could select one of them based on the use cases that you are handling within your application. So let's start with file IO. File IO is nothing but you have a file on your disk, and if you want to do something, if you want to write to that, or if you want to read from that file, you would ideally use file IO API. All right. So file IO is used to process the input and produce output for a specific file. All right. So you could access some file within your local disk, do something, and you can write it onto a different file as well. All right. Java.io package contains all the classes required for input and output operation for a file. All right. So as we said, package is nothing but name spacing, right? So everything is grouped. All the IO classes or all the classes in Java that is handling IO is grouped into java.io package. Okay. That makes it easier for programmers to understand as well, right? So if you're doing a lot of IO operations, you could directly say import java.io.star, which would import all the classes within your java.io package. All right. The files can be text file or it could be binary file, right? So you could imagine not always you deal with a text file, right? You have other files as well. So nowadays there's a lot of things going on IoT, right? Internet of Things. So you get data from different systems. It could be like your mobile phones, it could be from the car sensors or elsewhere, right? You have a real time raw information coming in into your system for analytics. So such data cannot be a text file because text file as such is a heavy file, right? So such IoT applications, what is being passed between systems or intercommunication between systems is done through a binary file, which is kind of lightweight, right? Compared to text file. Text files are heavier. So you could imagine this files not being just the text files, it could be binary files and so on. When I say binary files, it could be images as well, right? Different images that could be shared among system, or some image that is there on your local disk which you want to read into Java and do something on it, some kind of graphical processing on it, right? Stream is a sequence of data, so you convert this file into a stream and you use it within Java. Okay, we'll look at example which would give you a clear idea of what I'm talking about. Okay, so here you can see an example wherein you have a file which is student.txt into your local system, into your local disk where you are running this program. All right. Then you have a print writer. This is nothing but a print writer is a class that is exposed by Java, which is there in java.io package. You would pass on this file. So initially you have new file and you pass on the path of this file that you are going to read or do operations on. Not just read, it could be write operations as well. So basically you have new file and you specify the path name or initialize the file. The next thing that you do is you have print writer wherein you pass this file. All right. Now what we are trying to do here is we are trying to write into a file. All right. We are trying to write the name or there's some ID or something. We are trying to write this content into a file, right? Into your local file. We'll write a program on this, which would give you a clear idea. And the next step that we are doing here is kind of we are reading it from a file. All right. So the first step that you do is write into a file. The next step that you do is read from the same file and print the contents of it. All right. So it's not mandatory that you have to specify the same file for reading, right? This is for just for the convenience or just to demo it. We are using the same file. You could have different file as well. All right. So let me show you how this is done. So again, I create a new project for today, which is, all right. So we create a new project, Edureka module 4. All right. So we have this project. Now let's create a new class. com.edureka is nothing but the package name. And I give, say, input output demo. All right. So before we start off, I can do one thing. I can create a folder here. It says Edureka IO. All right, so we'll put all the files here. So this is an empty folder that I have created right now, or let me put it here. So for simplicity, I'm going to put it on C drive itself. All right. So on C, I've created Edureka IO directory, wherein we are going to dump all the files, right? Whatever we are going to do, it's going to come into this particular directory. All right. So the first thing that we are going to do is, so now we are thinking of writing into a file first, right? So I create a main method, right? The first thing that I do is create a file. All right. And I create a new file, which is nothing but I'm calling the constructor of a class of the class file, which is within Java, right? It's not something that we are writing. So Java itself has this internal file class, which is file. All right. So now I point to this particular directory. All right, com.edureka.io, and we say, so I call it as employee-info.txt. All right, so we are going to write into this file now from Java program. So now it's showing up an error saying that which file I want to refer to. As we said, all the IO related files, all the IO related classes are placed in java.io package. So I select this package. Once selected, you can see an import statement here coming up. So why do we have import statement? Because file is a class which resides in a different package than com.edureka. Had it been within com.edureka, you need not import it. It's outside, so you have to import it. All right. Then there are different ways in which you could write it, but now we'll follow the same example. So I write print writer. Print writer is there within java.io, and you could see it imported here. All right. Employee info writer, say for example. Okay. Now create a new print writer. And if you see the constructor of print writer, so we spoke about constructor overloading and stuff like that, right? So you could see if you go into the source code, if you want to deep dive more, you could go into the source code and see it takes file. All right. So here you could see an option, which is nothing but it consumes file. So the file which we created above, I can put it as employee info file. All right, so there's a file that's created here. So I put the same file here. All right, since the constructor supports file itself. Now this is checked exception. All right. You could see here, it is saying Java is explicitly saying that you are not handling this exception. All right. So ideally, the better practice is you shouldn't be writing everything into the main because it would become cumbersome to understand later on, right? You shouldn't be dumping everything to the main method. So as a good practice, what you should do is you should create a new method, write to file. All right. So this is best practices, right? It's not mandatory. Java is not going to tell you there's an error or something, but as a part of best practices, this is how you should write programs, which would make it readable for others, because tomorrow some other developer is going to handle this particular class. It's not that you are going to be there throughout, right? So basically, so that other developers can easily read it and maintain it well, this is how we write it. I move this content. So whatever the writing part is, I move this content here. All right. So now it's showing up an error saying that it's not been handled, right? File not found exception is not been handled because it's a checked exception. So remember, in the checked exception, we said that there are two options. One is to handle it within your method, or this write to file method can opt to throw it off, saying that I'm not going to handle it, let the caller handle it. So when I say caller is nothing but this method. All right. So I'm going to create, say here, input demo. So I'm creating an instance here. All right. And demo write to file. And I'm going to pass the file that we created here. All right. So there was one file that we created here, which is pointing to an employee info.txt. And we are calling this method to write it. If you think about the reusability part of it, so this is how you make the method reusable. If you put it into main, you cannot reuse it. If you're taking the right logic outside the main and refactoring and putting all the code that is specific to writing to a file into a particular method, you could reuse this method. You're making it generic, right? Now I opt to throw it off, or let's handle it. All right. When I say let's handle it, it's nothing but you have try catch block. All right. So I say catch. So what exception was that? It was file not found exception. So you need to have file already in place. All right. So here I print saying that given file was not found on the local disk. All right. And what's that file? Maybe we can print the name of the file as well. All right. So here we have chosen to handle it. Okay. So we remove this. All right. So we have a try catch block written now, and we say that okay, so we are handling this error. So we say that just print a message saying that given file was not found on the local disk. And as a good practice, I don't want further processing, right? If I don't have a file, I don't want to process it further. So I say throw runtime exception, and so runtime exception is unchecked exception. It won't give you error even if you don't handle it, right? Whereas this was a checked exception, that's why you were getting error. Basically what I'm doing is I'm catching the checked exception and wrapping it into unchecked exception. All right, because I don't want this to be processed further. So once we have this print writer set, so I'll have to take this print writer outside, or I'll put it here. All right, so what I do is employee.println and I write some content to it, and say in this case I'm writing Vinod. I write some ID to it as well. Anything you could write, okay? Once I write into the file, I have to ensure that I close the file. So basically you could have finally block. So you would do for this, I'll have to take, so this, if this is within try, so it's not accessible within the finally block. So to make it accessible, what you will have to do is you'll have to take it outside. All right. So I define it outside try block so that it gets accessed in finally. All right. So now what I do is employee info.writer.close. I close it. So that's one of the use cases of finally, as I said, it's basically for closing the resources. So this finally would execute even if this doesn't throw or don't throw any exception, and it would get executed even if it throws an exception. All right. So that's what the use of finally block is. So let me quickly run this program to see. I have to create a file here. So I create a text file here, .txt. All right. Before I create a file, maybe I would want to show you what happens if we don't have a file, right? So if we don't have a file, I run it. So we don't have anything into C Edureka IO. All right. Basically, you're trying to write into a file which doesn't exist at all. So it's building and it's running now. Even if you don't have a file, it doesn't throw file not found exception. Rather, it creates one on its own. So remember, we didn't have anything here. Now let's see the content of this file. You could see whatever we wrote, right? The employee name, and you could see the employee ID, which is 100. So whatever you wrote here came into that file. All right, now let's write a program to scan or to read through this file. All right, so maybe I can use the same file or I can use something like, all right, so I write something like BMW, Mercedes, Audi. All right, I write something like this, say it's a vehicle info, and say you have something like, or let's keep it as is. Okay, so you have vehicle info in here. So now we are writing a program to read from a file. All right, so we pass on the file parameter here. There are different ways in which you can do. All right, so we create scanner. Now scanner takes, if you see constructor, you could see that scanner takes file as a parameter. All right, so I put scanner file. Again, it's saying that file not found exception is to be handled. So in this case, you have to be sure the file is present, right? Since you are reading the file, in the earlier case, it was writing to the file, which can create a file. But reading to the file, you have to be sure that the file is present, or else you would get a file not found exception. So in this case, I choose to throw the exception. The read file is saying that I don't want to handle this exception. I instead throw it off. All right. You could see throws here. Okay. Now what we do is we read lines from it. All right. So we have like, okay, so we read line from it and we just print it out. Basically, you would have something like, so let me just print line read from the input file. All right, so this is nothing but we are just printing whatever we read from there. And basically, this should have something like it should loop in until it's the end of the file. All right, so this is how you use the while loop, similar to what you do in C and C++, right? Till the end of the file, till EOF character is encountered, you kind of read the lines within the file. All right, so this is a method that we have written, but we haven't invoked this method yet. So I create file. Since it's a different file, we have to create a file. Vehicle info is equal to new file. We give the path of it, which is nothing but edureka io vehicle info.txt. All right, we created a file here. Now what we are going to do is we are going to call read file on this file or vehicle info file, and we should be able to see the contents of it. All right, so now one thing here is since you have thrown exception, it's saying that exception has to be handled here. All right, I can choose to not handle the exception here as well, and I am adding it to the method signature. So main would throw as well. So basically what would happen is if you don't have a file which is being read, your program would stop at that point because you're not handling it anywhere, right? You're just throwing it off up the ladder. So basically at the end, if you don't have a file, you're going to get a exception. Your program is going to stop there. I run this file and let's see what we get. All right, so you could see BMW, Mercedes, and Audi being read out from vehicle info. This was the content that we had within the file and which you could see it's been read. So file writer and file reader. So similar to print, this one is a different way of writing it. So what's written within this program is nothing but we create an instance of file writer and we pass the string, the path of the file rather, as an input to the file writer. Now file writer is nothing but it's character oriented, right? Print was not as such character oriented. This one is character oriented, which means 2 bytes, right? Character is nothing but 2 byte size within Java. So this one is not like it doesn't work at the byte level. Basically, whenever you're dealing with character oriented file, you could use this one rather than print writer. All right. Object of file writer is being created, which is a character oriented file or which is a character oriented class. All right. And you write to a file. You're writing to the file here. All right. And similarly, when you use file reader, it's a character oriented reader. Reads character, one character at a time from the file that you have mentioned here. So maybe I'll take just an example of writing it because it's going to be pretty much similar. So I'll quickly write this program. You have a main method. You create a method to say you have public or it could be a private method. As I said, the best practice would be to restrict as much as possible, right? If you don't want this method to be called from outside, you could have private method. So it's going to be write to file. So you need to give string or you can have file as well, whatever you prefer to. You would have file and file to write to. Okay. So basically we were talking about file writer, right? So I create file writer object. Okay. And again, say it's a bike info. And I pass this file to which you have to write. All right. So again, you could see now you could see a checked exception that is nothing but is showing that IO exception has to be handled. Now I choose to throw it off. I'm not handling it here. Bike info dot I write to the file and I write some content. Basically, this should be writer just to make it more elaborate. All right, I say writer dot close this particular file. Okay, now I give a call to this method, which is nothing but file writer demo is equal to new. We are creating instance of it. Okay, let me create a file, which is nothing but file bike info file, and which is new file. And within the same directory, which is nothing but com.edureka.io, I create bike info.txt. All right, so what we are doing here is using file writer, we are going to write into bike info.txt and we are going to write this content that is Ducati. And maybe after this, we could have, so whatever you have in buffer that would be flushed off to your disk. All right, so when I run this, basically we don't have a file now, bike info, and I think it should create it. So you could see here, we don't have a bike info file. Okay, so again, let me talk about this program. So what we have written is we have a file. So what we are trying to do is we are earlier in the program, we wrote using print writer. Now we are going to use file writer, which is a character stream based IO. So we are going to write into bikeinfo.txt file and we have a method write to file in which we are creating a file writer object, which is taking up this parameter or taking this file, which we are going to read through as an input. All right. And not read through, it's rather write to. So the file to which we are going to write is taken as an input parameter to the file writer, and we are writing into this file. So right now we are just writing Ducati there. All right. So I invoke this method like file writer demo dot write to file, and I pass on this file here. All right. Shows up an error that you have to handle IO exception, which has been thrown from write to file. So I choose not to handle it here as well, which means if you don't have that file or if there's some IO exceptions that's been triggered, program would stop. All right. So I run this program. So basically it should create file and should write to it as well. All right. So I go to the directory So you see bike info file has been created here. We didn't have it earlier. It got created after we ran this program. Now I just open it up and you should see the value Ducati being written there. All right, so that's about file writer, and similar to that, you have to just read through it. You have to pass the file that you want to read as a parameter, and you just have while loop to iterate through till the end of the file, and you can print the character. So basically, it's pretty much similar to what we did for the print writer, but I just wanted to demo for one of these cases. So we took an example of file writer. All right. So now let's move towards stream-based IO. So Java streams are used to perform input and output operations on 8 bits, a byte, right? Streams is basically operating on a byte. Input stream, it is used to read the data from the source. It could be file, it could be keyboard, or it could be anywhere across the network, right? It could be a socket as well. So basically, it is used to read the data from the source. That's input stream. And output stream is nothing but if you want to write something from your program to any resource on a network, that would be nothing but write. That would be nothing but output stream. All right. So with output stream, you would typically write data to a destination, and with input stream, you're going to read it from a source. All right, just to walk you through. So we have object, as I said, all classes or every class in Java is inherited from a class that is object. All right, this is a super class for all the objects, all the classes in Java. Okay, so you have object and you could see that there's input stream and output stream. So let's talk about the input stream. There's file input stream, there's byte array input stream, there's filter input stream, and there's object input stream. So we'll talk about this in the coming slides. Why do we have object input stream and stuff like that? But right now you could imagine that we have multiple classes, or you could think that there are multiple classes with it input stream, which are used for different use cases. Like you have buffered input stream, which is nothing but it buffers it. It doesn't read or write it in one go. It sort of buffers it and then it flushes it over. All right, output stream, similar to input stream, we have a output stream. It's an interface, I believe, which has got several implementations like file output stream. You have byte array output stream. You have filter output stream. You have object output stream. And filter output stream is further categorized as or has further subclasses as buffered output stream and data output stream. All right, so in further slides, we are going to discuss file input stream, file output stream, object input stream, and object output stream. Okay, so file output stream class and file input stream class, let's talk about it. So file output stream class is used to write to a file, right? You could take a byte array and you could write to a file. All right, so you could take something, if you have a string, you could convert it into a byte array and you could pass it and it would write to a file. So remember we said it's a byte oriented, right? So basically it's going to take array as input and it's going to write to the file that you have mentioned in there. All right, so you could take integer as well. It is used to write the specified byte to the file output stream. So you could provide integer as well. There's a close method, which is nothing but closing the stream. So streams are nothing but it is hooked up to the resources. It is taking up resources and there's a connection between your program and the file established, right? When you create streams. So when you close it, you close that connection and it is free for garbage collector to remove that particular object from memory. So basically it frees memory as well, right? Unless you close it, it's going to stay in the memory. So it's a good practice to close it right after you use it. Okay. Writes, you could write to a particular offset, which could be done using write method. So write length bytes, whatever length you have mentioned in as third argument, it would write it to a particular offset. It would write the byte that you have given or byte that you have passed in as input. It would write that byte into a particular offset. You have flush method, which is nothing but flushes the output stream and forces any buffered output bytes to be written out. All right. So it could be buffered, as I said. So not writing it each and every time you have byte. Basically, it buffers it, and you could have flush method to flush it off to the file. So basically we have buffered stream, which uses this method. All right, so here we have file output stream, and using file output stream, we write it to the file and then we close the file. All right, as far as the syntax is concerned, it's pretty much similar to file writer example that we took, but just to give you a demo, just to show you how it is, we'll have one demo done here. All right, so I create a new class, which is nothing but file output stream demo. All right, so we have a main method, and I create a new method which is like file write to a file, which could be like private method, private void write to a file. All right, so we are going to write to this file using what? Using file output stream. So it's showing up this. So I select java.io.file. All right. Okay, now I create file output stream. I create instance of it, right? Similar to how we did for other programs. Now it says file not found exception has to be handled. I choose not to handle it and I throw it back to the calling program. All right. So now what I do is I do file dot write file output stream. I am going to write it to this file. So I just write a text here. All right. So write a text here. Hello folks, hope you are enjoying the session. And I just close it off. Again, it throws IO exception when you close it. So remember we said there could be multiple exceptions that could be thrown out of a method. So I choose to throw this one as well. So basically what I'm trying to do here is I throw IO exception as well. Okay, so it doesn't take a string as an input. So what I have to do is I have to do dot get bytes. As we saw the constructor of it, constructor doesn't take string as input in case of output stream or in case of file output stream. It interacts in terms of byte array and stuff like that. So I converted this string into byte array. So when you see get bytes method is a method on your string class which converts the string into array of bytes. All right, so now what I do is I give a call to this particular. I'm writing to a file and I'm going to create a new file. So I can take the same file, right? I'm going to take maybe, or else I'll create a new one. All right, so I create a file which is like message.txt, or you need not even create it. It will create by its own. I'll delete it maybe, okay? Only thing is I'll have to create C edureka.io. All right, and here we say message.txt. All right, so I call a method to write to the file using file output stream. I choose to throw it off from here as well. All right, so we have a method which is going to write into a file using file output stream. All right, so I run this program. Okay, it ran successfully. Let me open this message and see if we have the message written there. All right, so you could see here, hello folks, hope you're enjoying the session, which is written from your program. All right, so there's file input stream as well, which is pretty much similar. It again operates in terms of bytes. As you could see the signatures of the methods within, it would read the contents of the file into the byte array that you have passed as a parameter. The second one is to read from a particular offset till the length that you have mentioned or passed as a parameter. Close is pretty much similar. It would close the connection that's been established and it would make the class available for garbage collector to clean it off. Okay. Garbage collector is nothing but unlike C, wherein you have to deallocate the memory location that's been used. Garbage collector is parallel thread that is run by JVM to remove the or to free up the memory space that's been acquired by classes. So it runs sporadically. It's not within your control. It runs sporadically and it clears off the memory locations. We have a read method, which is nothing but reads the next byte from the input source. So on the file input stream instance on which you read it, it would read out the next byte. And if it's end of the stream, it would return -1. So the return value is integer, as you could see here. You could skip specified number of bytes from the input stream, and available returns the number of bytes that can be read from the current stream, right? So maximum number of bytes that could be read out. So I'm just going to read through this slide, or if you want, yeah, I can take an example maybe. Since we didn't take example on reader, I'll take one example on reader as well. Okay, so here I do file input stream demo. All right, so we create a class here, and I have a main method here. Okay, I have a private method which says void, and it's not returning anything. And I say read from file. All right, which takes file. Again, I'll have to import file. Okay, so java dot, you could see the import statement coming up here. So now I create file input stream. Okay, I create a new instance of it, which would typically take, for that matter, it could take string as well. Just to show you a different variant of it. It's not that you have to always pass file, you could pass string as well. All right, so we are passing a string here. It says file not found exception has to be handled. Since it's read, you have to ensure that you have the file there, right? So I choose to again throw off this exception. So I'm not handling it. So typically you would handle exception when you want to do something on it, right? When file not found, if you're trying to read a file and that file doesn't exist in your drive, I wouldn't handle it. I would just throw it off. I want program to break right there, right? I don't want it to proceed because our program, this particular method is trying to read from a file. And if it doesn't exist, it doesn't make sense to proceed further. All right, so I have input stream. Now what I do is dot read, and as you could see, it's returning integer, right? So this has to be looped. All right, this has to be looped until you get -1, right? So basically you would have like, say, integer, and you have like, so this is integer read from file. All right, and I keep this as integer, which is, so whatever you read, I need to assign this because I want to write that as well. All right, so I'm assigning to this. And unless this is -1, you're going to read through. All right, it again shows exception, which I need to handle. So this time it's IO exception, and I'm going to throw this one as well. All right, so you have a read method, you are going to read it, and basically till the time it's -1, it's going to be read. All right, now what I'm going to do is within the loop, I'm going to just type. So basically I'm going to just typecast this to character. It's read as integer, so you have to convert it into character if you want to see in terms of character, or else you would get the ASCII value of it. All right, so once this is done, basically I need to close off the stream as well. Okay, now what I do is I create the instance of file put stream demo, which is nothing but creating instance of it, right? Demo.read from file, but remember this time we are not creating a file instance. We are just passing the string, all right? So you could take any of this file. Since we are reading it, we could take like, let me take bike info, right? It just got valued Ducati. So I'm passing this as a string this time, all right? And it's a different variant. You could pass it as a file as well. You could pass it as a string as well. But since I've been passing as a file in previous examples, this time I chose to pass it as a string. All right, so now I'm throwing it off from here as well, since I don't want to handle it. right? So if I get an error, I want the program to break. So that's the reason I'm throwing it off from here as well. So I got an error. Let's see what's it. Okay, so I have to put double slash here. All right, I missed that one. So basically, if you don't put double slash, it would take it as a regular expression sort of. Again, it's not bike info, it's .txt, which I missed, I believe. So it says that bike info file doesn't exist, right? Since it's a text file, right? You have to provide the extension as well. All right, so you could see it read in terms of characters, right? So you could see the first character read as D, then you could see it followed till it read Ducati. All right, so that's about file stream or file input stream. That's how you write programs. Now, what serialization and deserialization? I'll quickly cover on this one. Since this is something that's been used widely in big data, when it comes to big data or when it comes to distributed computing, just not to, if you understand, it's good. If you don't understand, you don't have to think much, but I'm just talking in terms of distributed computing, right? So when it comes to big data, it's not that you have server farms and everything. Your program doesn't run on server farm anymore. It's more about you have commodity hardware on which a program is run. And that's what big data frameworks are good about. The investments in terms of infrastructure by having server farms has been reduced a lot, has been cut down a lot, and you could have commodity hardware on which you could have this distributed frameworks running. So say for example, you might have heard about Hadoop or Apache Spark, which could actually run on normal hardware, right? Or you could run it on cloud as well. So you have like Amazon Web Service, which is cloud. Like you have Google as well, Google services, which exposes as a cloud. You have Azure, which is nothing but Microsoft's cloud. So all these are kind of not big hardware, not server farms that you have. It's a normal hardware that you could configure and you could run through your chunks of data or petabytes of data that comes in from cloud or from elsewhere, right? So that's the beauty of it. That's the beauty of Java. And one of the main things or main feature that Java has got is serialization and deserialization, which helps in having this distributed framework going. Okay, so serialization is nothing but you have class, right? And you create instance of a class, which is nothing but an object, right? Now, this instance of a class, if you want to pass it over to some other computer or some other computer on your network, right? This could be done just because there's a serialization. There's a concept of serialization, right? Suppose I create some object of a class today on my computer. And if I want to pass the same state, right? It's about passing the state, not the behavior. Behavior is, of course, just methods, right? So it's about passing the state of the object. So whatever state my object is, or whatever properties my object holds at some particular point, if I want to pass it over to some other computer on the network, this could be done just because you have serialization. Because what you would do is, basically, if you remember, the object stays in heap, right? Heap memory, which is protected, which no other process can get into that particular heap process, heap memory, right? That's a security that Java provides. If you remember in the first slide, we covered it, right? So what Java does by serialization is whatever contents of a particular object or whatever contents a particular object holds at any could be written into your disk as a binary file, and you could send it over to some other computer via wire, or you could take it, plug in your USB drive, and you could just take that particular file, the binary file that's created, and you can go elsewhere and just play that file or just deserialize it to see the contents of it, right? So you could imagine this is something that is needed in terms of distributed computing. Since not everything is being carried out on a single computer, you would process something on your computer, you would write it to a file, and you need to pass on this file to a or transport this file to a different computer, right? Or a typical example in which you would think of serialization is more about you could have, say for example, one operation carried out on one computer and same operation or different operation on a same file carried out on some other computer. Now you want to merge them together, and that's where you would have serialization and deserialization coming into picture. Basically, to understand the concept, serialization is nothing but writing the state of the object to a file, and deserialization is nothing but again taking the state of the object that's been written to the file, again putting it back to a class format. Or when you want to use this serialized class, you would basically deserialize it to use it. So serialization is a process of converting an object into sequence of bytes which can be persisted to a disk or file and can be sent through streams or can sent across wire, or could be you could actually take it on your drive and transport it elsewhere. The reverse process which will convert data bytes into object is called deserialization. All right. So how do we have this serialization and deserialization done, or what classes we have for supporting it? Let's talk about that. All right. In this example, you have a student info, which is having ID and name, right? And basically you could see that we have created an instance of student info, which has value of 9 and John. All right. And now what we are doing is we are writing the state is nothing but the value that this particular object holds, right? Which is nothing but ID of 9 and name value of John, right? So we are writing this into a file which is nothing but student.txt, and we are just writing that to a particular file. Okay, and this is nothing but the student.txt file that you see. It shouldn't be txt actually. It's a binary file, so I would rather prefer to have student.bin or binary, and you would write it to that file using write object. So the supporting class for serialization is object output stream and object input stream. All right, so I'll quickly take a demo of this. So the first thing that we do is serialization. Serialization is done by object output stream. All right, so again, we have a main method. Suppose I want to serialize it, so I would do something like, say I have a private method which is void, which is serialize. Okay, so the first thing I would want to create is nothing but Java class which will hold the state, right? So this is a class which you want to serialize, or which you want to send it across to different computers. So such classes are known as model classes, right? Basically, such classes are nothing but classes which holds chunks of data. So for simplicity, we have taken small data like ID and name, but in general, you would have like chunks of data there. All right. So here I say vehicle info. Maybe this is the class that I have here. All right. And now what I do is suppose I have two parameters here. All right. So I have two parameters here, which is nothing but integer. And suppose I have like a string name of vehicle. All right. So now I define a constructor for vehicle info, which takes three parameters for simplicity. Number of wheels. First is, say for example, I take name of vehicle, then its number of wheels, and say I have one more parameter which is mileage. All right. Now remember, we use of this keyword since the name of the arguments and the name of the instance variables are the same. We need to use this. This dot number of wheels is equal to number of wheels. All right, and this dot mileage is equal to mileage. All right, so this is a simple model class which is supposed to hold values. Basically, in reality, this would be holding like chunks of values. Okay, imagine like could be like megabytes of information or even huge gigabytes of information. All right, but for simplicity here, we are taking this simple class. All right, now what we want to do is we want to serialize this into a file. We are going to create an instance of this particular class, and we are going to write the state or whatever values we have in that particular instance. We are going to write it to a file so that it could be read from somewhere else, or it could be used by any computers on the network. All right, so I have vehicle info. Again, suppose I write BMW is equal to new vehicle info. Now what I have to pass is name of the vehicle, which is BMW. All right, number of, and I pass some value like 10. All right. Okay, now we have created instance of vehicle info and we have passed the values that we want to pass it. And now we want to serialize this. Okay. So how do we serialize? Is nothing but we use object output stream, right? So what does it take? So basically you could go into the source code, and if you want to deal more, you could actually see what are the constructors that it takes. You could see it takes output stream. So one is output stream as a constructor. If it takes output stream, then I'll have to create file output stream. Basically, I'll name this as object stream, and this one would be file stream. Okay, I create a new file output stream, and you could pass the file on which you want to write it. All right, so in this case, the file on which I want to write a particular class, I'll pass it as file, and I'll be passing it over here. All right, so what I'm trying to do here is resolve this. Okay, so you take the file to which you want to serialize. So basically this vehicle info would be serialized into this file, and this file would be transported anywhere across your network. So it shows file not found exception. Again, I choose to throw it. It shows IO exception. Now I've passed this file stream here. All right, so this is how we usually write programs. You have file input stream, the file output stream, which is nothing but the file to which you want to write the state of the object, and you instantiate object output stream. Okay, now let me write to it. Okay, so basically what are you going to write is nothing but vehicle info, just instance of. Okay, so you want to write this instance of vehicle info, particular instance of vehicle info into the file. Okay, so I write something like this. Okay, so basically what we'll have to do here is whenever you have this thing, whenever you want to write, or whenever you want to write the state of a class to a file, you need to implement one interface which is serializable. All right, it's a do nothing interface. It's just used by, it's a markup interface as well, marker interface rather. It is just used by JVM to say that this particular class could be serialized, but it doesn't have any methods within it. As you could see, if it would have had some methods, it would have shown an error saying that you should implement it. But in this case, it didn't, because it doesn't have any methods within. All right. So basically when you have object stream dot write, okay, so it takes, all right, so
So,
we create an object stream, and we pass the file that we want to write to, and we have write object method which would take the instance of the class that you want to write, and we have, like, we flush it and we close it. So one thing to note here is vehicle info class has to implement serializable. That's a marker interface. Serializable is nothing but a marker interface, and it doesn't have any method within. It is just an indicator. As you could see, it's an empty interface. All right, this is the source code of it. You could see it's an empty interface. It is just a marker, or it is just a notification to the JVM saying that this class is something that could be serialized. All right, so we have this class, and we are going to serialize the state of BMW object into a file. All right, so now what I do is I create object output stream demo, and I call serialize within it. Now this serialize is taking two parameters. So the first parameter is, this is other way of passing it. We are not actually creating instance, we are passing it directly. All right, so I pass this and I say serialized file, okay, or maybe dot bin. And the other parameter that it's taking is nothing but the instance of class that you want to serialize. All right, so here we are again getting exception which needs to be thrown off. All right, so this is a simple class that we have. We have vehicle info which carries BMW instance, or we have created instance of vehicle info with BMW values, and we are trying to serialize this to a file which is serialized file.bin. Okay, let me see if it runs. All right, so I hope it ran. Now this is a binary file. If you see, you're not going to understand everything that you have within this file. Okay, so I just, okay, so here you could see it's not something that could be completely readable, but you could get some idea about it. It's storing BMW. All right, and this is not meant for you to read it, right? It's not in a human readable form. This is basically for passing this over a network, and at the other end, you would deserialize it. All right, so this is how we serialized it. Now we will check on how we deserialize it. All right, so you saw the contents, right? It's something that is not readable. Okay, again, I'll open it up. Not everything would make sense, but you could see that this is for BMW. So basically you could see the value BMW here, right? So now what I do is I want to deserialize this, right? So this is how you serialize it. We spoke about it, how we serialized it. Now we are going to deserialize this. So basically this deserialization won't happen on the same computer. It might or might not, or it could be say different application within the same computer as well. So if you have two applications running and if you want to interact between the two applications running on the same computer, could use serialization and deserialization. Or you could, majority of the use case for this feature is more about passing it over the network. All right, so let's see how we deserialize it. Okay, so when you deserialize it, you use object input stream. Okay, so in the same class, or I'll just for simplicity's sake, I'll change this to object stream demo because this is not just. All right, so I refactor it and I rename this to, okay, so this has been renamed to object stream demo. Now create a private method which is nothing but void deserialize. Again, for the deserialization, you need to have the file, right? You could imagine of you having the file, and file should be okay. Okay, so now what we do is, so basically we could have this as a file rather, since we are going to send the same file for deserializing as well. So it's better to have it defined here and you pass it as serialized. Okay, so far we have serialized it. Now we are going to deserialize it. So what you do in deserialization is nothing but you use object. So the first thing that you will have to create, similar to we created file input stream above. Now we are going to file output stream in the serialized case. But here we are going to create file input stream. And I provide the file here. All right, so we have file input stream created. Now we have object input stream. All right, we are creating instance of it and it would be new object input stream and you would be passing the file input stream that you created in the step above. All right, it's showing you for exception. You have to could either throw it or you could handle it. So in this case, I'm throwing it off. All right, so we have, so here you could see we had write object. Now I'll have read object. So read object throws file not found exception or class not found exception that you need to handle. All right, again throw it. So here you could see IO exception and class not found exception, right? Single method can choose to throw multiple exceptions from within. All right, so we have chosen to throw it. Now we have vehicle info, or we don't know whether it's BMW at that point. So I say deserialized object. All right, so object stream dot read object by default it returns object type So we need to typecast it. This is how we typecast it, one form to other. So basically we know that object stream.read object is going to give us vehicle info object. That's why we can actually typecast it. All right, so now what I do is once I get this deserialized object, I'm going to print out the values that I have within. All right, so I'm going to print the name of the vehicle. So I say, all right, put as, all right, so name of the vehicle in the serialized file. Similarly, I just copy paste it. We'll print number of wheels. All right, and we'll print mileage of vehicle. Don't need this one. All right, so basically we are serializing it and then deserializing it. After deserializing it, we are printing the value of the contents, or we are printing the contents of a particular object to see if it is what we expect. All right, so maybe I can do one thing. I can delete this off. Let me close this and let me delete this off. Okay, I'm deleting serialized info. I'm going to run this program again, and this program will serialize and deserialize it. Okay, it will serialize it in the first case, and now I'm going to write for deserialization. Deserialized and the serialized file. All right, now here as well, I'm going to throw it. Okay, so first we are going to serialize it and then we are going to deserialize it and see whether we get the contents that we expect. All right, so it's running. Let's see if the file has been created. So we deleted the file. It's not yet come. So we can see that a file was created here, right? Which is a serialized file. And we printed the value from deserialized file as well. After deserialization, we printed the value of the contents in the serialized file, which is like we got the expected value, which was BMW 4 and 10, which you had said. So basically what we are doing here is we are storing the state of a class or state of the object to a disk, and this could be transported anywhere. When I say it could be transported, it's nothing but this is just a binary file, right? So you could take it into your text file, or you could take it into your pen drive, and you could take it anywhere. All right, so that's the beauty of serialization and deserialization. I spent more time on this because this is something that is very important for big data. Since big data is nothing but all the big data frameworks that we have, they follow distributed computing, and this is one of the important internals of distributed computing. Though you need not take care of it, it's all taken care by the big data framework, but this is an important concept to understand. All right. So let me quickly talk about wrapper classes. It's not an important topic though, but I'll quickly cover on this thing. So wrapper classes are nothing but you have primitive data types that we discussed the first day, right? So initially we didn't have this wrapper classes in picture when the initial version of Java was created. So data types were dealt in terms of primitive data type itself. Then since Java is object oriented, right? It has to be completely object oriented. So they came up with a concept that we shouldn't be dealing data types as a primitive data type. Rather, we should be having some sort of object to it, which is wrapper, right? Which is wrapping this primitive data type. So in order to make it completely object oriented, they have come up with this wrapper classes, right? So int, when you define int, right? If you define int something of this sort, it's primitive. Whereas you would have something like this, inti is going to be primitive data type, and whereas you would have something like this, which is nothing but wrapper class, right? So if you go into the wrapper class, you could go into the source code and see it's nothing but it's doing the same thing. It has got some utility methods as well on the top of it, but basically it's storing your value. So for now, they have changed the source code quite a bit. Basically, it's storing in terms of characters, I believe. All right, so you need not take care of this, but what I'm trying to say is wrapper class is nothing but a wrapper built upon the primitive data type so that everything is taken care in terms of classes since it's a completely object oriented programming language, right? So Java has a class dedicated to each of the primitive types. These are known as wrapper classes because they wrap the primitive data type into the object of that class. All right, so you could see for byte, you have a wrapper class, corresponding wrapper class as byte, which starts with capital B. All right, since it's a class, it has to start with uppercase or it has to follow camel casing. Short has again short, int has integer, long has long, float you could see a corresponding wrapper class with name float, double will have double, char will have character which starts with uppercase C again. Boolean again has camel cased boolean as its wrapper class. All right, so when it comes to classes, you could have hierarchy. So basically, you could see that all this byte, short, integer, long, float, double, everything is subclassed from number. So basically, in the source code that we saw for integer, you could see it's extending number, right? So that's what it is saying here. It's a subclass of number. Integer is a subclass of number. So how do we use wrapper class? It's basically you just have to pass value to it, or you could have as a part of constructor you could pass some kind of value to it, or so you could either assign value of 100, right, or you could have something like this. Okay, so you have different variants of it. You could either create it directly, assign literal value to it, or you could have something like this. But as you could see, this is deprecated. This is no longer required actually. It is still accepting it. It's not throwing compile time error, but it's deprecated, which means if you're writing a new code, you shouldn't be writing it this way. So there's also concept of auto boxing, which is nothing but if you have like integer a could be assigned value k directly, all right, or could be assigned value j directly. So it could be converted from wrapper class into your primitive type without any kind of conversion. That is known as auto boxing. It does it by itself. Now, what is generic in Java? Generic is nothing but template in C++, in C++ rather. You define a template which is a general this thing. You're not putting in a specific data type. You are saying that this is what it is. It's a template and you could have any data type during runtime. So basically what you're trying to say is this particular method or this particular class is a generic class which could handle any data type that is passed. So it's not specific. All right. So generics in Java is similar to templates in C++. Generic enable type parameters when defining classes, interfaces, and methods. All right. So the type parameter is nothing but a generic type, and it's not saying that it's going to deal just with integer or with character or with string. It is saying that it could handle anything that comes, any type that you would send it, any type that you would instantiate that class with. All right. So when we take example, you should get some more idea about this. Generic provide compile time, type safety, allowing programmers to catch invalid types at the compile time. So generics work on type erasure, which is nothing but which is done at the compile time itself. Basically, it's done at the compile time. It can catch exceptions during the compile time itself, or it could prompt you during the compile time itself. All right. We can specify the type in the angular brackets. So whatever type you want to do, whatever type is that class going to handle, we can put it into angular brackets, which makes it generic. All right. So here you could see that there's a method which is print array, which is taking E as type. So as you could see, E is a type here. All right. E is a type here. And we are not mentioning that it is going to take print integer array or string array or something of that sort. We are saying that it's generic. So whatever you pass or whatever you instantiate it with, it's going to take that array and print elements within it. All right. So this method could be thought of as a generic method, right? You could think of this print array as a generic method, not a method which is just taking integer and printing it. It could be string array or it could be anything else. So that's what generic means. Advantages of generics: type safety. Objects of single type can be stored in generics. We would be looking at it in the next example. Typecasting is not required. There is no need to typecast this because it knows that what kind of objects that particular data structure would carry or hold. Compile time checking, it checks type mismatch error in compile time, which avoids runtime errors. All right, so imagine a list, which we are going to talk in further slides. What is list? But imagine a list which is a collection, all right, and you have like Imagine a list which is holding strings. All right. So you have list dot add and you add edureka to it. Now when you get zero, typically get zero would have object. The return type would be object since it doesn't know that it is just carrying string. Nowhere you have mentioned that it is a string of, it's a list of string, right? It's a generic list. So it could hold integer value as well. All right. So in that case, what you need to do is when you do list.get zero, you have to typecast to the string. Yeah, the next element could be integer. We don't know, right? Since we haven't said that it's a list of string. So that's the reason you need to have typecasting done. All right. Now using generics, you could define that this list is a list of string. All right. It's going to carry only string, nothing else it's going to hold. Now it makes it simple, right? You add edureka. Now if you try to during the compile time itself, if you try to add integer to it, like list.add 100, it would throw an error saying that it cannot hold integer because it's meant for string. So that's the advantage that you get over generics. You could hold it, you could catch errors during the compile time itself. All right. So it won't allow you to add or it won't allow you to put 100 into your list of string. All right. And since we know it's going to hold only string, there's no need of typecasting it as well. You can see here it's not typecasting it. In this case, you had to put this string here, right? So basically, in this case, you need not typecast it. There's no typecasting required because we know it's a list of string. Now, what are collection frameworks? Collections framework is nothing but you have data structures in terms of classes. Again, it's a wrapper for data structure. All right. It's nothing but like you have array, which is normal primitive arrays, but this one would be sort of growing array. So basically you need not take care of actually, adding up indexes to it. It would automatically, it's a self growable array. So you could imagine when it comes to array, you could imagine collection. You could imagine one of the classes within collection is list, which is nothing but growable array of any data type. All right. So Java collection framework provides an architecture to store and manipulate a group of objects. A Java collection framework includes the following. It has interfaces, classes, and algorithm. Interfaces is nothing but again specification. This is how it should be. So Java says that, when you have a list, it should have so and so methods like adding to the list, setting to the list, removing some elements to the list, something of that sort. So it defines collection. If you have a collection, you should have so and so methods, and list should have so and so methods, and so on and so forth. So basically, it's for specification. Classes is nothing but concrete implementation. So list would have all the methods that you just the it's an interface, right? So it would have all the methods that you want without any implementation, but this classes would be actually implementing it, or rather it would be implementing these interfaces and would be giving a concrete implementation for methods, right? So as you could read here, it's concrete implementations of collection interfaces. In essence, they are reusable data structures. All right. Algorithm is nothing but there are utility algorithms that you have, like if you want to sort a particular collection or if you want to sort a list of string, you could do it using your algorithm, using a predefined algorithms that already comes preloaded with Java. All right. When I say algorithms and where are these algorithms residing? There's a class which is collections. So you have a collection which is an interface, top level interface, and you have a collections class which is holding all the utility methods or algorithms, whatever you call. So basically, you could just read through this hierarchy. These are different types of data structures that is being supported by Java. You have a collection. So the top level interface is, as you could see, there's collection which is extending iterable. All right, extending iterable interface. Collection itself is an interface. You have a list as interface, which is extending collection. All right. So list is extending collection. Queue is extending collection. Set is extending collection. So we have three distinct type of data structures here: list, queue, and set. List is nothing but you could say it's a ordered one, right? It maintains the insertion order, right? the order in which you inserted data into the list. Queue is nothing but first in, first out, and whatever you push in first would come out first. And set is nothing but it's a set in mathematical form, right? Wherein you have unique values. You cannot have duplicate values. So that's what set is, but it need not be ordered. It need not maintain the insertion order, right? So you have the concrete implementations for list are array list, which is nothing but again similar to array that we have, right? The normal primitive array that we use. So it's a wrapper class for it. We have a linked list, all right? So this linked list is nothing but doubly linked list, all right? So you could insert from, you could traverse the either direction. You have vector as well, which is legacy form, which is not used to that extent yet as of now. So we have vector, and we have a stack which extends this vector. All right, stack is nothing but last in, first out, and it adds some more capability on the top of this vector, which is nothing but it's a subclass of vector. All right, so these are concrete implementations of list. We have a queue, and as you could see here, there's one interface here, DQ, which is nothing but it is extending queue. All right, and we have a array DQ, which is implementation of DQ. All right, it's a class which is implementing DQ interface. All right, there's a priority queue as well, which is a class which is implementing queue. When it comes to set, we have a sorted set, which is again an interface which is extending set. And as you could see, there's a tree set, which is a concrete implementation of sorted set, and it sorts the element that you put into a set. It sorts it into a specific order. All right. Again, the concrete implementation of set interface are hash set, which is nothing but which does some kind of hashing, which is a default implementation of set and which doesn't maintain insertion order. Hash set is nothing but it is indexed to for fast traversal, or if you want to get something out of a set, it's kind of an indexed set, you could say, right? It has buckets and everything. It follows hashing algorithm, right? Which is basically for indexing, or which is basically meant for retrieving data faster from the hash set, from the set. And that implementation, that's a default implementation, which is hash set. All right, there's a linked hash set which maintains the insertion order. All right, this hash set doesn't maintain the insertion order. So if you put x and y into your hash set, and if you retrieve it, or if you traverse through it and print the values, it's not mandatory that you would get x and y in the same order. Whereas in the linked hash set, it's pretty much you could be 100% sure that x would come before y. All right, so it maintains the insertion order. What is list? List is nothing but an ordered collection of elements which can contain duplicates. Unlike set, it can contain duplicates, but it has ordered, and unlike set, it is ordered, right? Lists are further classified into following: array list, linked list, and vectors. All right. So based on the use case, you could select one of these data structures. Let's talk about array list. Array list is nothing but similar to arrays that we had. And here you could see elements stored within of size 5, array list of size 5, and you could see values stored within. All right. So this is how you instantiate an array list. Array list object is equal to new array list, and you have an array list created. One of the main things about array list is, as I said, it's self-growable or it's dynamic. You, unlike array, the normal primitive array, wherein you had to, within your square brackets, you had to mention the size of the array during the declaration itself. Whereas in array list, you need not have to mention this size. All right, it grows by itself. As in when you insert data into it, it would grow. So basically, you could imagine in general scenarios, or in most of the programming cases, or in most of the real use cases, you don't know upfront what is the size of data that a particular array is going to hold, right? Or the number of elements that a particular array is going to hold. You cannot know it upfront because things are dynamic, right? So suppose you are reading from the database, you don't know what that size of the data, or what are the number of elements that a particular database is going to have. So typically, you could imagine real cases, you would go with array list and not primitive arrays. All right. So also you could imagine this is saving us in terms of memory, because we are not hard coding the values of it. So by default, it starts with 10, size of 10, and then it keeps growing as and when you insert it. So again, it has a logic. It doesn't keep growing for each and every insertions that you do, but it has a logic within to grow it by a particular size. So which is all optimized, which is good uh, for your cases, use cases. So these are the methods that we have within ArrayList. It's pretty straightforward. When you do add, it happens the specific, it's usually add and not collection. For collection, you have add all methods. So it's a typo here. You have add and you mention an element that you want to insert into a list. If it's a string, you would have string element, or if it's something else, if it's an integer, you would have integer element. You could add it to a particular index. You could clear it, removes all the elements from the list. You could have last index of, okay, return the index of this list of the last occurrence of the mentioned object. So if you have multiple, as we said, there could be duplicate values within, but when you give last index of, it's giving you the last index. All right, last index of the object that's been passed. You could clone it. So it's basically coming, clone is nothing but a method that's there within your object class, and it would shallow copy the array list. So whatever list you have, there would be a clone of it, right? So clone is, as we could see, it's from the object class. So any class that you create could be cloned. All right, then you have two array. So you could have an array list, and if you want to convert it into a primitive array and use it in some form, you could do that thing as well by doing two array. You could trim to size. So trim to size is nothing but trims the capacity of this array list instance to the list's current size. All right, so whatever is the size, it would trim to that. So moving on, let us understand how we can traverse through a list of collection. So traversal is done through iterator interface. Okay, so basically you have an iterator interface, and that's how you traverse it. Basically you have implementations of it. Since it's an interface, it is just a specification. You would have an implementation of it. So iterator is an interface that iterates the elements. It is used to traverse the collection, access the data element, and remove the data elements of the collection. All right, it's used for traversal as well as removal of data elements within the collection. Okay, so what are the methods that we have within iterator? First is has next. So it's nothing but, as you could imagine, it is returning boolean. So if it has a next element, it would return you true. Okay, and if it doesn't, then if the array list is already exhausted, then it would give you false. So you would basically you would have a loop wherein you would see if it has a next, right? And if it has next, you could access the next element using next method. All right, so next would return the actual object. And to remove it, you could do iterator.remove, which removes the last element written by the iterator. All right, so here you could see how iterator is being used. You declare an array list, and you iterate through it, and you print the elements. So quickly we can take this. So basically I do com dot edureka dot, I create one more package now for array list. Okay, I say collections demo dot array list. All right, so I have this particular class created. Now I create a main method, and I create private void. I write a method which is create array list for demo. All right. As you could imagine, when I say create, it's going to return array list. All right. We want it to return list. Okay. What I do here is I would create list, and this list is going to be list of string. Okay. Imagine generics that we spoke about. You're saying that it is going to be list of string. Now it's throwing me error saying which list I want. It's going to be java.util. So you could see java.util.list here. Now I say it's strings.new array list. You're saying that here what we are doing is we are instantiating. So we have a list of strings and we are instantiating it. since we want array list, it's going to be array list. So here you could see array list being imported as well. All right. Now what we are going to do here is we are going to add some values to it. Strings.add, or maybe I'll put, again, since we have been talking about cars and bikes, I'll cars, right? So we are creating here cars, list of car. All right. So I put BMW. I would put, all right, so all German cars, and then we return it. We are returning this. So we are creating a collection, right? And we are inserting data into it and we are returning it. All right, so this would create a list for me. All right, now I want to iterate this list. Okay, so I create a private method which would return void and which would print array list for demo. All right, so as you could imagine, this is going to take a list as parameter. All right, list to be printed, or it's pretty much implicit or implied that list is whatever list you pass as a parameter is going to be taken for printing. Okay, so here what I would do is list dot iterator. I take the iterator. Okay, so I get the list iterator. I say iterator, and I would say list iterator. All right, so I take this list iterator and I say list while it has any elements within. So how do we check with whether it has elements within is nothing but dot has next, if you remember. While it has any elements within, what we are going to do is we are going to print the value in the list. All right, we are going to print it using iterator dot next. Okay, so I've created two methods. One is create array list for demo and the other one is print array list for demo. Create array list is doing nothing but it's creating a list and it is returning the list. And print array demo is printing the list that you have passed as a parameter. Okay, so I create a new element of array list demo dot create array list. All right, and whatever array list that I get, or whatever list that I get, I would be putting it here. All right, now I create one more this and I print it. All right, now when I print it, I'm going to pass this returned array list. All right, I think it's pretty clear now. So we have created array list in this method and we have returned it. And in the second case, we are just going to print it. We are going to take any array list and we are going to print it. All right, so let's see. So rest of the collections, most of the collections, you do it pretty much similarly. It's just that, it's used for different use cases. All right, I am getting some error, I think. Okay, yeah, you could see here it has printed BMW, Mercedes, and Audi, which we had put into the array list. All right, so that's how you kind of iterate through it. Similarly, you could just remove it. You could use list iterator dot remove will remove the current element that's been iterated. All right, so yeah, basically I don't need to actually create one dot remove. You could remove it. All right, so that's how you remove it if you want to. So you have the same syntax. So basically we don't use iterators nowadays more. It's more about we have Java 8, there are different constructs, like we have lambda expressions and stuff, we have stream processing. Basis is you have iterators. All right, so this is what we have. We have an iterator which is iterating through all the elements, right? And you could remove it as well using the iterator. Usually nowadays we use Java 8 streams, which helps us to iterate through, which is pretty much like the underneath is iterator and stuff, but there are some kind of abstractions done so that we don't actually deal with iterators. There's some kind of abstractions, or it's less verbose. In this case, you have to write a lot of code to print through and everything. Whereas in streams, it would be just one method call, which would do a lot of things, right? So that's what is being used as of now, but this should be good enough to start off with to understand the basics of it. All right. Other thing is I was talking about the best practices. So it's good to have things broken down in methods so that could reuse it rather than putting everything into the main method, which makes it difficult for any other developers to understand more. So basically, it's a good practice to make it modular, right? And which enables reusability as well, which reduces the lines of code within your program. So tomorrow, if I have some other list which I want to iterate, I can just pass the list to this and it would iterate and give me the result. So I don't have to write the same piece of code again. All right, so moving on. So we have an array list. Array list is nothing but an abstraction done on a primitive array. So what are the advantages of using array list? It's more about it's faster in terms of retrieval, right? Index based retrieval. So suppose if you want to get to the index 2, just write like array list dot get 2 and it would give you the one at the index 2 or the element at the index 2. Whereas when it comes to insertions and deletions, if you want to insert a particular object at index 2, what it has to do is it has to move that was there at the index 2 to the index 3, and it has to increment the entire array by one or move to the right by one position, which is pretty cumbersome, right? Which takes a lot of time. So insertions and deletions are not good when it comes to array list, whereas when it comes to retrieval, it's faster. So based on the use case, you have to decide which data structure you should go for, right? So simply put, if you think of big data applications, it's mostly about you don't have insertions and deletions as such. It's not transaction, right? A typical online transaction processing, this thing would be application, or say for example you have Amazon, right? Amazon or something wherein you have a lot of transactions happening which needs insertions and deletions, right? In that case, array list is not a good option. Whereas in terms of big data, which is like analytics, right? Online analytic processing, which doesn't have transactions as such, right? It doesn't have insertions and deletions. It is one time load. You have data, you load it into your data structures and you do some kind of processing or you do some kind of analytics on this data, but you don't manipulate this data. You don't actually have insertions or deletions done. In such cases, it's better to go with array list. All right. So which is the variant which is good for insertions and deletions? That is linked list. All right. When it comes to insertions and deletions, and you want to maintain the order of the list, insertion order of the list, that's when you would go with linked list. All right. So linked list is a sequence of links which contain items. Each link contains connection to another link, and that's how insertions and deletions are simpler. You don't have to shift elements to the right when you insert it, or you don't have to shift elements to the left when you delete it. There are two types of linked list to store elements: singly linked list and doubly linked list. Singly linked list is nothing but it has pointers in one direction. Doubly linked list is like it has previous and the next. It stores both. Each node would store previous element, pointer to the previous element, and the next element. So yeah, this is a singly linked list wherein you see that it has pointer to the next. It doesn't have pointer to the previous one, right? It's a one directional traversal, right? Whereas in doubly linked list, you could see that it is looping back to the previous element as well. So it has a pointer to the next and it has pointer to the previous one. It's a bidirectional traversal. So linked list has pretty much similar to array list. You have add. You could add a particular object. You could check whether a particular object is contained within the linked list, and that object has to be passed as a parameter to contains. You could add a certain element at a particular index. You could add it to the head of the list. You could add it to the last. You could check the size of the list. You can remove the element from the list, and you could get the index of a particular element. So you could pass some element and get the index of it. Since linked list is again, it can have duplicate elements. If you want to get the last index of a particular element, you could do that thing as well. So if you have multiple elements, you would get the last one, right? The index of the last one. So linked list example here, you could see that a linked list of string is being created and you add values to it. Rachit, Rajul, Rahul, and Rajat. You add things to it, and yeah, this is just about adding elements to the list. All right. So array list versus linked list. Array list internally uses dynamic array to store the elements. Since I said it's growable, it grows on its own. Linked list internally uses doubly linked list to store the elements. To add an element in between or to remove an element from the array list is slow because it internally uses array. If any element is removed from the array list, then the rest of the element should be shifted to the left. All right. Similarly, when you add something to the list, you have to move everything to the right. Adding an element in between or removing an element with linked list is faster than array list because it uses doubly linked list. So no element shifting is required, right? You don't have to shift any addresses or something. It's just about moving the pointers, right? So you would just move it, skip one element and move to the next in terms of deletion. Whereas in terms of insertion, you would insert a node and you would manipulate the pointers accordingly. All right. Array list can act as a list only. It is normally for list, but linked list could be thought of as a list as well as queue, right? Since it's a doubly linked list, you could have like first in, first out. Array list is better for storing and accessing data. All right. So as I said, this is pretty much good enough for analytical sort of application, analytical nature of application. Whereas when it comes to transactional, linked list would be better. So linked list is better for manipulating data and it is slow in searching an element because it needs to compare the elements from the first node. When it comes to, index based search, it is slower because it has to start all the way from the start because it goes through links, right? It has links linked to next element and that's how it traverses through. Vectors are similar to arrays, but it's a legacy form of it. It's a dynamic array again, similar to array list. All right. It could be visualized very much similar to array list, but just that it's a legacy of Java. It's not used to that extent, or I would say it's not used at all at this point. But what is important to note is vector is synchronized when it comes to multi-threading. It's better to go with vector, but nowadays we have concurrent array list that is supporting concurrency, right? So there are a lot of optimized versions of it, which gives a lot of performance improvement. So vectors are no more used as such in industry. It's a legacy form of array list. There are concurrent versions of array list that has been evolved, which could be used in multi-threaded applications. All right. Vectors contain many legacy methods that are not part of collections framework. So it doesn't even fit into collection framework because it contains some legacy methods which are no longer used or which are not part of collection framework at all. Now vector is again taken into collection framework and it implements list, and that's the reason it has the implementation for these methods, because these methods are typically coming from collection and list, collection interface and list interface, and all the concrete implementations have to implement it. And since vector is one of the concrete implementations of list, they have to ensure that they implement these methods as well. All right, so these are the methods pretty much similar to what we spoke earlier: add, clear, and add to a particular index, remove, and then you could have size, then you could have last index of and last index of object. So it's a vector of string, then you add element, you add Umesh, Irfan, and Kumar, and you just iterate through it to print out the message. Umesh, Irfan, and Kumar would be the output of this application or this program. All right, so you could see iterators used here as well, like we did it in list. So let's talk about queue. Queue is nothing but first in, first out. Whatever goes in first would be first to come out. A priority queue allows you to initialize a queue. These are implementations of queue. So you have a priority queue. You have, as we said, linked list is list as well as queue. So you could have linked list assigned to a queue, right? Linked list is a list and linked list is a queue, right? Is a relationship, which means it's extending it, right? So here we can see double-ended queue lets you to add or and remove. So double-ended interface DQ interface allows you to add and remove elements from peak as well as from the bottom. That's what DQ is, double-ended queue, right? And array DQ is nothing but the concrete implementation of DQ. DQ is an interface and the concrete implementation is array DQ. So what are the queue and DQ methods? You have add method, which is nothing but it adds to the top of the queue. and it returns boolean, as you could see here. If it is successful, if it has added to the top of the queue, it would give you true, and if not, then it would give you false. All right, you have offer, which inserts the specified element into the queue. Again, it does the similar stuff, it inserts to the queue. All right, you have remove, which removes the head of the queue. We have poll, which retrieves and removes the head of the queue. Again, it does the same thing, retrieves and removes the head of the queue and returns null if the queue is empty. All right, polling is nothing but getting the top of the queue. And you have element, which retrieves but does not remove. All right, so when you do queue.element, it would give you the top of the queue or the head of the queue, but it would just give you, but it would still be there. So if you want to check value that is on the top of the queue, if you want to check it and do something with it based on the value that is there on the top of the list or top of the queue, if you want to perform some actions, you can do it using element. Peek again does the same thing, it retrieves but it does not remove the head of the queue. If you want to actually retrieve and remove the head of the queue, you would either use remove or poll. Basically you would use poll, not remove, right? Remove is not a good operation to do when you want to retrieve and do some actions on it. The best practice would be to use peek to retrieve and use poll to actually retrieve and remove. All right, so let's take an example of queue. So right here in the package, I create a main method, right? So I create private queue, create queue for demo. All right, so it's asking me which queue. I'll go with this one, which is java.util.queue. All right, now I'm creating a new priority queue, which is a concrete implementation, which would be, say, for example, of integer, right? So I create queue of integers. So we are putting integers within, all right? And what we are doing is new, I am instantiating it, all right? So this is a queue which is going to hold just integers. That's where generics come into picture, right? Queue of integers dot add, suppose I put 100, and then I put add is used to, as I said, to insert, right? And I put 50. So I've created a queue and I return this queue. So I've created a queue so far. Let me print this queue. All right, so we have, which is going to return void and print queue for demo, and which is going to take queue. All right, queue of, say, I'll not even put it here. So now let's see how we can retrieve elements from it. One way is to iterate through it, and let's see how poll and other things work, right? So let me get the head of the list. So this is just retrieving it, right? Retrieving head of the list. We are not removing it. It is still there in the queue. We are just trying to check what it is. So when I say when it's retrieving, it's peak. All right. Now, if I want to remove it, if I want to kind of retrieve and remove it. So basically what I'm trying to say here is when you have queue.peak, it's going to return the top of the list, which is nothing but 50. All right, so the first one, the peak is just retrieving it, whereas when I poll it, it's going to retrieve and remove as well. So I have queue dot poll is going to, now when I do s out, retrieve and remove, say this is the first attempt, all right, and we again do it, which is the second attempt. This is just to show you that when you poll it, it's actually removing it as well, whereas peak is not removing it. All right. So peak is just retrieving it and this one is removing it. So the first poll is going to give you 50, whereas the second poll is not going to give you 50. It's going to give you 200 because it has removed 50 from the queue. All right. So this is what I wanted to show. So let me queue demo. All right, so here I'm going to do demo dot. So when it comes to generic, we can make this a generic queue program by doing something of this, and instead of hard coding it, you could put as T here. Right now, let's keep it as is. All right, so in the first case, queue is being created. The second case, we are going to see how peek and poll works. Retrieving is just retrieving it, and it is still keeping that element at the top of the queue, whereas polling is actually removing it as well. All right, so you could see here, peek is giving you the last one here. It's a double-ended one, so it's giving you the last one here, and poll is giving you this one. It's based on priority, I think. All right, so you can see poll is giving you 50 as well, and when you poll it again, it's giving you 100. All right, let's move on to the double-ended queue. All right, so here we have something like you could remove first. All right, so it's a double-ended queue. You could interact in both the directions. You could actually remove first and add to the last and stuff like that. So you could see here that there's a double-ended queue created with 4 elements initially, 21, 42, 63, and 84. And you could see that remove first is removing 42, 21 rather from here, since 21 is the first one. So it's removing 21, and remove last or add last, it's adding to the last, which is nothing but it's adding 105 to the last. So what is set? Set is nothing but, as we said, it's a representation of mathematical set, which is unique, which holds unique values, right? You cannot have duplicate values within set. Set has its implementation in various classes such as hash set, preset, and linked hash set. So it's a mathematical set abstraction. We have variants of set in Java, which is hash set, linked hash set, and tree set. Hash set is nothing but it hashes it, or basically there's this indexing done. And it's good for retrieval, as you could imagine, since it's indexed, it's good for retrieval. Okay. So the analogy behind this could be, or it is analogous to index page that you have in books, right? You have index page, you just go to the index page and see at what page is the content that you are looking out for. This one is pretty much similar to that. So when you do hashing, you would be able to retrieve it much faster than sequential retrieval. All right, so that's what hash set does, and it has unique values, of course, which is a property of a set. You can't have multiple values within or duplicate values within. It doesn't sort automatically. This is a typo here. Hash set doesn't maintain any order at all. It's internal to the order in which the retrieval would be done is pretty much internal to the runtime. Or what I mean to say is, if you have a hash set with the same content and if you run it multiple times, you would see that the retrieval is different in different instances. So it doesn't maintain any order. Your application might demand something or demand a data structure that is set, as well as it maintains the insertion order, right? That's a scenario in which you would go with linked hash set. So linked hash set is nothing but set which has its insertion order maintained. All right. So the third one is tree set, which is nothing but it. So these are the methods that gets inherited into hash set, and not similar to other collections that we have, but just to talk about this one. So you have add, which is just adding object into hash set or linked hash set. You have contains, which is basically checking whether a particular object is present in a set. You can clear the contents of the set. You can check whether a set is empty using isEmpty method. You can remove a particular object from a set using remove method and pass the object that you want to remove. Clone is nothing but a method that is inherited from object class, which is superclass, and it is basically meant for cloning any data structure or any class or any instance of a class. All right. So when I say cloning, it's not but making a copy of it, and it's a shallow copy. There's a deep copy and there's a shallow copy. Shallow copy is nothing but the properties within the set, so the references remain the same. Basically, you would have a value, say for example string, right? If you have a value, say edureka, you would basically have both the set pointing to the same instance of edureka. All right, so it's a shallow copy, and deep copy is wherein you would have different instances altogether. So when a change is made in new set for a particular element, it won't be reflected in the other set. So that's deep copy. But by default, it's a shallow copy that's done. If you want to deep copy it, then you'll have to use some other utility or use some other class. All right. There's an iterator similar to other collection. You can have iterator to iterate through the set. And if you want to check the size of the set, you could use the size method. All right. So let's see an example of hash set and linked hash set. All right, so here I've created two methods: create hash set, which creates the instance of hash set and adds some integer values to it, which is 130, 340, and 440. And you see there's one more method created, which is create linked hash set, which is again inserting three elements into it, which is 100, 300, and 500. So I return this. All right, now I write a method to iterate through it, which is displaying nothing, and print set, and which would set s. All right, what you do is you have like set to print dot, you could have iterator, right, which would give you a iterator, which would give you an instance of iterator for set. All right, so we have iterator created for set. Now let's iterate through it. So remember how we iterated list. So you would say set iterator dot has next. If it has next, then print the value of. So basically we have this, then you have set iterator dot next, which would give you the actual value. All right, so we have a method which would iterate through the set and display its content. All right, now what I do is I create instance of set demo. I create hash set, and whatever value I get, I put it as hash set for demo, or I keep it as set. All right. Now I have again set. I say linked hash set for demo. So basically we just creating the set. All right. Then we create the linked hash set. Now set demo, we are going to print it. The first one to be printed is hash set for demo. And this is what is reusability, right? See, I'm not writing the method to print it multiple times. It's just once, and which could be used for printing hash set as well as linked hash set. So this is what reusability is all about. If you don't expose it as a method, and if you write it within your main method, you won't be able to reuse it, and you would have to write the same piece of code multiple times, which adds to the redundancy and which is not a good practice. And this also makes it much more readable. By looking at it, you can understand that, okay, it's creating a hash set, the second method is creating a linked hash set, and the third one is printing a set. So it makes much more readable, right? So that's an important factor as well when it comes to programming. All right, so here we can see that when I printed the hash set, it gave me 133, 44, 40. Now the thing is, it's just three elements, so it has maintained the insertion order. But basically, if I have more elements, I'll just copy this multiple. Oh, okay, I remove this. Okay, now you can see that you won't get it in an insertion order since it was just three elements. It's by fluke that you got it in the same order as which you inserted. So if you see it now, so now you can see that, the first element that got retrieved is 4401, which was basically you put it at the last, right? So it's pretty much random. As I said, linked hash set, the retrieval would be pretty much random. You could see 4401, then 130, which was the first element inserted, then 340, then 440, then you saw 40, which is again out of order. So basically, this is what linked hash set does. And suppose I put the same values in the linked hash set, you would see that insertion order is maintained. All right, so from here, if you see from 130, I think from here it's printing linked hash set. and you could see the insertion order being maintained as is 44, 10. And when you see hash set, which is pretty much like this one, you can see that it's random. All right, so that's what linked hash set and hash set differs on. Tree set is nothing but it's a sorted set, and you have a retain all method. Retain all method is nothing but intersection between two sets. So basically you could pass one more set to the retain all method and you would get an intersection of two sets. So what I mean to say is if your set has value 1, 2, 1, 2, 3, 4, and you pass one more set to it, or you invoke retain all method and pass one more set to it which has values 1 and 2. All right, so your source set on which retain all method is being called, that has got 4 elements, 1, 2, 3, and 4, whereas the set that is passed to retain all contains only 2 elements, that is 1 and 2. All right, now when you invoke it, your source will have only 1 and 2. Your 3 and 4 would be removed off from the source set, because the retain all method is nothing but it's an intersection between two sets. Okay, so size and hash code, so all these methods remain the same as other ones that you have in different collections, right? So you have like size, which would give you size. Hash code is nothing but a unique integer that's written for any object in Java. It's not just preset. Any object in Java, when you invoke hash code, it would give unique integer. All right, because this particular method is inherited from object class of Java. Contains is nothing but pretty much similar. You pass an element and check whether that element is contained in the source set. Contains all is something like retain all. It would return true only if all the elements in the collection that's passed here as an argument is present in the source set. All right, it has to have everything, all the elements. So in the previous case wherein I said the source has 1, 2, 3, and 4, and if you do collect contains all on a set, or you pass a set to contains all with values 1 and 2, it would return true. Whereas if you pass a collection with values 5 and 6, it would say false because you don't have values 5 and 6 in your source collection. All right, iterator is nothing but it returns the iterator that we checked on. You can convert it to two array. Any collection could be converted to two array, which would give you object array. You could check equals, basically checks if the collection is, I think it has to be empty here. It checks whether your collection is empty. So there's a typo here. Just to give you an example, I'll create one more. So I copied the same method and I said create tree hash set. All right. So what I do here is I'll make these changes. I'll keep it as, this could be kept as set, and this is like tree. All right. So tree set, and we are set. Now I print this one. Okay. Basically set demo dot create tree hash set. All right, so I'm printing this. So prior to that, maybe I'll put a statement here, printing tree set. All right, so I created a tree set with this random values 130, 340, 440 and stuff like that. Now let's check whether it has sorted it or not, right? So I created a tree set and I'm just printing it here. So what you can see here, we have created tree set. Now, if you see it right after printing tree set, all the values that you see here, 10, 30, 40, 44, 130, 440, it's all sorted if you see, right? And it's unique as well. So if you insert it multiple times, like if you insert 10 multiple times, still it would take just one value of 10, all right? So you cannot have multiple values. If you put 10, unlike array list or linked list, which will have multiple values, this would take just one 10. All right, it would ignore the other one. Enum set is a special type of set which creates, enum is nothing but a constant. It's a replacement for constant in Java. So basically it's a replacement for public static final, and basically for constant earlier it was like we used to use public static final, but now it's advisable to use enums for constants. All right. We'll see an example which would give you much more clear idea about it. So first one is all of. All of method is nothing but creates an enum set containing all of the elements in the specified element type. So it would create a enum set with all of the elements that you have. Copy of is nothing but creates an enum set initialized from the specified collection. All right, so you could pass a collection and it would create a enum set out of it. None of is creates a empty enum set with the specified element type. This creates a enum set initially containing the specified element. Okay, you could initialize it as well. So basically here we are giving a specific class with which it would be created, or the enum set would be created. Range creates a enum set initially containing the specified elements, right? And clone is nothing but, again, it's pretty much similar. As I said, clone is a method that is inherited from object class and is meant to clone or have a shallow copy of the data structure against which it is invoked, or object against which the clone method is invoked. All right, so here we can see there's a enum which is months. All right, so here you could see a enum months which has like 3 months declared within Jan, Feb, and March. All right, so now what you do is enum set off, and you just create set out of two of these elements, which is Feb and March. All right, so this is what enum off is. So you could have some enum values put in and it would create set out of it. Now when you iterate through it, you would see that you have Feb and March into your enum set. All right, so this is something that is required when you have enums with multiple constants, and if you want to have, or you want to create set out of it and do something with it, right? So it would be pretty much common, or you imagine of enums as an exhaustive list of constants, right, which is used throughout your application. Now there might be instances wherein you want to put them into set and do something with it, right? So basically this is meant because the values within your enum cannot be put into a data structure as of now, or prior to enum set we were not able to put the values within the enums into a data structure, right? It was considered as a separate entity. So now this is introduced so that you could put it into a data structure as an object and you could play around with it. So that's the reason we have enum set. What is map? Map is nothing but it's a key value pair and it is unique keys. It holds unique keys. So suppose if you try to insert same key with different value, you would have your value updated or overwritten with the new value. All right. So, but it won't duplicate it. So what I mean to say is it maintains a key value pair, but the key is going to be unique across. All right. So this could be imagined as a table, right? You have a table in data structure which has got one primary key, say employee ID, and there's a name which is like name of the employee, right? Imagine this ID is a primary key, right? So you cannot have multiple values. So if you try to put one more value to it, it won't allow you to put in. The only thing that you could do is update the value of existing IDs or add a new ID. So this is pretty much similar to that, right? Map is specifically for maintaining key value pair and wherein keys would be unique. And if you try to map an existing key with a new value, you would see that the value is being overwritten, but you won't have duplicate keys. All right. Again, there are different variants that we would look at. Map has hash map, which is similar to hash set, which is based on indexing or hashing. All right, you have linked hash map, which is pretty much similar. Again, hash map doesn't maintain the sequence of insertions. Linked hash map maintains the sequence of insertions. There's a sorted map, which is again tree map and which is sorted on based on keys. All right, so the structure that you see here is pretty much similar to set, right? We had hash set, we had linked hash set, and we had tree set. So this one is pretty much on the same lines as set. So how do you put data into your hash map? It's with put method, right? You have put method and you put some key and value. All right. We have put all. We can have an existing map, and if you want to put all the key value pairs that's there into a map, into a new map, you could use put all. Or you could remove some key, you could get some key. All right. you could check whether a particular key is contained within hash map. You could get your key, all the keys in the hash map as a set, which is key set. Just give you extract all the keys as set, and as they are unique already, then you would get a new set returned out from key set. Entry set returns the set view containing all keys and values. So basically you would get all the keys and values as a set. When it comes to entry set, from the entry set you could get key and value distinctly. All right, so get key is nothing but obtain a key. Get value would give you a value against the key. Now, what are the typical exceptions that you get when you deal with map? Some exceptions thrown while using map interface is no such element exception. So when you're trying to invoke some item from the map, if you're trying to invoke a key that doesn't exist, this is what you would get. Okay, this is more about when there are no items, if there's no item that exists in the map at all. If it's an empty one and if you're trying to retrieve something, that's when you would get no such element exception. All right, class cast exception is pretty much, it's a generic exception that you get when you try to cast it against an object, or suppose value is a string, all right, and if you try to cast it to integer, you would get a class cast exception since string cannot be mapped into integer. All right. Null pointer exception is the runtime exception, which we saw that if you haven't initialized your hash map and if you try to put something into it, you would get null pointer exception. So you have to make sure that you instantiate the map first and then start using it. Unsupported operation exception. This occurs when an attempt is made to change a map which is unmodifiable. So you can get an unmodifiable version of a map, and if you try to change something within it, this is what you are going to get, unsupported operation. Hash map, linked hash map, and tree map. So this is pretty much similar to the examples that we saw for the set, right? Java hash map class implements the map interface by using hash tables. It inherits abstract map and implements map interface. It contains only unique elements. Hash map contains values based on the key. It may have multiple null values, but only one null key. So this is important to note. You can have multiple null values, but only one null key. You can't have multiple null keys. So null is also treated as a key, as a valid key when it comes to hash map. Right? Whereas in hash table, there's one more variant of key value pair, which is hash table, which would throw you an error if you have key as null. But hash map takes key as null. So that's an advantage of it. So hash map doesn't maintain the order of the element. Linked hash map maintains the order of the elements in which they were entered. And tree map sorts based on the key. So these are pretty much the same thing that we discussed for map earlier. If you see entry set, key set, and all those things, we have already discussed about, and it's the same one. This is something that we have in specific to tree map. You could get first key, you could get last key. All right, since it is sorted, you could get it. Now there's a hash map example. I create a main method first. Then I create private map and then create hash map. And I create a new map here, say map of integer string. Typically you would have integer as your ID, right? Say employee map, all right? And which would be new. Suppose I create a new hash map. All right, so I'm creating a new map here, which is like the key would be integer, your value would be string. Dot put is a method that we use, and say employee map dot put. All right, so this is how you put into map. All right, so I've written this map from here. So we'll take an example of hash map wherein we would be putting some ID and we would be putting some value as a string, and we would check how it gets iterated or how we can iterate through or get something out of the set, out of the map. Okay, so here you can see that I created a hash map. I created this method, which is create hash map, and I put some value within, which is nothing but, and you could see here, it's a map of integer and string. So I put a value of 1 and I put value as X. I put 2 and value as Y, and I put 100 and value as A, right? So I created a map of employee ID and employee name, so to say, right? Okay, so I've created this. And so what we are going to do here is, so you could even print out a map directly if you want. If I print it out like this, like map to print, you would see all the values contained within the map. All right, so this is, all right, I print the hash map right here. So basically I created demo dot create hash map. Okay, demo dot print map, and let's print this map here. All right, so we have inserted 3 entries into this map, 1, 2, and 100 with ID 1, 2, and 100, and which has got value of X, Y, and A respectively. And what we are doing is we are just printing the map, contents of the map right here. So you could see here there's 1, 2, and 100 been printed out here. All right. So again, this is a hash map, and you could have, it's based on hashing, so it doesn't maintain any order. So if you have multiple values within, you would see that the order is not maintained, similar to what we had in hash map. So if I put something like this, all right, now when I run it, you would see that insertion order is not being maintained, and when you retrieve it, you will get it in any order. All right, here we can see that the order is not been maintained. 112 is displayed first, which is second last actually. All right, so it gives you all the entries within the map, but it won't maintain the insertion order. So that's, if you want to maintain the insertion order, you have used linked hash map. All right, if I change this to linked map, linked hash map, so just one single change would, so I copy the same stuff here. All right, and I put a linked hash map. All right, and suppose I create one more, which is for tree map. All right, so we have created 3 maps here. One is your tree map. So the other one is linked hash map. Linked hash map. Now let's print one by one. Right, the first one is hash map that's already been printed here. Now I create linked hash map. All right, and the third one that I print is demo dot create tree map. All right, so we have all the 3 maps created, and we are printing it here. All right, so here you could see that when it comes to hash map, the key value pair is not maintained, right? Whereas when it comes to linked hash map, this is a linked hash map, and you could see that the order is exactly the same as the order in which we put in. All right. And when it comes to tree map, which is the third one, and here you can see that it's sorted one. So sorted by your key, not the value. All right, so see the key to the left hand side. When it says 1 equal to X, 1 is the key and X is the value. If you see it, you will see that 1, 2, 11, 21, 100, 111, 112, 1010, and 1100. So you could see that it's been sorted per the key. All right, so there's enum map. Enum map is a specialized map implementation for enum keys, all right, which we saw. Here we can see that there's a enum, which is nothing but constants, and you could see 3 constants being put into the months, which is Jan, Feb, and March. And you could see there's a enum map created for all the months, or for all the months that you have within your enum, that is months. All right, you have this enum map, and you could actually put in values something like this. So basically enum map is nothing but you could use the enums or the values within the enums as your keys, all right, when you use enum maps. And you could just iterate through it to see that you have these keys put in and values put in properly. All right, so just to give you an example, we can create a enum here. I'll choose to create the same one, and I create enum here, right? So I create enum month, and which has got, say, for example, Jan, Feb, March. All right, so we have created this. Now what I do is I create a new enum map with months and with string as its value. So I create a main enum map with month, and maybe we could put integer as. I create this enum map here. All right, enum map of you have month and integer. All right, so here we will have to give month dot, or even months is okay. Takes class, so month dot class. All right, so in the constructor we could see that it takes class as a parameter, so we put month dot class as a parameter. Now I put map dot put, I put like the key is here, it is depicting something like sales done per month. All right, it basically it refrains you from putting anything but the enum value as your key. All right, so that's what we are trying to do here. And you could just print enum map calendar and you should be able to see the values. All right, so it's basically restricting the key as one of the values or one of the constants declared within your enum. So yeah, you can see here Jan is equal to 100, Feb is equal to 200. You could. Now I'll quickly talk about comparable and comparator. Comparable and comparator are the two interfaces, or it's used when you want to have sorted set, or if you want to sort a collection. Say for example, you have list of integer and you want to sort it. A list of integer is something that is by default could be done because integer itself implements comparator. But if you have a self-defined class, or if you have your own class, say for example, if you have your own defined class, something like this, vehicle info, which has like a number of wheels, mileage, and name of the vehicle put in. Now, if you want to sort this particular class, if you give it to a sorter, it won't understand because this is a self-defined class, right? It won't understand what you want to sort in this, right? Basically, when you have something of this sort, when you have your own defined class and you want to sort it, that's when you use comparable and comparator. All right, so I'll just walk you through it. So comparable interface is used to sort the objects of user defined class in an order. So to give you an example, suppose you have an employee class which has got ID and say salary, right? If you want to sort it by default, Java wouldn't know what you want to sort within that particular class, right? You want to sort it by the identifier or the ID field within the employee, or if that's the use case, then it could be like you want to understand the order in which employees joined the company. And the other case could you want to sort it by salary to understand which employee is taking the most salary, or to understand the sequence in which salary is being paid to the employees, right? So to make Java understand which use case you are trying to solve based on which identifier or based on which property or instance variable within your class you want to sort, to just indicate Java that this is what we want to do, express it in the form of implementing comparable interface. It is in java.lang package and it contains only one method, that is compare to. It provides single sorting sequence only, that is you can sort the elements based on one data only. You can't have multiple data, can't sort based on multiple data. All right. So I'll just walk you through this, which would give you an example. So basically you have a student which implements comparable. Now here you could relate to the example that I took, wherein you have roll number and name. Now you want to sort it. Now what we are trying to sort here is by roll number. So that's how you express using comparable, right? You have comparable student, right? And you could see here there's a compare to method that this comparable student has got, or the comparable interface has got. Now compare to will take student as a parameter. All right, now you could see that we are comparing roll number, right? You're comparing the roll number of the parameter student that's been passed to the compare to. If it is equal, then it's 0, right? You don't have to do anything. If it is greater, then you return as 1, and if it is less, then you return as -1. So basically, based on this compare to, Java will do sorting. All right, it will sort it based on whatever you provide here. So what you're trying to tell Java is, if it is equal, we are returning 0. So this is a contract. Okay, this is what we need to actually, this is how it's been coded, or this is a contract that you need to follow whenever you compare to. So if it's a roll number, then you say it's roll number 0 or return 0 if both the roll numbers match. If the one in your instance is greater than the one being passed here, then it would return 1 or else -1. All right, so how do we use this? So basically you can see here you created student. All right, so there were like 3 students created, 101, 103 and 102. You could see 3 IDs being created here. All right, now what you're doing here is collections.sort, and you are passing your array list of student, and you use collections.sort. All right, when you do collections.sort, what it would do is it would arrange it, or it would sort the array in the order of roll number. So 101 would be first, 102 would be second, and 103 would be the last. All right, so there's comparable and there's comparator. All right, there are two interfaces. Comparator is nothing but it is used to order the object of use. Again, it is used to order the object of user defined class. But what is different in comparable is comparable takes compare to, which takes just one parameter as input, and the other parameter is nothing but the instance within the class itself. All right, or this instance rather, the instance on which this particular method, or instance on which compare to method was called. All right, so basically comparable will have only one method, compare to. All right, whereas comparator, when you use comparator interface, it will take two methods, or it will take two parameters in the compare method. All right, and it will compare both the parameters that are passed. So basically it's for customized sorting. In the first example, that is comparable, we are putting the logic of comparing within the class itself, but you have a separate class which implements this particular comparison logic. So basically you could see here, right? You have a class student, and student is just holding the values of roll number, name. All right, you don't see how you don't see the comparison logic within. Now you have another class which is name comparator, which implements comparator. All right, there's name comparator which implements comparator. Now if you see the compare method, it takes two parameters. The earlier one, the compare to method in comparable, was taking just one parameter. Here it is taking two parameters, right? And what you could do is you could simply compare based on name, right? Since name is a string, you could do s1.name.compare to s2.name. This would compare based on name. There's another one. You could have one more class created, which is nothing but roll number comparator, which implements again comparator. Now here you would use the same logic that you defined earlier for roll number. All right, if s1 dot roll number is equal to s2 dot roll number, return 0. Else if s1 dot roll number is greater than s2 dot roll number, return 1. Or else if it is less, if s1 dot roll number is less than s2 dot roll number, return -1. So based on this logic, you would see that the compare, or you would see the sorting happening. Now, how do we use this? So we have defined a class, we have defined a model class. So model class is nothing but a class that has got just the state, right? Student, if you see, student doesn't have any behavior as such. It doesn't have any method within. It is just a state. So this is a model class, all right? So student is a model class which has got roll number and name. And we have two separate comparators defined here, name comparator, which is comparing the name, and we have a roll number comparator, which is comparing based on roll number. All right. Now, how do we use it? This is not sorting it yet, right? How do we use it? So how do you use it is nothing but you have collections dot sort. All right. This is pretty much similar to, if you see the other part of the program, this is just about putting the data into your class. All right. So you have 101, put in as Vijay 106, put in as Ajay 105, put in as J. All right. And now we are trying to sort this based on roll number as well as name. So both these can't happen in one go, by the way. All right. This is like first you can have something done on roll number, and so it's not in one go. All right. You could do it in stepwise manner. So as you could see here, how are we using this comparator is nothing but you have collections dot sort, and then comes the collection that you want to sort. In this case, it is AL2, all right? And then you provide the comparator. So here you are providing new name comparator, all right? So after this particular statement is called, you would see that the collection has been sorted based on name, all right? And the first one here, as you could see, collections.sort AL2, and here you are passing roll number comparator. In the first statement, or here the first collections.sort statement would sort based on roll number, whereas the lower one would sort based on name. All right, so this is basically offloading or just decoupling your comparison logic out of your class. That's when you would go with comparator, whereas you would go with comparable when you want to put the logic within the class itself. All right, so it depends on what use case you want to do, but as far as the performance is concerned, it's pretty much the same. All right, even if you use comparable or comparator, it's pretty much the same. It just depends on how you want to write. It's a programmer's wish. So few people prefer to have modular programming rather than coupling everything into one class. They would go with comparator, and few people like to add things to the class itself, which they would go with comparable. So what is comparator and comparable? Comparator provides single sorting sequence, that is, we can sort the collection on the basis of single statement such as ID or name. As we saw that you would have just one compare to method, and based on that you would have the sequencing done or the sorting done. Whereas comparator, you could have multiple logics. Since you could have multiple classes implementing this comparator, and you could write your own logic. Like in the previous example, we saw that we had a comparator based on roll number and we had a comparator based on name as well. Comparable affects the original class. Comparator does not affect the original class. So we saw the student class, right? The student class, within the student class itself, you defined the compare to method when you used comparable. Whereas when you used comparator, you wrote different classes. So that's about decoupling that I mentioned. Comparable provides compare to method to sort the elements, and comparator provides compare method to sort elements. All right. Comparable is found in java.lang package, and comparator is found in java.util package. We can sort the list of comparable type by collections.sort list, and we can sort list of elements of comparator type by collections.sort list, comma comparator method. All right. When I say list, it's a list of some type, right? So in the previous case, it was list of student, and since student class itself had the logic for comparison, we don't have to mention it explicitly. It's taken care of by itself. Whereas in this case, wherein you used comparator and you had different classes wherein you put the comparison logic, in that case, you have to explicitly give the comparator, right? Like we gave something for roll number, we instantiated roll number comparator and gave it for sorting by roll number, and we instantiated name comparator for sorting by name. All right, so that's how we sort user defined classes. So basically, why do we have comparable and comparator? Just to reiterate, but JVM or Java wouldn't know how to sort a user defined class, right? It could be based on roll number, it could be based on name, so it won't know by itself what you are trying to do. So that's how you, using this interfaces, you express your logic of comparison. So what is XML? So Henry handles the database of a college, but the data is stored in a form of XML file. He wants to extract information from this. Now he is learning XML so that he can handle it easily. So what is XML all about? It's an extensible markup language. It is designed to store and transport data. XML has hierarchical human readable format. XML is platform independent and language independent. why did XML come into picture at the first place? So it's basically you have different systems. Tomorrow you might develop some system or you might have some service that is exposed to the outside world. So what happens is there has to be some contract. You as a client or you as a service provider, first of all, would expose a contract saying that if you give input to my service in so and so format, I'll give you output in so and so format. So basically, when you want to send data from a client to the service, you would send it in a specific format that the client understands or the server understands. So the server exposes or the server expresses the input format in a XML form. And this is platform independent. This is like you might have a service tomorrow in created in .NET, which can use the same XML as used by Java program as well. So it's a platform independent thing. Basically, it's used for carrying data, as I said, store and transport of data, which we'll see in the coming slides. But you could imagine this as nothing but a file which is used to send data from your client to the server for communication. It's pretty much human readable. It's not like yesterday we saw about serializing the state of the object, which was not human readable. So this one is pretty much human readable. You could imagine like you would have a employee ID, or if you want to search something in the employee directory and there's a service which is exposed for that, you could imagine that you could send an ID to it or you could send an employee name to it, and format in which it is sent would be pretty much human readable. You could see that okay, there's an ID, there's a name which is sent to the server, and the server is doing so and so things. So it's hierarchical and it's pretty much human readable. Again, as I mentioned, it's platform independent and language independent. It's agnostic of all these technologies. So there are a lot of existing services which use XMLs as a part of input data and output data. So as we go through the examples, you should be clear to you guys about what XML is all about. Why we need XML? XML is an industry standard for delivering content on the internet. So it's a standard. So most of the services, most of data intercommunication that's happening within internet is done in the form of XML. They communicate with each other in the form of XML. XML is designed to store and transport data. XML is extensible because it provides a facility to define new tags. It's not that once you define it, it's all done. So it's extensible. It's extensibility feature wherein I can say today my server is accepting employee ID and employee name. Tomorrow my server want to accept employee salary as well. So you could add that to it, add tags to it, which makes it extensible. So it's not one time defined. You could change it. You could evolve the XMLs. XML is used to describe the content and structure of data in a document. So it has got its own schema, and you can say that my XML is going to contain just email ID and employee name, nothing else. And you could validate real XML or the actual XML that you have against this schema. And if you have some extra parameters put in, it would throw you an error. So that's about why you need XML. Let's talk about what are the features of XML. Why is it so widely used? Writing XML is pretty much easy. As I said, it's human readable and you could actually write it. And there's a lot of API or a lot of SDKs that are exposed for reading and writing with XMLs, and very optimized version of it. So you could see parsers, right? We had multiple parsers. It's for performance based on the needs of your particular application or the nature of your application. You would select one of the parsers. So writing XMLs is very easy. The other one is XML data can be extended with DTD and XSD. It's a schema description. As I said, you could extend it. It's not that it's one time defined. You could extend it. XML can work on any platform. It is platform agnostic. You could run it on any platform, either .NET, or it could be different languages or different platform. It could be different operating systems as well. I could run it on Linux tomorrow, or I could run it on .NET. Any tool can open XML file and can parse it in programming language. So a simple editor, even Notepad, you could open it in Notepad++ and just view through it. And there are different tools available in the market as well, which would give you kind of format your XMLs so that it's much more readable. So there are a lot of tools available already. XML separates data from HTML. It separates the actual data from HTML code. XML simplifies data sharing. So basically, as I said, it pretty much intercommunication standard between systems. You just have to put it into XML and you share it across systems. XML simplifies data transport. What is the difference between XML and HTML? So XML is used for storing data and data communication. So as I said, inter-system communication standard, and HTML is used for display. So whatever you see on the web is something that is, you have a HTML page, you have coded it in HTML format, and it's used for displaying it. XML uses user-defined tags. HTML has its own predefined tags. So when you define your XML, it's a user defined XML. As I said, today I might have a service which is taking employee ID and employee name, which is like user defined, which is not predefined. Whereas when you use HTML, HTML is nothing but it has to get parsed into, or it has to get passed into a page which is being visualized by clients. So that's why you have a predefined tags. You cannot have anything, you cannot put something of your own, or if you put your own tags, it would show up an error. So it's validated. Reason being, you have to compile it or you have to run through to show it as a view or to show it as a HTML page to the clients. There's an interpreter which has to understand what you're trying to do. So it's predefined tags. XML is case sensitive and HTML is case insensitive. In XML, it is mandatory to close all the tags. So you cannot keep any tags open. So we'll talk about the tags once you see the format of the XMLs. But basically, if you have every property or every data that you want to send out will be enclosed in a tag, you'll have to ensure the tag is closed. Say, for example, employee ID, right? Employee ID will have an opening tag and it will have an employee ID as a value, and you will have to close the tag. You will have to ensure that employee ID tag is closed right after the value. In HTML, it's not mandatory to close the tags all the time. XML is dynamic because it is used to transport data. HTML is static because it is used to display data. So basically, when I say it's dynamic, it's extensible. So tomorrow you could change it, you could change the format, or you could add few more elements or few more tags or add some attributes. So it's pretty dynamic, could change it. Whereas HTML is aligned to a proper predefined tags and you can't change data, or you cannot add some tags, additional tags of your own. XML preserves white space and HTML does not preserve white space. So what are the rules? Let's talk about XML rules. XML considers white space as the actual data. So whatever you're sending data through XML, so imagine you're sending data between two systems, right? So space is also a character when it comes to XML. So suppose you want to send some data that is client is typing. So of course you need to have space sent as well. You cannot have space ignored. It's actual data between two systems, communication between two systems. And since space is valid data, it's been considered as data by XML. Ordering and nesting of XML documents should be proper. As I said, you have to ensure that once you open a tag, you have to close it. There could be nesting. So there could be a tag which says employee, and within employee tag, you might have employee ID tag and you might have employee name tag. And once you have this employee ID and employee name tag, you have to ensure that you close the employee tag. So that's nesting. So you're nesting ID and name within employee tag. So yeah, this might be really confusing at this point if you have no idea about what the structure of XML is all about. But don't worry, in the coming slides we have examples and it's pretty straightforward. XML tags are case sensitive. Every opening tag must have a close tag, else XML will not correctly function. What does an XML file consist of? It has one root element, that is one tag which encloses the remaining tags. So it has one root element within which the entire content would be. And each element consists of start tag, content tag, and end tag. So there is one of the components of XML is nothing but element. Within an element, you would again have some content expressed in form of element again, which will have start tag, content tag again, and end tag. This is about nesting it. We'll see in the example, which is pretty much like readable format. XML tags are case sensitive. Opening and closing tags should be exactly the same without any difference in the case. So you have to ensure that it's been enclosed with the same case as it was started off. This is an XML. So the first thing that you see is nothing but XML declaration. The first line that you see here rather is nothing but XML declaration or prologue. So this is nothing but kind of saying what the XML is, or the format in which it is encoded. Here you could have your DTDs, which we'll see in the coming slides, but it's a kind of summarizing your XML, what the XML is all about. That's your declaration or prologue, and that's mandatory. If you don't put it, it would throw you an error. Then comes the student tag, which is user defined. You could imagine this as a user defined XML, right? And you could imagine this as data being, or you could have a service, say, for example, which is doing something with this data, maybe inserting into a database, right? So you could imagine this being sent from client, or you have a web page, say, for example, wherein you enter first name, last name, and email address of a student. And say, for example, that comes to a server and it's loaded into your database. So the root element of the document is nothing but student here. You can see a student tag. And as you can see here, it's an element which starts with angular bracket, then the name of the element, and it ends with the angular bracket. So this is student, and then the next line is about you define three tags within it. This is nothing but the content of student, and here you can see it's following the same strategy, or it is following the same structure. You have first name Henry, and it has closed the first name element. You can see the second element as last name, and which starts with angular bracket last name and end the angular brackets. Then there's actual value Lee, and you could see that it ends with a tag or with the element last name. So one thing to remember here is about start and ending of a tag, ending of an element. You can see that right after the value, the element is closed. And you can see nesting here as well. So student is a element, and you can see first name, class name, and email being nested into student element. Nested, or they are the child elements of the root element. So you have child elements defined here, and you have the last line which defines the end of the root element. Here we have a XML which has stores, or which is used to transport first name, last name, and email address of a student across systems. Let me show you the tree structure of this XML. So it could be imagined as student being the root element, and you can see that first name, last name, and email is nothing but your child, or is the child for student, since it's a root element. And you could see the values, the actual content of it. Within your first name tag, you saw the value Henry. Within the last name, you saw the value Lee. And within the email address, you saw henry123@gmail.com. So the leaf node is nothing but the content of elements, or the actual contents of the XML that you're trying to send across systems. This is pretty straightforward. Like, you could realize XML in a form of tree format, wherein your root node is nothing but element of your XML, and the leaf nodes or the leaves are nothing but the actual value stored in the XML. So let me talk about tree rules. In this given example, student is a root element, then first name, last name, and email are descendants of student. This is pretty much straightforward when it comes to tree. So you have a root node and you have descendants, and we can see from the structure. Ancestors, in this example, student is ancestor of all other elements. It's a root node, so it's an ancestor of all other elements within this tree. Now, what are XML attributes? You can have attributes which are common across, or you could have some attributes defined within an element. So here we can see that message, that's nothing but an XML with the root node messages, and you could see individual messages within. So there are two messages here within messages tag, and the first one is to Annie, and it's from John, and you have a body there, the actual body of the message, what you want to send. And you can see here there's ID, or there's something that has been provided as an attribute, which is nothing but you could see MID is equal to 1. That's an attribute. It has to be enclosed within single quotes or double quotes. So whatever you see within the element enclosed within quotes, that is nothing but attribute. It's a modifier, you can say, some kind of a modifier to your element. So attributes add more information about the element. It is adding some more information to the element. XML attributes must always be quoted. Either it should be within single quote or you could have it within double quotes. Here we have it within double quotes. What are XML comments? So to make it more readable or to increase the maintainability of an XML so that someone else can understand what you're trying to do, you could have comments put in. So this is pretty much similar to comments in other languages. The reason why we rationale behind why we put the comments. It's more about make it much more verbose and understand what tag is all about. How we comment is nothing but you have opening angular bracket, then you have exclamation mark, then two hyphens. And after the hyphen, you have the comment. And once you have the comment, you close it with double hyphen and then closing angular bracket. So one thing to note here is exclamation mark is there only when you start the comment, and at the end you don't have exclamation mark. It's double hyphen and then closing angular bracket. XML comments are just like HTML comments. Comments are used to make the code more understandable. What are the rules? Do not nest a comment inside the other comment. Okay, you can't nest it, and I don't see any need to nest it because we are just expressing it or we are just adding comments to make it more readable. So if you nest it, it would give you an error. Do not use comments before an XML declaration. XML declaration should be the first line. You shouldn't be using comment before that. Comments can be used anywhere in XML file except attribute value. So you can't put comment within an element, or you can't put it right after the element is defined. Or say for example, you have this message tag, right, which starts with angular bracket and then message, and right after the message you can't have comment. Your element tag has to be closed. After this closing angular bracket, you could put any comment, but it cannot be within this space wherein you define the attribute. So basically comment can be put anywhere, but it cannot be as attribute value. So let's see a well-formed XML, and what do we call well-formed XML as? There must be exactly one root element. An XML should have exactly one root element. You cannot have multiple. Every start tag has a matched end tag. So we saw in the previous example, like if you start student, you have to ensure have an end tag for student as well. So that's what it is about. Every start tag must have an end tag. Attribute must be quoted either with single quotes or you could have double quotes. Comments and processing instructions may not appear inside a tag, cannot be inside a tag, and you have opening angular brackets or and must not occur inside a data element. Your data cannot have this as value, or your data element cannot contain this as a part of the name of element. So let's move towards XML validation. So well-formed XML can be validated against DTD or XSD. It's a communication between multiple systems. You have to ensure client is sending data or is kind of, preparing an XML which is aligned to what server expects, right? So that's where you have DTD and XSD. Let's see what is DTD. DTD is a eBNF grammar defining XML structure. It's a normalized format grammar which defines XML structure. A DTD defines a legal element of an XML document. So it says what XML can contain, what an element could be, or what the attributes could be. And it's a legal element. Okay, so basically, when you define a DTD, you can expose a service today which could be used by Google tomorrow, right? Google can be using it for some purpose. So, this is a legal document saying that my service expects or accepts data in so and so format. So, you have to send it in so and so format for us to process it through. All right, so it's a legal document between multiple organizations. XSD is nothing but used to address the shortcomings of DTD. uses namespace to allow for reuses of existing definitions. So you could define an XSD and you could just use it, or through namespacing, you can have it within other pieces of XMLs as well. So let's see what is DTD. DTD stands for document type definition. DTD is used to define structure of an XML document. A DTD defines the legal elements of an XML document. As we spoke, it defines legal elements or which cannot be accepted. So basically, you define what your XML is all about through DTD. So you could see a student DTD here. So you have XML, which is nothing but which has student, which has first name, last name, email, and marks. All right, this is what you have within your XML. Now you define a DTD, which could be put into your doc type. So the first tag that you see is nothing but declaration, and it's linking, you're kind of tying it against a DTD that's defined, external DTD file. All right. You define this and you have a DTD file below, which is student.dtd. And here you can see that it says that within student element, you can have 4 other elements, or there's a nesting of 4 other elements, which is first name, last name, email, and marks. All right. If you, since this DTD is linked with your document or with your XML document, now if you try to add something, if you have one more element here, which could be like address, right? If you have one more element here, which is address, it would throw you an error because your DTD says that student can have only first name, last name, email, and marks. Address is not a valid element within student. All right. First name. Now let's define what can we have in first name. All right. So first name is nothing but character data. Again, last name is a character data. Email is again a string, and marks is again taken as character sort of. So this is how we define DTD. All right. So we are trying to establish the structure, or we are trying to say that student can have only so and so fields, and if there's something else, then it's invalid. So here we can see DTD contains a root element and declare the child elements. We can see here that it says student can have only first name, last name, and email and marks. It defines last name, child, element, and data from this element is parsable. All right. When it says PC data, it's parsable. Again, you have first name, which is parsable, you have last name, which is parsable, you have email address, which is parsable, and you have marks, which is parsable. All right. So what is XML schema? XML schema is used to express constraints about XML document. All right. It's pretty much, it does the same purpose as DTD, but it's much more advanced than DTD. It has much more features. XML provides more control on XML structure. A well-formed XML document can be validated against XSD. So you have an XSD, again similar to DTD, which defines the structure, and a well-formed XML should be validated or should be valid against a particular XSD. So here we see an XSD which is much more verbose, or which is much more clearer to understand compared to DTD. DTD was something like, it was not expressing to that extent, but XSD is pretty clear in terms of what the content could be. Again, it defines the root node and declares the child elements. So here you can see that XSD is defined in a form of XML itself. All right, it follows the same pattern as the XML. So it says element, which is a keyword. All right, element is a keyword for your XSD, and you have student as an attribute. So this, you could realize XSD, as I said, as an XML itself. It's a valid XML rather, which says that you have an element with name student. Now what can student hold is again a sequence. When you say sequence, it has to be in the same sequence. Break the sequence, it's again going to be invalid. Then it says first element first, child element within student should be first name. The next one to follow should be last name. The next one should be email, and the last one should be marks. All right, and it defines what type this particular elements hold. So first name is a string, Last name is a string, email is a string, and marks is a string as well. So this is how it is. You define a structure to the XML, and you have to ensure for your XML to be valid, it has to be valid against this XST. It's just XML schema descriptor. So what's the difference between DTD and XST? DTD stands for document type definition. XST stands for XML schema definition. DTD is not extensible. XST is extensible. DTD provides less control on XML structure. XST provides more control on XML structure. DTD does not support data types. XST supports data type. We saw the data types like string and stuff, which is like it's supported just in XST. You don't have DTD supporting it. DTD does not define the order of child elements. As we could see, it just says that you could have 4 elements within, but it doesn't have any specific order as such. Whereas when it comes to XSD, you could define a sequence, right? As we saw in the previous example, we said that the first one should be the first name, then the last name, then email ID, and then marks. So you could define the sequence in which your sub elements should occur. XML CSS file. CSS is used to add more styles to the XML document. So if you want to color code it or do something, that's when you use CSS, pretty much similar to HTML document. So here we can see that you could define student, which has got a background color of pink. Then you have first name, which has different font sizes here, first name, last name, and email ID, and marks, which has got different font sizes. So we want to have font size of 25 for this child elements. We want to display it as a block, and color as white, and the margin left as 50 pixels. All right. When you have such thing defined, if you want to link it up, or if you want to link CSS to a XML, you need to have a XML style sheet tag defined, and you put type as text or CSS, and you put href as your CSS name. To make the changes in the styles of the XML file, CSS file is linked to XML file through this statement. So this is how you link your CSS file to your XML file. Now, what is XSL? XSL stands for Extensible Style Sheet Language. XSL navigates all the nodes and elements and display XML data in a particular format. All right, it's basically for parsing sort of. It navigates through all the nodes and elements. Queries can be specified in XSL. If you want to query some particular data, like we had message, this thing in a couple of slides back, we saw multiple messages within message, right? So if you want to read some messages, extract the messages that are sent by the users, you could query it out using XSL. It displays data on the browser as per the format given in the XSL file. So let's see what is XSL file all about. Okay, so here what you're doing is nothing but you're extracting data. All right, you're extracting first name. So the first name here would be taken from your student and would be displayed here. And again, the second one, you have last name. You select the last name. Particularly, this is acting upon student.xml. All right. How do you link up XSL to XML is pretty much similar to CSS. You have style sheet and you have type as text slash XSL and not CSS, right? And you have href as student.xsl. So that's for XSL. And again, let's see what's the difference between CSS and XSL file. CSS files are easy to understand. XSL files are difficult to understand. CSS is less powerful than XSL. CSS is specifically for display, right? Changing the font size, changing the colors, background colors, and foreground color, and everything. XSL is more powerful than CSS since you can extract data or do something with it. Basically, it's a processor. You actually can process the XMLs using XSL. CSS does not use XML notations. XSL uses XML notations, which helps in writing code. CSS can be read by modern web browsers. XSL is not supported by many web browsers. Now let's talk about XML parsers. Okay, so XML parser is nothing but you parse through. You have an XML and you want to read data from it, or XML parsers could be used for writing the XML as well. Okay, creating an XML could create an XML using XML parsers as well, or you could read through the existing XMLs. So an XML parser is a software library which provides client applications to work with XML document. An XML parser is used to check whether the document is in well format or not. It is basically used for compiling or parsing your XML as well. It is used to validate an XML document. And parsing XML refers to going through XML document to access data or to modify data in one or the other way. All right. You could actually read through the XMLs, or you could extract data, or you could modify data using XML parsers. What are parsers? Here you could see XML document, right, being sent to the parser. Parser is nothing but API. So you send the XML, the source XML or the XML that you're trying to parse is going to be sent to the XML parser. And this API is going to be used by client application, right, to parse the XMLs. So XML parsing could be broadly classified into two different types. One is object based and one is event based. All right. Object based is nothing but document object model, or it is also known as DOM. Event based, we have two different parsers when it comes to event based. One is SAX and the other one is STAX. All right. So let's talk about object based model. DOM parser, it stands for Document Object Model. It is an object-oriented representation of an XML parse tree. So remember we saw an XML and we parsed it into a tree-like structure wherein your root node of the tree was the root element from your XML, and we had all the elements, and at the end the leaves were nothing but the values or the data that the XML stores, actual values, right? Or XML stores or carries rather. So that's what tree is all about. It defines the standard way to access and manipulate documents. DOM is a common way for traversing the tree. So as we look through the examples, you should get fair idea about it. Creating an XML document using DOM parser. So what is required to use DOM parsers? How do we do that? First is you have to import all the parsers. You have to import all the classes that you have within javax.xml.parsers. These are all import statements that you have. You have to import different packages, which when you use IntelliJ or Eclipse, it would prompt you to import it. It would suggest you to import it. So you did not actually write these import statements, but it's very important to understand what we are trying to do here. So these are different packages that we are trying to import. And as you could see, all your XML related classes are put into javax.xml.transform, or basically javax.xml package. So once you import it, you can start using the classes within. The first thing that you do is when you generate an XML, you have document builder factory. So you have document builder factory.new instance. You create a new instance of it, and you get document builder factory, that's the instance of it. So now with the document builder factory instance that you got, you would create a new document builder. Okay, so this is a factory design pattern. We have a design pattern in Java, and document builder factory is nothing but it's following a factory design pattern. Right, you don't have to think much about it, but basically what we are trying to do is instead of creating the instance of something on our own, which is like we usually do with new and the class name, right? Instead of doing it on our own, factory design pattern is nothing but the creation logic is written within a class which is not exposed to you. So you need not create it. There's some class which creates instance for you. All right, and that is nothing but a factory class. Then you create a document builder. So it's nothing but f dot new document builder. Okay, you handle the exceptions and everything here. So now let's start with creating the actual document. you have the root element as students, all right? And within student, you have student. Within students, you create student, and within student, you have like first name, last name, email, and marks. And you could see first name put as Henry. So how do you create element? Is nothing but using doc.create element. How do you create text node or the actual value that you have within your element? You would do it with create text node. And you could nest it using append child. So basically you have first name appended to T1, which is nothing but this one, right? T1 is appended to the first name element that you have. T2, which is the text node, which is holding the last name, is appended to the last name element. T3 is appended to the email element, and T4, which is your marks, is appended to marks element. So basically, this is how you make nesting of your nesting within the XMLs. All right, so once you create this document, you append all the childs and everything. You create a well-formed document here, or you create an XML here, and all the XML that you would get is within this doc. Since we are creating element, you could see here, we are creating elements within doc, creating elements and text node and everything within doc. So at the end, once you have all this done, you would have a well-defined XML stored as a form of document class. So we want to print this particular document in a text format, right? Which could be readable by us, or we want an XML out of it. So that's when we use transformer. So there's a transform factory dot, again, since it's a factory design pattern, it's exposing a method which is nothing but new instance. So you create a new instance of transformer factory and you create a new transformer. So at then what you get is nothing but a transformer. And what are we trying to transform is nothing but we are trying to transform the object or the document object that we created. We are trying to transform it into a human readable text file or the XML file. All right. So that's a transformation that we are trying to do here. So here you could see that you transform it, t.transform, and you pass the document object that you created and put the element into element and text nodes and everything into, which is holding a valid XML. You're trying to transform it into an XML file. So how you do that is t.transform. Then you have the new DOM source and you specify the instance of document which holds your XML. Then you have stream result and new stream result class, which takes file output stream as its parameter. So you have to pass the parameter where you want to write this XML to. And when you run this, at the end, we are just printing that XML file is being generated. The first thing that we do is we are creating a document, and using the document, we are creating elements the way that we want. So in this case, we have a students as a root node, and within students, you have student, and within student, you have first name, last name, email ID, and marks, right? We created the structure till here. And as you could imagine, this is just dealt in the form of object, right? Which is stored in doc. So now, since you want to write it into a file, which is into a human readable form, or which could be passed across network, you have to transform this into a XML file, which could be read. So that's what we do here through transformer. We are transforming your document or the XML, which is in the form of document, into a file. So let's see this program. So in the meanwhile, we can do one thing. I'll create one more directory here, Edureka XML. Okay, and we don't have any files within. Yeah, let's hold on for a minute. Yeah, it has come up. All right. So it's the same program that we spoke about. So I have loaded into my IDE. So we do the same steps here. We create all the elements, all the required elements and stuff. So we are writing it into a file, right? So you could have your own file here, whatever file you want to write into. Okay, so I write it into the directory that we created, which is nothing but edureka XML, and we are writing the XML file there. All right, so let me execute this program. It's building it, and if it's generated, you should get XML file generated at the end. So this is about using DOM. All right, so when you say DOM, it's nothing but document object model. It's building yet, so hold on for a minute. Okay, let's see, I think it should come up soon. Right, I think it's coming up. All right, so we have this program here, which is kind of creating XML document. This is same as what we spoke in the slide, right? What I walked you through. So basically you have students, you are creating students elements. Within students element, you are going to have student and then first name, last name, email, and marks. All right. We are going to create a text node within this elements. So this is nothing but your first name, which would go into the first name element. This is the last name, which would go into the last name element that we created earlier. Then we have email and marks going into a respective element. All right. So basically we are nesting it here. At the end, we have the transformer, which is kind of taking the document and converting it into XML file that we want. So let me go and delete this off and run the program. In this folder, we don't have any file, right? I run this program from here. So you could see that it says XML file generated. All right, so let's go to the folder and see, yeah, there's a file that's generated, that is students.xml. Now I can open this with any tool. Say I open it with Notepad and I see something like this, right? Now I want to format this. I want to format this into, because this is like one single string, which is big, right? So if I want to format it, we have tools that are online. Even you could format it online, all right? So I put this and I say I want like 3 spaces per indent level, which is good. And I format it. Okay, when I click the format, you can see that it formatted the entire XML for me. So the basic thing that it's doing is just about formatting this XML, all right? This is much more readable, right? After formatting, you can see that it's readable. You can see first name as Henry, Lee, and Henry123 at gmail.com, and you have 70 put in here, which is what we expect out. Okay, so we saw this output after running the program. Now quickly, let me run through what's DOM parser and how do we use DOM parser for parsing an existing XML. All right, so these are the classes that you need to import, which would be suggested by your IDE as well, either IntelliJ or Eclipse. So you have document builder factory, you use the same thing, get the new instance from the factory wherein you get an instance of document builder factory. With this, you create document builder. And once you have the document builder, you parse it, invoke a parse method on the document builder and pass the XML file name. All right. So whatever XML you want to parse, you would send it across. Now, once you have this parsed, if you want to get the node name, if you want to display something like what's a root element within your XML, you could do something like this: doc.get document element and get node name. So this would basically display the first element that you have within your XML, which is nothing but the root element, right? You could read based on the name. You have the tag names or element name. So you have methods like get elements by tag name, and you could give the name of the element and it would retrieve it as a node list. Now you will have to iterate through this node list to display the contents of it. All right. So here what you do is you iterate through it. So when you get a node list, basically you would get list of nodes. All right. So now what we are doing is we are printing it out one by one. We are printing the nodes or the contents that we have within one by one. So in this case, you can see that when you do student.get elements by tag names, and you can see student here. So this would give the number of students that you have within a document. In the previous example that we took, the number of element is just one, right? We just had entry for one student. So it would iterate just once. In this case, it would iterate just once, all right? And what we are doing here is we are kind of taking again element by tag name, and these are nothing but your actual values or the first name, last name, email, and marks. This loop is going to run just once since we have only one student. And this is how you display the content of an XML. So basically what we are doing is we are parsing it. When we say parse, we are trying to get data or we are trying to load data into DOM or document, and we are printing it out. Why do we have parsers? Is nothing but to retrieve data. If you want to query out particular data, you could do it. You could write some logic to read out a particular data from an XML. Say, for example, you might have a long XML and you want to read data pertaining to a student Henry. So what you could do here is you could write some logic here saying that if student is equal to Henry, then return marks secured by Henry. So that's why we have XML parsers in picture to have it loaded into memory and play around with it. All right, so let's see the example of XML reading using DOM. I give the path here as C. We give the same file, all right, Edureka XML student.xml that we created. Or let me do one thing. So I create one more student here, say for example. Just for simplicity purpose, I'm just putting test last name as the last name, test email, and I put test marks. All right, so these are the values that I've put for one more student that I've created, or maybe I'll put this one as just to be consistent. So we have two students now within. So first one is Henry Lee, and the other one is like we have created a test student. Let me show you when we run this program. What we are trying to do is we are going to read this XML that we have created, and it's going to parse it. Parsing is nothing but it's going to display the contents of it. So it's going to loop through, it's going to understand there are two students within, and it's going to display first name, last name, email, and marks secured by each student. All right, it says the processing instruction. Okay, we can see the output being displayed here. All right, so we can see two students here, the current element, Henry Lee Com, henry123gmail.com and 70. And there's one more student that we added directly into the XML, and we can see it displayed as well, saying that test first name, test last name, test email, and test marks. So that's how we parse it, okay, using DOM parser. And what DOM parser does is nothing but it creates a tree. If you remember, I said it creates a tree-like model that was there in one of the slides that we discussed earlier. It creates a tree-like structure with a root element as your root node, and your leaves are nothing but these values, Henry, Lee, and all this stuff. Whatever is being displayed here are nothing but leaves of your tree. Advantages and disadvantages of using DOM. It is preferred when we have to randomly access separate parts of the document. So if you don't want to do it sequentially, it's preferred that you use DOM. It supports both read and write operation. So we created XML using DOM and we read XML using DOM as well. So the first example that we took about creating a student.xml was using DOM as well, since it was document. Remember, we created object of document and then we inserted all the elements within. That is nothing but DOM. It supports both read and write operation as we saw. And what are the disadvantages of using it? It is slower than other parsers since it has to create tree. So it's a one-time activity that it does. So remember in the second example that we took, we saw parse here, right? There's parse here, document builder dot parse. This is going to take a lot of time because it's going to create a tree. If your XML is big enough based on the size of the XML, it would take time because it's going to create tree. So parse is something that is going to take time. And it's not very memory efficient, since you could imagine if you have a big XML. So XMLs in general are like, it could have like 100 million records within. They are humongous. They are not small XMLs that we are dealing right now. It's coming from different systems, right? So you could imagine their system pushing data in the form of XML and sending it to some other system to process it. So it could be humongous, could grow up to like 100 million records or something of that sort. So imagine that you want to load all this into memory, right? And create a tree. So this parse method is going to take a long time to create a tree. And the other thing is it's not memory efficient because it's going to load this entire document into your memory, right? Which is going to take like a lot of GBs of memory, right? To load it. So it's not pretty memory efficient when it comes to parsing using DOM. So that's the reason we have other variants of parsing, which is not document object model, which is basically event based. So we have like two parsers, event based parser. One is like for push parsing, it is SACS, and whereas for pull parsing, it is stacks. All right, so we'll just go through what is SACS parser and stacks parser. SACS parser is nothing but it stands for Simple API for XML. SACS parser reads XML files sequentially. It's a event based. All right. So when I say event based, what happens is when a parsing event occurs, the parser invokes the corresponding method of a corresponding handler. So basically, you define a handler. You say that if I get so and so tag, or if I get start of a element tag, go to this particular handler. All right. And these handlers are nothing but user defined handlers. So you could say that when I get a start of a element tag, go to this handler and do something, right? It could be as simple as printing it, or it could be as simple as filtering it. So it's up to you to write the logic for the handler. But what the framework does is nothing but when you see your opening tag, it would give a call to your method, all right, your handler method. SACS parser is used when we have a large XML document. As I said in the previous example of 100,000 records that you have within your XML file, document object model is not that efficient because it's going to load everything into the memory, which is going to take a lot of time, as well as memory, which is going to consume a lot of memory. So it's not good in terms of time and space complexity. Whereas SACS does a good job when it comes to large XMLs, when it comes to parsing large XMLs, because it's not storing or it's not parsing everything into a object in one go. It's a event based. So basically you would see that it sequentially goes through the XML, and as and when it sees something, right, start of element, start of an attribute or anything of that sort, it would give a call to handler and handler would process it. So basically it's not storing anything, it's not retaining any information into memory. It is just calling the event handler and just leaving it right there. So since it's not consuming memory, it's good when it comes to large XMLs. But it's not good for random search, right? Random parsing because it goes sequentially. So for SACS parser, again, you could see the files present in javax.xml.parsers.sax parser. Earlier it was document, and here it's SACS parser. Again, you could have this imports done by your IDE. This is what event handler is all about, right? So you are defining an event handler here, which is nothing but a default handler. So your XML reader using SACS is nothing but a default handler. Okay, is a relationship, is a default handler. You extend it. You're extending default handler, which is maybe an internal interface to your SACS parser. Once you extend it, it's not an interface, sorry, since it's extending, it has to be class, all right? It's a class. So the default parser or the default handler would have these methods within, which is nothing but start element. You have characters, you have end element and end document. So these are the methods within, right? When you give a big XML in this example, or when I say this one, so when it comes to student, which is your root node, it would go to start document. When it reads this XML, it understands that it's a start of document. So it says document begins here. It would go sequentially. This parser, what it would do is it would read this entire file and it would go sequentially. When I say sequentially, then it would understand that there's an element again, and it would give a call to start element. And here what you could do is you could print it. So what we are doing here is nothing but we are printing the XML document using SAX parser, all right, which is event based. Whenever a particular event occurs in your XML, it would give a call to the particular handler. So whenever there is a start of document, in this case, student is a start of element again, which would go into start element, all right. When does it come into characters is nothing but when it encounters Henry. When it encounters Henry, it would go into characters. All right, you see a characters method here. It would go into characters and you can see that it's a character array. All right. So here it would print the entire array, which is nothing but the value Henry and all these leaf nodes, all right? Henry, Lee, and whatever values that you have would be printed by this characters method. Whereas the tag names would be printed by your start element and end element. This would be your end element. All right. So this is pretty much like it's a event driven one. Whenever it encounters something, framework gives a call to a particular method. And this method is user defined. You could do whatever you want to. So this is how you create a instance of it. So you have sax parser factory dot new instance dot new sax parser. You create the instance of sax parser. Now you parse it p dot parse and you provide the handler as well. The handler that you have provided, which is nothing but XML reader using sax. That's your handler. So you have to create the instance of it and pass it over. Let's see this program. And also you could see it is reading students.xml, right? So I'll have to change this name to C Edureka XML. All right, so let's run this program, which is the same program that I spoke about in the slide, which is event based. You could see methods implemented here, and you could see it extending default handler. All right, so there's a default handler, there's start document, basically start document, and everything is coming from your default handler. All right, and in the start element, we are just printing it, characters. And again, when it comes to end, we are ending it. And when it comes to end of the document, we are just printing saying that document ends here. All right, so we are reading the same student file and this time it's using sax. So you can see here when it encountered start of the document, it printed document begins here. Then you could see elements printed sequentially. So this is what it is. This is like event driven, right? And at the end, when it reaches the end of the document, you can see document ends here being printed out. So basically, this is, as I said, event driven and this is sequential, right? It goes line by line. So if you say you have like 100,000 records within your XML and say the last entry that you are searching for, it's going to go through the entire XML till it encounters the last element. When it comes to random search, or if you want to search randomly, it's not well suited. But when it comes to big XML, it's much better than DOM since it's not loading anything. So it's not keeping anything into the memory. It's just parsing it, it's just printing it out and it leaves it right there. So what are the advantages of SAX? It is simple, it is memory efficient. SAX parser is faster than any other parser. It handles large document. We spoke about all this right here. Disadvantages of using is client will be unable to understand the whole information because data is broken into pieces. So it's not storing it in one place, it's broken into pieces. It's not even storing it into memory. It's just flushing it off. It's just writing it and leaving it. So what's the difference between DOM and SAX parser? DOM stands for Document Object Model. SAX stands for Simple API for XML. DOM reads the entire document. SAX reads node by node, which we saw. Sequentially, it would go. DOM is useful when reading small to medium size XMLs. SAX is used when big XML files need to be parsed. SAX is good for big, and this one DOM is used for small to medium size. DOM is tree-based parser. We saw it creates a tree, and SAX is event-based parser. We saw how it has event handler, and you saw that it calls a particular method based on the event that it encounters. DOM is little slow as compared to SAX. because it has to create the